Should have asked, but I was like, so tired. So by the time others trickle in, I just like yesterday some things that I said I was not very clear about saying these things. So I got then stuck into some sort of a loop. So I wanted to at least complete this loop and try to answer it in a way which I have at least formed the ideas properly. Okay, so the question was about whether there is gravity once you go to space, right? And oftentimes you see these astronauts which are freely floating around and so on. So you think that there is no gravity, but that is not the case. So of course, gravity is always there. It's just that you don't feel it if you are freely falling. So when you are freely falling down, it does not mean that the gravity is not there. It's just that you don't experience any forces. That's all. Okay. And there are of course mathematical ways of showing this, which I got bogged down in yesterday. So that's the reason why I was trying to say this. Okay. So so in order to understand partly this phenomena I told you about, this lift, and the lift starts accelerating, then you feel a different weight, and it starts decelerating. You feel a little bit different weight. Right? So how much weight you feel on any surface, right? It is related to this normal reaction that is given by this surface. And so how much is that reaction is what determines how much, like how heavy you feel. And so let's suppose there is a person here standing on the ground. Then if you look at this person, then there is a weight which is acting downwards, right? It is weight. And then there is a normal force given by the ground. And they are balancing each other. That's why this person is not like flying off or accelerating here. Right? Because the total force acting on this will be m minus mg. And if the two of them balance, then the person stays where he is. Or if he had some velocity, then he would be falling with the same velocity. But the person stays at the same place when these things are balanced. Now imagine, for some reason, this person was not starting on the earth, but instead was in some lift which is accelerating. And the lift is accelerating with, let's suppose, an acceleration of p. So this person is actually falling with an acceleration. In that case, what it will mean is that these things are not balanced. the gravitational force is more than this normal reaction that the lift surface is giving. So that's the total force. And this is equal to mass times the acceleration. Because this is the acceleration with which this whole lift and the person is falling down. So if so you can calculate what this normal reaction felt by the person is, right? So this is mg minus x. So if the acceleration is smaller than g, right, but still substantial, then it means that the normal reaction is now not equal to mg, but a smaller quantity. So you feel less weight. And as soon as this acceleration becomes exactly equal to g, that's when you don't get any normal reaction from that surface. So if both the lift and the person are falling down with the same acceleration, you don't get any normal reaction. And this is that feeling of weightlessness. So that feeling is related to this normal reaction. But that does not mean that gravity is not active. So gravity will always act wherever you are, however far you are. Gravity will always be there. That's not something that you can get. It's just what you feel depends upon how you're accelerating. If you're accelerating with the same gravitational acceleration, then you feel as if you are completely weightless. But if you're going with an acceleration which is smaller, then and there is some surface which is causing this acceleration to be smaller, then you feel the pushback from this surface. That is where you feel that. Okay, so anyway, by the time everyone was coming in, I at least wanted to clear it. There are other questions which were also asked related to like things that students ask, which is if you are on the surface of the earth, you measure your mass or weight, and you get some number, and then you go to the moon, you want to do the same thing. It is commonly known that the gravitational acceleration that is there on the moon compared to that on the earth is like 1/6 of that on the earth. And so you will measure a different weight. Right? But when people say this, then they interchangeably use the terms mass and weight. Okay? So weight is a force, which is mass times the gravitational acceleration, while mass is just the mass of that object. And so when you stand on a scale, you are trying to measure the mass because someone has calibrated the scale to the gravitational acceleration of it. So if you take now this same scale, which is calibrated to the gravitational acceleration of the Earth, and go to the moon and stand on that same scale, you will register, or the scale will tell you that you are weighing 1/6 of what you would weigh on the Earth. But if you have a balance, weighing balance, right? The simple things that some of these bajiwalas have, right? That one compares the weight, or compares the force exerted by Earth on one object and the other object. So it is trying to balance things. So now if you take that balance to the moon and now try to do the weight, you will get exactly the same weight that you get on the Earth, because you are doing a comparative thing. You are comparing the force here and the force on this standard object that you have labeled. So you have to be careful about how you are measuring things.
That is mass, right?
You are comparing the masses here.
Yes.
And also the forces, because both these things are at the same place. While there, when you are standing on a balance, like what will happen is, again, like you will stand on some platform, and the platform may have some spring. Okay, and this is the ground. Okay? So when you stand on it, you're putting some weight on this platform, some mg weight on this platform. Then what happens? Because of this weight, this spring compresses. Okay? And the more you compress the spring, the larger force you will get from this. Any of these springs, if you compress more, you will get a larger force. So that force is actually balancing the force mg given on this platform. So I'm just now considering only this platform. Platform is getting mg, and then there is the force from the spring, which balances. So depending upon how much compression happens, that's how you can calibrate what that weight is. So that's how these things work. So now if you take this, so it requires you to know what is this exact g and how it compares to the distance that by which the spring gets compressed. So this one requires a calibration to this gravitational acceleration.
How does a calibration happen?
How do they do it?
Yeah.
They say that, okay, I will take a 1 kilogram piece block, I will put it and see how much it compresses this spring.
And then
So, like you do 5 kilograms, you see that, okay, it got depressed this much. You do 50 kilograms, it got depressed this much, and so on. So then that will allow you to calibrate. But how much the depression happens will depend upon the gravitational acceleration at different places. So you go to the moon, then you will have to change this calibration.
But because it is spring, no? It's pressure on the spring. Why gravitational forces coming into the picture?
No, see, okay, so let's back off a little bit. So all of this system, when you analyze, you have to separate out everything. Okay? So there's the man, there is gravity acting on the man.
That's the force.
And then there is a force exerted by this platform on the man. So this force is called the normal reaction, right, from this platform. Because the man is not moving, this end should be equal to it. Or not accelerating, I should say. Then let's take the platform. Okay. So whatever force was exerted by the platform on the man exerts the same force on the platform, but downwards, equal and opposite. Right? So that is this normal reaction. But this normal reaction was also equal to mg. That's why I did it. And now this spring is now exerting a force on it, depending upon how much it gets compressed. So this is where the gravity comes. It is through the normal reaction, but the normal reaction is equal to.
Sir, I'm a little bit stuck in that gravity in space.
Yeah.
So in International Space Station, when the people are working,
yes,
and
yes.
they feel the weightlessness.
Yes, yes.
So explaining these to students, even for 11th or 12th grade, I find it a little difficult. It's just free fall and all that, saying that term and actually explaining it on the basis of the centripetal force, centrifugal force.
No, so it actually, so the explanation that I gave for the lift is the exact same thing that happens even for people who are going in orbit. Okay, it's just that in one case, I mean, there is an acceleration like this, but whether you are falling down like this or you are going in some circular motion does not matter.
It's just
so
about that.
Even if it is going in a circular motion, it is still freely falling. So the moon is still freely falling onto the earth.
So it's
just
about
that it has some velocity, so it misses the earth.
It's constant free fall.
It's constant free fall. Yeah. So moon is in constant free fall around the earth.
So are all the satellites which are revolving, artificial satellites.
Yeah. Long as you are accelerating with the same acceleration as the gravitational, as the gravitational acceleration at that point, anything that is on it will not experience any force.
So weightlessness is, I mean, there it is just.
I mean, the weightlessness is because that normal reaction is just not there. So if you are standing on that on the floor of the space station, you will not feel any normal reaction. That's the reason why you start to float around. Now you give some kick, then you will just bounce. As long as you are freely falling, which means that your acceleration of your system is same as the gravitational acceleration at that point, then you experience this weightlessness.
Forces are balanced, one way or the other.
Yeah, I mean, so there are different ways of looking at it. You can see what the system is doing, or you go into the frame of the system, and you can use this. There are different ways of telling it. I told you in the manner of this normal reaction. What is happening. So the normal reactions go.
For the revolution, we can talk about the gravitational force which is causing the centripetal action.
Yeah,
this-
that is causing exactly. So this motion, circular motion, involves an acceleration which is exactly equal to the acceleration produced by the. So if you want to go in a circle, then you need to be accelerating at a certain. You need to be accelerating in a certain manner, and that acceleration is provided by this gravity. It's exactly balanced, and that's the reason. Like when you are falling exactly by the same acceleration as that of gravity, then you are not feeling any normal reaction. So it's the same. It's just that in one case you are falling down straight to the earth, and in the other case you are going. Okay, so maybe we can get started now. We are already a little bit late, I suppose. Yeah, that's right. Okay. So today, what we are going to do is talk about the life cycle of stars. Okay, so this is a chapter which may not be there in all curricula, but at least Maharashtra State Board does have it. And since students are usually curious, then, I thought that we should at least cover this thing. It's also very fascinating to understand what these stars do, and when we see them, where is all this energy that is coming from? If you look at life on the Earth, right, it really depends upon the sun. If the sun were not there, we will not get a lot of energy. In fact, a lot of the energy that you see around is coming from the sun. The energy that allows you to run around, do work, just walk, and so on and so forth. It is also indirectly coming from the sun. So when you think about it, you are eating food, right? And so some of you may be vegetarian, some of you are non-vegetarian. If you are non-vegetarian, then even those animals are eating some food. And that food is being made by plants by using the energy from the sun. So our life critically depends upon the energy from the sun. And so that's why it is important to understand where these things, what these stars do, how long they last, etc. So when we talk about this life cycle of stars, we try to understand where these stars are formed. In places like these. Okay? This is an image taken by the James Webb Space Telescope. It was one of the first images that was taken by this massive telescope that is sent in space. And then towards the end of their lives, some of the stars turn into black holes. And so we'll try to also touch upon that. Okay? Not all of them, some of them. So let's see if this is ahead or not. So the first question is, what do we need in order to form a star? So a star like the sun is actually made up of a lot of gas. And typically when we talk about gas, we are used to gas on the Earth, right? I mean, our atmosphere has lots of gases, and we feel that, oh, okay, how can the sun be made up of this kind of a thing? But it is. Okay, so it is made up of gas, mainly, predominantly hydrogen. There's helium also inside the star. And then there are some other trace elements which you can find. But mainly it's predominantly hydrogen and helium. In fact, when the universe begins, you end up having a lot of hydrogen atoms around. And you also form some of these helium, actually I should say hydrogen nuclei and then helium nuclei. Okay? At some point of time, they also gather the electrons around and become bound and whatnot. But the universe is predominantly made of hydrogen and helium in terms of mass. Now, this gas, it collates into these big giant molecular clouds that you see here. And these giant molecular clouds are nothing but just collections of huge amounts of gas that is present. And when you have a lot of gas, what happens is it contracts, it starts to contract because of its own gravity. These gravitational forces start to make it smaller and smaller and smaller. And then it forms these kind of structures like this. So this thing is called like the pillars of creation. because it is one of the sites where you usually form these stars. There's lots of gas that comes in and forms these stars. You can see this is the Orion Nebula. Unfortunately, yesterday was cloudy, and so we could not show it. But it looks really beautiful. I mean, even in the telescope, if you come later on to some of these stargazing sessions when there are no clouds, you should try to observe this. You'll see all this kind of a nebulosity which is present around. So a lot of light beams floating around. Yeah?
Is the telescopic picture?
Yes, this is from HST, I think, the Hubble Space Telescope. And so, as I said previously, they take pictures in different colors and then they compose it. If you just go and look at it through the telescope, you will see it grayish.
Sir, you said that the gravitational force, the gases come together, right? But usually on Earth, you don't see that. Usually gases, the property is that it will keep on expanding.
So the amount of, yes, that's right. So it all depends upon the amount of this gas that you have and the temperature at which this gas is. So in principle, to actually cool down, you need to have smaller and smaller temperature. That is true. So the thing that you are saying that gases expand and so on, that is because of the pressure. The pressure is coming because of the motions of these molecules, and these motions are coming because of the temperature of the gas. So as long as the temperature is high, it will keep on expanding, or there will be pressure which will not allow the gravitational force to contract. Okay? But if there is sufficient amount of this gas, then the gravitational forces overcome these actions due to pressure, and they keep on collapsing. But you do indeed have to lose a lot of energy before that thing starts to. So when you take these clouds, in fact, many of these clouds will not form stars just because they cannot compress enough because of their temperatures. So if the temperatures are low, then they can compress. And after they compress, they again start to heat up.
Again,
Just like as you are, when you try to compress the gas, you again start to heat up these particles.
So can you just explain the light which is emitted?
We'll come to that. Okay, so if you want to understand like lights of stars or the formation of stars in a nutshell, it is always a competition between gravitational forces acting to try to compress things. Now, something or the other has to balance it out. Only when these things balance out, then you can form a stable star. If there is nothing to balance out, then you keep on becoming smaller and smaller and being compressed into smaller and smaller. So initially, as I said, it's the temperature of this gas itself which prevents the collapse. But that is not good enough to form a star. Okay, so it keeps on radiating energy and it becomes lesser and lesser hot. And then again it starts to compress because of gravity.
Gravity is more stronger all the time.
If you have more and more mass, then of course things will be, it will be having more and more gravitation. So it is the self-gravity of this giant molecular cloud which starts to form these kind of structures called cloud fragments. Okay, so here there is a numerical simulation which is showing how you can form stars and star clusters within this giant molecular.
Could we accept the word self-gravity? Self-gravity, the word, no?
Yeah.
Very
Self-gravity of the cloud. It's not the self-gravity.
No other body is there.
It's an ideal word for you said.
Self-gravity,
Yeah.
is that a correct word we use?
Yeah, so that's what I'm saying. It's the self-gravity of the molecular cloud, which means there are multiple different particles which are also pulling that cloud together.
Interparticular forces
Yeah.
of
So it's not like you need some gravitational force from the sun in order to get this to collapse.
Gravity itself it
Instead
generates.
of self gravity, we can use pseudo gravity.
Pseudo.
But,
No, it is gravity which is doing this.
No, he's
Now,
asking
is there
you,
any-
the term is in a circle.
It's falling, it's basically crumbling under its own weight. That's the reason why it is called self.
Origination of gravity so far is a big question mark, correct?
Observation of gravity.
Origination of gravity.
Origin of gravity. Oh, okay. We can get into those details, but then I will not be able to cover everything.
Okay, that's okay.
Okay. I mean, we will have to talk about general
No,
theory of relativity.
okay. So my question that I posted is
No,
why
no,
you use the
So
self?
the reason, that's why I'm qualifying that statement. When I say self-gravity of the molecular cloud, I mean these molecules here, or these gaseous molecules here will be attracted by these gaseous molecules, which are in the same cloud. That's what causes these things to come closer and closer. Is that okay?
So, PC क्या होता है?
This is a unit of distance called parsec. So again, if I try to go into this, it will take more time. But okay, maybe I can explain. It's fine. So if you hold your finger in front of your nose, okay, and you close one of your eyes and then the other eye, you will start to see that this finger is actually moving with respect to the background. Right? So depending upon how close you keep this finger, if you make it further and further and further apart, this difference reduces.
Correct.
Okay? So if you are closest, it is really large difference. Like I'm seeing my thing pointed, my finger pointed towards this lady, and then when I close this eye, I'm seeing here. Well, instead, if I keep my finger here, then it's a small difference, maybe one chair, not any more difference. Okay. So this thing is called parallax. So if you are seeing things from different vantage points, they appear with respect to the background at different angles, depending upon how far they are. So you can do the same thing for stars. You take these stars further and further away, and you observe once when the Earth is at this point in the orbit, and then the next time when the Earth is, say, 6 months apart. And what that does is that the location of these stars with respect to the background stars, which are even further away, that seems to change. And the amount by which this changes depends upon the distance.
So can you repeat everything again?
Yeah.
Can you repeat these things again?
Yes. So
Yeah,
from where?
so
nose?
No, from the stars.
Okay, from the stars. Okay,
Stars.
good.
So with parallax method, we can get the distance between two objects.
Yes. We are going a
Distance
little
of
bit
that
further from the
Distance of that
discussion that
object.
we want, but it's so this is the Earth and the Sun. Let's suppose there is a star here. Okay. So just like so, consider this to be your finger. Okay, and the two eyes to be, one is this eye, so I2 and I1. It's the same thing, right? Now I'm observing this star with respect to the background. So I see it somewhere in this direction. When I'm here, I see it somewhere in this direction. So this difference in the angle that you see, by which the star seems to have moved, even though it's not in reality moving,
Correct.
it's called a parallax. So this is this parallax, the same thing, same principle. So depending upon how far you are, this parallax is smaller, just like you moved your finger. If it was closer, you saw a large angle difference. If you moved it further away, you saw a very small angle difference. Right? So you can use this parallax in order to measure the distance. So the distance at which the parallax is equal to 1 arc second. So what is an arc second? You know what is a degree? You make 3,600 parts of a degree, that is an arc second. So if you remember your protractor, it goes from 0 to 180. You take 1 degree and you make 3,600 parts of it. That is 1 arc second. Okay? Very small, 1 arc second. Arc second.
It's a degree of
It's like seconds, right? So 1 hour consists of 3,600 seconds. So 1 degree consists of 3,600 arc seconds. So it is this small parallax, which when the distance is 1 parsec, that's when this parallax is so small. So this one is 10 parsecs, which means that the distance is so far that it's 1/10 of the arc.
One parsec equal to 3 times of IUCAA.
No, 1 parsec is equal to 3.27 light.
So that parsec is what? Upsec?
Huh?
Parsec is? What is the
Path length is,
Light years.
the parallax is equal to 1 arc second.
1 hour?
If you move further, then it becomes lesser.
No, you mean parallax is an angle.
Parallax is an angle. This
That's
Parallactic angle.
So
This
1
is
hour
the-
sec is 1
1
hour.
arc second is the distance at which the parallax becomes 1 arc second.
Okay, so 1 PC is
1 parsec is that distance.
okay.
If you put it at 10 parsec, now the angle will be even smaller.
because it's
So 10 parsecs does not mean 10 arc seconds, of course, right? 10 parsecs means the angle will be 10 times smaller. Okay?
So 10 parsecs is about 32 light years.
About 30 light years. So light takes 30 years to cross. Okay? So it's huge. I mean, in terms of size, in terms of kilometers, etc. If you do, it's huge. So this, you start with this ball of gas. I mean, it is shown to be a sphere, but in general, it will have all sorts of weird shapes. And then you start to see all these collapsing things happening. And at certain point of time, you form the stars. Okay? In these particular stars, you see some particles actually flowing out. That is because once a star forms, and if it has too much of material around it, it starts to clear it out. Because of the energy that is released, the gas gets heated up and it starts to fly away from all sorts of directions. Okay? Sometimes there is mass which gets accreted and then it comes out of in the form of jets, for example. But again, those are details we won't go into. So, so what happens, right? So at some point, it stops. Let's see. It stops, or it has to stop and form something stable. Okay? So how do we do that? So as I said, if the whole life of stars is always about balancing, some sort of balance. Okay? So in this case, there's gravity which is pulling things inward, while some sort of a pressure needs to come in order to balance this. Okay? Now you can say that maybe it is just the gas pressure, just the temperature increase, and so that's the reason why this is happening. That's one way, right? And people used to think that. And so what you can do is do the following calculation. Okay? You can calculate what is the energy of a sun-like star just because of gravitational forces. And that, it turns out, it is basically proportional to this quantity. Gm square by r. You can show by dimensions that this is the energy that comes out. There are factors of half or so which are in front, but let's forget that for the purpose of argument. Okay?
Energy that comes out of the star.
No. This is the gravitational energy of the star. Okay? That's how much gravitational energy is there present in the star. Now you can ask the question, okay, I know sun-like star, I can measure how much energy per unit time it is emitting. Okay? So this is energy. And I know how much energy it is emitting per unit time. So this is called luminosity of a star. How much energy it emits per unit time. Okay? So you have some reservoir and you start, just a moment, you have some reservoir and you start losing energy. So what will happen? At some point it will run out, right? Okay? So you can calculate for a sun-like star, at what point this energy will run out. Okay? The whole gravitational energy will run out. You do this calculation, the number comes out to be about 15 million years. But the Earth has existed for even more time. And the sun should have existed even like 4.5 billion years. So this is not enough. Something else has done. So if you just take the gravitational energy, that is not enough to sustain a star for such a long period of time. It's not the gravitational energy which is doing this. So there is something that needs to come in, which will result in all this pressure to be built up in order to support the gravitational forces that are trying to like push it inwards. Yes,
The
sorry.
R root, is that a distance or a radius?
So this is the distance of the radius of the star itself. Okay, so it's the gravitational energy of the star. That is the radius of the star. So it's so you can take the mass of the sun here and the radius of the sun and you calculate. You will get something of the order of few tens of millions. So it cannot be gravitational energy. Yeah.
In the previous slide, actually, there was a term called a protostar. What do you mean by protostar? The last one.
So these protostars are basically again big clumps of gas which are continue to accrete material. Okay, so they have not yet ignited the thing that I'm going to talk about next, the nuclear reaction. So they keep on like accumulating material from the background. But these are like dense, and this material is just gas. Yeah. It's all hydrogen and helium.
Before star, proton is before.
Proto is before. So it's just a region where you would expect now a star to be born anytime. It just requires some more mass to be put in order that it becomes hot enough to do something else. And so typically what happens is if you have protons and protons, you try to get them together, just like if you take the same poles of a magnet, they start to repel, right? Because of electrostatic forces. Magnets do it due to these magnetic things, but this is electrostatic forces, right? So they start to repel each other. Okay. But if gravity is so powerful that it starts to smash things into one another, then even like overcoming this electrostatic repulsion, then you can get some of these protons to fuse together to form helium.
Then only
Sir, there is
more temperature is required.
Temperature is also required. So for all these reactions to happen, you need a lot of temperature, a high density. All this happens because gravity keeps on pushing. So there is nothing preventing it from.
10 power 7 to 10 power 9 Kelvin.
Before, there is nothing preventing it from the collapse. So until there is something that you ignite which prevents the collapse, it will just keep on like pushing things together and together and together.
So, but when we talk about the formation of nuclei, it's the weak nuclear reaction force. The nucleons
It's the strong forces which are responsible.
Yeah, strong forces at the small distances.
Yeah, small distances, exactly. They become attractive. And so
That's
it
not
overcomes the repulsion, and now you can form these kind of.
But that's not gravity, right?
No. Gravity is making sure that you
They
reach
come
the
together.
condition.
They come to.
Otherwise, usually protons will not like to come together towards each other because of the electricity. Only when you have a lot of gravity, you can actually form densities high enough and temperatures high enough that you can overcome this and form this.
Usne close डालेंगे. The gravity is making close, they come so close together.
Yes, exactly. And create the right amount of temperature and the right things in order for these reactions to happen. So now, when these reactions happen, what you will notice is you can go again and calculate what is the mass of a proton and what is the mass of 4 protons. And then you can go and calculate what is the mass of a helium.
Yes.
And it turns out that the mass of these protons, if you sum them up together, and it turns out to be larger than the mass of the helium. So the rest of that mass gets converted into energy. So that is the nuclear energy that you can get. This is from fusion, okay, because you're putting things.
So in the second picture, we have 4 protons. So they are combining, we are getting heat. So here I couldn't find any mass difference. Instead of getting mass difference, the mass has been increased like that. Because 4 protons mass.
No. So there is a binding energy, right? So when it is not just equal to the mass of these mass of all these.
Charge is also not conserved, no? So here
Charge is not conserved. So whatever reaction we are showing.
Here 4 protons, 4 positives.
Yes.
Here only 2 protons,
Yes, of course.
2 neutrons. Then
Exactly.
you get the 2 neutrons means 1 positive and negative. But
I completely agree. So this reaction is just showing a schematic of what happens for the nuclear energy. In reality, there are detailed nuclear reactions where everything that you are saying is
Proton cycle.
So it depends upon on which stage you are. And it also does not happen in one stage. In fact, you first take these protons, you form deuterium, and from the deuterium, you form tritium, and so on. So there is an elaborate cycle of reactions. the end product is you go from 4 protons to a helium. Yeah. You can look at the masses of these objects, and the helium nuclei has a smaller mass than the 4 protons. The rest of the thing gets converted into energy. That energy is the nuclear energy. And this energy then starts to heat up things, and now you can start to balance the forces, balance gravity. So you can ask now, how much energy does one nuclear reaction generate? And you have to think how many such reactions must be going on in the sun in order to sustain it, and how long it will last. Okay, just by these kind of arguments. Okay, how much fuel it has, how much does it burn? If it burns it based on this, okay, nuclear reactions, then how long it can last. So that number turns out to be billions of years.
5 billion.
So sun-like star lasts for billions of years. So how many reactions are going on? You can all calculate this based on how much energy you are receiving per unit time. From there, you can work out how many such reactions should be going on per unit time. Okay. And then you have again a reservoir, which is this huge amount of hydrogen gas. Then you can ask, how long will this hydrogen gas last? And when you do that calculation, it turns out to be billions of years. Now you can have a star which can sustain itself for billions of years based on this nuclear reaction. Yeah.
When we talk about masses of these planets and stars, how originally were they calculated by us?
Oh, so there are different kinds of methods again to calculate the masses of these objects. So, for example, you can study gravity on Earth and calculate what this gravitational constant is, right? Once you know that, if you measure the distance between the sun and the Earth, and you know how long it takes for the Earth to go around the sun, you can calculate what is the mass of the sun.
Okay.
So then it becomes a question of, okay, how do I measure the distances and so on. So there is again an elaborate thing that I can do to tell you how these distances were. Yeah, I mean, not. Yeah, that is one way. Okay. So it's quite an interesting question actually, and you should also think about it like how would people measure even how the Earth is covered, by what radius the Earth is covered, then what is the distance to the moon, the masses and so on.
So
it's not simple because it's not like you can go there and put it on a spring and measure the mass. Right? That's not something that you can do, and so you have to use these kind of techniques in order to figure out. So there are some gravitational laws that you learn by looking at things on the Earth, and then you apply it to the cosmos, then you start to get to learn about the masses of these different things. I mean, we are talking right now just about the mass of a star. We can measure the masses of galaxies, and there's this thing called dark matter also, which we can't even see, and we are still able to measure the masses of this. Well, yeah, sometime later. So, as I said, if you keep on continuing this reaction for a long time, the hydrogen keeps on burning and forming helium and so on and so forth. And so what happens is at some point, it will start to, like all the helium will start to come into a core, right? While the hydrogen starts to be on the outside. So something like a shell burning process happens, where now the hydrogen is only burning outside in some shell. At that point of a time, these stars, they turn into something called red giants. And these red giants, their surface, sometimes like the size of this star becomes so large that they can even engulf the inner planets or planets which are close by to them. So stars like Betelgeuse, for example, they have really huge sizes. And our sun-like star, for example, its surface will come quite close to the orbit of the Earth. So it will like completely eat up Mercury, eat up Venus. It will come very close to the size of the Earth.
They played, sir.
Yeah, plates. So all these processes, there are like detailed balance equations that you can write about why this star starts to expand and why these outer layers become bigger and bigger, and there something's happening in the inner regions and so on. But again, we will not go into those details. It's just that it becomes big. It actually cools down when it is bigger. That's the reason why it turns redder and redder. So redder things are actually cooler than bluer things. So that's another thing that is sometimes considered.
Yeah, because it is expanding, but is the number of atoms or molecules increasing?
No, it's the mass is still conserved. It's just that it's becoming bigger and bigger.
The
That's
pressure
all.
inside.
Yeah. And the mass that it starts to eat up is also not that much. I mean, all these mass of Mercury and Venus, they are nothing compared to the mass of the Sun. So yeah, it was a little bit more massive because of eating these, but not much.
Energy inverse proportional to lambda.
Yes, so energy is inversely proportional to lambda.
So lambda of red is
Lambda and
like
temperature are related and so on. So indeed, so these things get cooler and so they become redder.
So
Yes.
they are absorbing those planets close by.
Yeah, they are eating it up. Basically, it becomes part of the sun.
So the matter inside increases, right?
Yeah, a little bit,
So
but
what
not
happens
much.
to that?
Huh? It just becomes part of the sun.
It just starts burning along with sun.
Okay, so it's
It's
not
just
only
part of, it
hydrogen
just
and
becomes
helium.
part of the sun. But it is not going to be like nuclear burning. Right? So because these are terrestrial planets, it's not like there are helium. Okay?
So
I mean, maybe trace amounts in the atmosphere.
They just burn.
They just go inside. Become part of this whole soup.
Great.
Red color.
Yeah, so towards the end of this life, of something like a sun-like star, what will happen is all the ashes from the burning, they are forming at the centers. And so from hydrogen, you get lots and lots of helium. Right? And so this helium, at some point, there is a helium, and there is nothing which is supporting the weight of this helium. Right? So now what will happen? There's a lot of helium, nothing which is supporting the weight of this helium will again start to compress. Okay? So even though these outer layers of hydrogen are like moving out and outwards, this helium starts to compress, the helium core. Now when it starts to compress, again it starts to heat up. At some point, just like hydrogen atoms came together to form helium, these helium atoms come together to form carbon.
CN cycle.
And that is, again, these nuclear reactions that we have studied on the Earth. We can apply the same nuclear reactions to calculate what will come through. And from these heliums, you then form carbon.
Helium ash is meaning temperature is becoming less, right? Helium ash means temperature is becoming less inside.
Yeah, because now there are no nuclear reactions going on inside, right? Because the hydrogen that was inside is gone,
So the
almost
pressure is
depleted.
less. Pressure.
And so now there's less pressure, it starts, again, gravity starts. So always this balance between gravity and something inside, which makes a stable thing. But there is nothing when there are no nuclear reactions going on, and so it collapses until it starts to burn itself. Okay? So helium now combines to form carbon, and that kind of reaction for some time can sustain the helium from collapsing, all the helium from collapsing.
How many years?
So it all depends upon the mass of the star, and so where exactly you, how much time you spend on that particular sequence where helium burning is happening, it depends upon the masses.
So
yeah,
you said that fusion reaction will occur when hydrogen is turning into helium, right? Now helium turning into carbon. So what kind of
that is also fusion.
Also fusion.
It's also fusion means coming together of different nuclei. Yes, exactly. Yeah. So again, nuclear energy is released, and that energy then sustains you for some time. Okay, because now it can balance the gravitational forces. And so you get this helium core. So the outer, so before we go there, so the outer layers of the star at this particular point of time, they also start to get like dispersed. Okay? So oftentimes what happens after you form this helium and then from helium you form carbon, after some time even that thing dies out. Right? So all this material that was there, that gets expelled because you see that there was this red giant thing. Okay, it also keeps on expanding and it loses all this material. And then when you form this carbon nucleus inside, at some point what happens is everything just flies away and you get something called a planetary nebula. Planetary nebula don't have anything to do with planets. It's just a term that was stuck. But these are beautiful nebulae that you see, and I don't think I have a picture of it here. Maybe later. You just search for planetary nebula, you'll find this beautiful gallery of pictures. Where all these layers are expelled and just there's something in the center. So what is that thing that is there in the center?
Right.
So again, now there is a carbon. It's of course not just carbon, right? There are also electrons which are around, moving around. So again, the nuclear reactions have stopped. So what will happen? So everything again starts to compress. And now the things just depend upon the mass of this object. So at some point, if you keep on compressing this thing, these electrons kept on pushing into smaller and smaller and smaller regions. At that point of time, there is something called electron degeneracy pressure which comes in to picture. Okay? Now this is a quantum mechanical phenomenon, and I have no clue how to explain it right now and how to get it to fields. Quantum mechanics is so bizarre that it becomes very hard to explain to anyone who is studying even quantum mechanics. So that's why I will not even try to get it. But imagine that if you have electrons, if you try to put them into smaller and smaller regions, at some point of time, it becomes harder for them to be squeezed into some smaller and smaller state. Okay? So that starts to produce a pressure, which is called as electron degeneracy.
Electrostatic.
Electron degeneracy pressure. It's not the electrostatic force. That is the thing then that holds the star from falling down. Okay. So now this carbon thing is around, but then it is being held just by these electrons not being able to be squeezed into even smaller and smaller regions. But gravity is great, right? It can even overpower that if you have a lot of mass. If you don't have a lot of mass, then you can still be balanced by this electron degeneracy pressure. So you try to squeeze this in. So imagine when school children come out from the school and they fill into bus. If you try to put all the students in your school into a single bus, right? That will become difficult. I mean, at some point they will start to push around each other, right? So you can think about it like that, but of course it's a quantum mechanical. So it's kind of preventing now these electrons from being pushed into smaller and smaller regions. And that's what keeps the star. This is this white dwarf that you get. So now what is happening in terms of our balancing of forces? Gravity is being balanced by the electron pressure. So Subramanian Chandrasekhar was one who had actually studied these kind of objects. And he had worked out these equations and he had figured out what these white dwarfs should be. Okay? So just to give you an idea of how dense things are. Okay, so if you take, okay. Yeah, so if you look at how dense things are, so let's try to take the mass of the sun and you can calculate its density. You know its radius. So you take the mass divided by the volume, 4 by 3 pi r cube, and calculate its density. Can you guess how much the density should be or is roughly? Just guess.
10 power 40, 10 power 60 something.
Units. So let's say in units of the density of
kg per meter cube.
density. Okay, 10 power 60 kg per meter cube. Any other answers? Don't know, right? Try to calculate this number. It's a very, very small. I mean, it will be unbelievably small. So the density is just 1.5 times the density of water. The average density of the sun. In the inner cores, it's really dense. but the average density of the sun is not.
Size is also.
But huge mass is concentrated at the small point.
Yes.
But it's-
So let's look at density of the sun. Google is really good. So it actually just directly
I
should
think
give
I can look at
the-
160 grams per centimeter cube.
No, that's the core. That's the core. Right. So average density. Okay, let's write it.
7 grams per
Mass of the sun divided by volume.
The average density is given.
1.4 grams per centimeter.
All are gases only.
Yeah, it's just 1.4 grams per centimeter. So it's not like that dense on average. Okay. But at the center it's just quite dense, but still not as dense as you are thinking, not 10 to the 6. Good. So I just wanted to give you an idea of this, right? Just because sometimes we have like different ideas in our brains about what the sun is. So this kind of an object, now you take the mass of the whole sun, which is like really huge, compress it into something like the size of the moon. That is how dense a white dwarf. So now again you can calculate what the density is, and it turns out to be quite dense. Yeah.
I had heard of the term photosynthetical lipids.
We will get to it. We'll try to get to it. Let's see. I don't know. I will try to. Is it coming? Oh, yeah.
But sir, you take time.
That's okay. So anyway, so white dwarf is quite more dense, and I will leave you as a homework to actually calculate how dense it is. Okay. I mean, think about the sun, and you compress it. Now the same mass, you are changing the volume, and the volume is changed by a lot of factors, right? Because the sun is quite more big compared to the moon. So you compress it, and you'll see that the density increases.
1.4 grams per cubic.
That's the average density of the sun. Okay? White dwarf is even more. Now, what happens is if you have even more massive objects, okay? So if you have even more massive objects, now these electrons are not able to hold the collapse of this star.
Gravitation.
So now what happens is these electrons, they start to combine with the protons within the carbon nuclei. Okay? So protons and electrons combining, they become neutrons. Okay? And now instead of having electrons supporting you, these electrons got squished even more. So it's like this buzz, you said, no, I will even crush such that their bones get crushed and whatnot. If that happens, then these electrons get pushed, but quantum mechanics does not allow that. It says that you cannot really go inside such a small volume. So they don't remain electrons anymore. They said that, okay, it is better for me to get together with the proton and become a neutron.
So repeat the whole thing again, proton, neutron.
Okay. So see, you have this carbon, right? Carbon is nucleus. So nucleus has many protons, right? I think 12, no, six protons in carbon, right? And so 6 protons and 6 neutrons. That's what is there in carbon. Now you have electrons which are floating around. You push them really inside this carbon. And this pushing is happening because of gravity. Because it's so massive that electron degeneracy pressure is not able to hold it. You push it even further. Now these electrons, they have no other way than to go into the nuclei themselves. They react with the protons within that nucleus of carbon. And they turn into neutrons. So instead of now having this carbon being like 6 protons and 6 neutrons, these protons inside the carbon, they turn into neutrons. So now you have neutrons.
Only neutron.
Neutrons, yes, only neutrons.
So number of protons in all.
Carbon.
It doesn't remain carbon, so it becomes like neutron-rich material. We don't know even what to call it. So this neutron-rich material now, again, it has these quantum mechanical principles. You cannot really squeeze it even further. Okay, or if you try to, then it exerts some pressure. That pressure can again try to halt the collapse of that.
One more question I had.
Yes.
See, helium is an inert gas. It is not a reactant. So how come the reaction change?
This is nuclear reaction.
So see, nuclear reactions are different from chemical reactions. Okay, so chemical reactions they happen because of the electrons interacting with other things. But nuclear reactions happen because of the nuclei itself doing something. So now you smash this nuclei together, you make another nucleus. When people from long time have been trying to say how to produce new elements, you know,
Transmutation.
and that was just not possible because it requires tremendous amount of energy.
Alchemy.
This thing called alchemy.
Alchemist.
Exactly. It's only possible when you like really go to high densities, high energies, and so on.
So your
High
last
temperatures.
statement was some neutron-rich material is formed, and this stops the collapse of the star again, right?
Again, yeah. I mean, you again stop until, of course, it's not good enough. So it's the same kind of a thing. Okay, so if it forms, then it becomes this thing called a neutron star. Okay, so in this case, gravity is being balanced by this neutron pressure. But by the time this is happening, in order to cause these electrons to be pushed inside and whatnot, by the time this happens, it actually undergoes, because this does not happen at the same place in all times and so on and so forth. You undergo this kind of an explosion.
And that's the black hole.
And so it happens only to really massive objects, and you form these supernovae. At the end of this supernova, you'll find like a neutron star which is formed at the center.
Still, it's not black hole.
Can you just repeat the last thing
Yeah,
again?
yeah. So before you form a neutron star, you are like squeezing in all this matter, right? It results in a complete backlash, and there is a lot of material and energy which gets thrown out, and this causes these supernovae. So there's a star which is in a whole galaxy, it just completely outshines the galaxy. And this happens to massive stars. When you form then a neutron star at the center, all these electrons now have combined in order to form this neutron-rich material. Okay? So if you have calculated the density of white dwarfs, now calculate the density of neutron stars. That is even more. Okay? So I told you take the mass of the sun and put it into the size of the moon. That is a white dwarf. Take the mass of the sun, put it into a size maybe 5 to 10 kilometers. Okay, the moon is so big, you even compress it further, and now you try to calculate the density.
So the neutron
it becomes
star-
like density of nuclei themselves. So it's really, really dense material. So you can see the neutron star compared here to like New York City. Right? Yeah.
So in neutron star, what is that reaction happening which is giving out that energy?
No,
It is shining.
No, so while it is falling down, there are lots of processes which go on which actually generate this, because there is a lot of gravitational energy which is also released. Right? And so that causes that explosion. And it does not happen in a circularly symmetric fashion and so on and so forth. So it results in lots of shocks being generated. Yeah, it's like this material starts to collapse, but then it reaches some sort of a hard surface and then it backlashes. I mean, it bounces back. And that results in all this material being completely thrown out. It's a violent thing. And that's the reason why you see this super.
Sir, as you said, that the electron as plus proton turns into a neutron, right?
Yeah.
And plus energy.
Naturally.
This gives energy, right?
Yes, so I mean, it's
That
this,
is the explosion, right?
well, this, okay, so it's the weak reaction which is doing this. Do you know what is the amount of energy released by these weak reactions? The weak forces. No. So we'll have to get back. But I don't think it is necessarily just this weak reaction. Is the gravitational energy, right, which compresses things and then it reaches this hard surface and bounces up. That's the energy with which
the neutron ball inside, but you still have some gas outside. So everything is falling, and then basically the falling gas now hits a wall. It's like a train which is moving at a very, very high speed, and then suddenly it hits the wall, and then a shock comes, right? The train gets crumpled. You have seen pictures.
Yes.
So like that, the shock wave now gets transmitted and then it blows apart
Blows apart the
whatever
whole
gas is
stuff.
remaining. Whatever material is remaining. That is the supernova.
Because of the crunch.
Yeah, it's the crumpling because of gravity. Yes. But the pressure that is there is because of this electron degeneracy pressure. Neutron degeneracy pressure.
So,
That balances.
so in the neutron star, it is neutron degeneration, which is
Yes.
holding it for a while.
Yes. But that, neutron degeneracy pressure can hold it for quite a while actually. So after this supernovae form, then you have these neutron stars which form, which will stay there for a long, long time.
So that will be shining.
So you can see neutron stars, but you have to see them in different kinds of. You do see neutron stars.
This movie will show
Oh.
this pulsar.
Yeah. So these neutron stars then have like magnetic fields, and they are rotating stars, and they release like periodically they release some radio emissions. So you can find this. But look at this. This is like a mass of the sun, but extremely tiny. So these radio emissions that happen because of material which is falling onto these neutron stars, that is the thing that you can try to observe.
So neutrons from their core, the neutron stars from the core, they are not emitting anything. It's something.
Yeah, so
which
there is no
surround-
nuclear reaction going on.
And that's
There is no nuclear reaction.
just surrounding, interacting
Yes.
with that part.
But this all depends upon what is the mass, right? So you can maybe stop at white dwarf and stay happy there. If you don't have enough mass, like not enough pressure from gravity, then you can stop there. If you have a lot of mass, then that electron degeneracy pressure does not work to form these neutron stars. There are even more massive objects, then they form these black holes. So black holes are things where things get even more compressed. Neither neutron degeneracy pressure, neither electron degeneracy pressure is able to halt it. And then you collapse into a very small region of space-time. How exactly these things happen are again not clear. But when you get to these densities, you turn into black holes. So what are exactly these black holes? Yes.
Is it necessary that every neutron star will turn into a black hole eventually?
No,
No. You can stay happily as a neutron star.
Say more mass.
Okay.
You mean star.
If you have even more mass, then now even neutrons are not able to sustain that gravitational force.
So can we say that the small stars may not turn into a black hole,
Small
but the big
stars
stars
don't.
will
Yeah,
definitely
only
turn
the
into-
really biggest stars, they collapse and then they form this kind of black holes. But so depending upon where you start, you can have a different end state for yourself.
Are there even small mass stars possible, which won't be even coming in the range of getting transformed into white dwarf?
Yes. So there are like, so I told you to calculate these kind of time scales, right? So you can calculate the time scales for stars which are even smaller than the mass of the sun. Okay, and you can keep on going down. And at some point, what will happen is you will realize that the age at which the time scale at which you can sustain these nuclear reactions and balance gravity for smaller stars is bigger and bigger and longer and longer and longer. It becomes many times longer than even the size of the age of the universe.
Oh, so they remain like that.
Yeah. So some of these stars which are small, they live for a long time. Nothing happens. It's just they are happily burning fuel at a very small rate, but rate good enough to be able to sustain the gravitation. So that thing happens. Okay, so maybe we came at black holes, and then we will stop. And then we can go to the next item, which is Vaishnavi. Yes.
Also, if there's a white dwarf and if it's accreting more matter as such.
Yes. That thing I forgot to talk, right? So, white dwarfs, so there was this limit question that was asked. So, what Chandrasekhar had worked out is that this electron degeneracy pressure, there is a limit in terms of mass out to which the electron degeneracy pressure can still sustain. Okay? And this limit was worked out by Chandrasekhar when he was traveling from India to England. And this mass is about 1.4 times the mass of the Sun. So if you become even more massive, then electron degeneracy pressure is not good enough to sustain. And so by itself, white dwarf will not reach this kind of a limit of 1.4 solar masses. So what happens is if there are other stars which are going around the white dwarfs, then the gas from these stars, these other stars, can flow into the white dwarf, and it can keep on feeding it until it becomes more and more and more massive. When it reaches this 1.4 solar masses, then it actually undergoes a thermonuclear reaction, which again blows apart this whole star. So that's called a type 1a supernova. The supernova, which happens because of much more massive stars, it's called core collapse supernova, because it's the core which collapses. In this particular case, it's like a thermonuclear bomb that goes off. And so those kind of supernovae are also quite interesting. But again, I mean, these are like lots of details which, I mean, it will be hard. If you want to learn more and more of the details, you have to write down all these equations, go through it and one by one and study. It's also not that I'm an expert on the life cycles of stars myself, but this is the general picture that happens for stars. Okay, I'll not go into black holes whenever we get time. No,
please.
It cannot happen in 5 minutes. If I keep talking, then it will continue.
We won't ask any questions.
No.
Ask anything.
Because our questions are confined to relating your talk, right?
Okay, fine. Okay, fine. Okay. So what is a black hole then, right? Okay, so in order to understand this, let's consider this chalk. Okay, if I throw this chalk up, what happens?
It comes
It
down.
goes a little bit high and comes back down, right? If I throw it up with even more speed, then what happens? It goes even further up and then comes back, right? So if I keep on throwing it at faster and faster speeds, it will go up and come back. But there is a limit to which this will happen, okay? Because the Earth's gravity is only so much. If you throw it even faster, then it actually escapes. Do you know what that speed is?
11.2 kilometers per second.
I want it this now.
Oh.
Because see, kilometers per second is very difficult to imagine, you know. So do you know what is the number? In kilometers per hour, right? It's very hard to like guess, right? What is 11.2 kilometers per second? So now can you tell me in kilometers per hour roughly what that number is?
4,000.
4,000? 4,000?
Get the logic there.
So 11.2 kilometers per second. So let's consider 10 kilometers per second. In an hour, there are 3,600 seconds.
So
3,600 times 10, right? So it has to be something of the order of
40,000.
So think about how fast it is, right? How fast I need to actually throw my. How fast I need to throw my throw something in order to escape the gravity of the Earth. Okay? When you are launching rockets, you are not trying to escape the gravity of the Earth. You are just trying to move it a little bit further up. Okay? But if you want to completely escape Earth's gravity, then it has to really travel so fast. I knew you know this number, 11.2 kilometers per second. So I wanted to translate it. We wanted to translate it.
So Mangalyaan went from the escape velocity.
Well, you slowly keep on increasing, and that is okay. So here I'm saying I'm giving the velocity just once.
Okay.
Right? What you can do is you can keep on kicking it a little bit more, and reach the orbit of Mars. Right? But if there was nothing in the universe, and then you again fall, then again it would have fell back on the Earth. Right? Now it gets captured by Mars and so on. So unless you give 11.2 kilometers per second from the Earth and there is nothing around, only then it will escape. Anything less, it will again will fall back. So for the Sun, this velocity is even larger, right? You can see that number. But now imagine that you can have even more and more massive objects. So massive and dense, dense objects. So you have Earth, then the Sun, which is like 600 kilometers per second. Neutron star, our friend, it's about 100,000 kilometers per second. Now. This is not even hours. So you have to multiply another factor of 3,600 to get kilometers per hour, right?
One black hole.
It's huge, right? So if you have something which is even more massive, like a black hole, which has formed now, and compressed into even smaller space, the speed at which you need to launch objects from its surface such that it escapes becomes faster than the speed of light. And the universal laws tell us that nothing can travel faster than the speed of light. And so nothing can escape from this. Not even light can escape if it has reached like quite small distances from a black hole. And so that's why it's called black hole, because nothing should be emitted. So there have been ideas of these black holes from quite some time, exactly based on these velocity calculations. But more modern ideas came from these people, okay? Albert Einstein, Schwarzschild, and Chandrasekhar. So then the question becomes, if light is not coming out from them, how do we actually observe these objects? Okay? So in order to observe these objects, you still need some light coming out from somewhere close. Okay? The question is how close. Okay, so sometimes what you see, many of these stars which form in the clouds, they don't form alone. They often form with companions. These companions over time, over some period of time, they may drift away from each other. Okay? But sometimes you see this kind of binary objects. So let's suppose you see a binary object in which there is a star, and you see it wobbling, but there's nothing around it. So that is how you can try to say that there may be something which is still giving this gravitational attraction, causing this star to move around. And based on size measurements, etc., and the amount of light or the absence of light it is emitting, you can say that there is a black hole. So that's one way. There are other ways. Sometimes this star, this kind of star, because of the tidal forces from this black hole, it can start to get bulged, as you can see here. And the material from this star can start to fall onto the black hole. When that happens, it falls in some sort of a gaseous disk, and this disk heats up, and it can emit X-rays. So it's still not within the black hole; it's around that black hole. And so those X-rays from around that black hole, they can still reach it. No, these are this kind of it. Okay? So this is Cygnus X1, for example. This is one of the first black holes that was observed. So you have this big star, which is putting material onto a disk around the black hole. Okay? And then you see these X-rays which are generated by this kind of thing. So what was seen is actually in the optical, you only see that star. And then there are X-rays coming out of it. Okay, so this thing is called, I think it's a X-ray binary, right? This was like first observed black hole. Then some of you may have heard the first image of a black hole like few years ago. So this is taken from something called the Event Horizon Telescope. Again, it's not detecting things from inside the black hole, but what is going on outside. Okay, so there's again this gaseous ring, and then it's starting to emit. Of course, observing these kind of black holes and this shadow of the black hole that you see here, that is only possible when you have really large telescopes. And it took efforts from a lot of scientists in order to get this possible. In fact, you have to construct a telescope which is as big as the size of the Earth, okay, in order to be able to resolve this kind of thing. And it's not like literally you create something as big as the Earth. So you keep one telescope at one point of place in another place in another place. That allows you to get the resolution. Okay, so that's how these radio telescopes work. And then they used it to image the surroundings of the black hole. And it is predicted that when you observe these kind of things, at the center there should be a place from where no light comes out, and that's basically this shadow that is coming.
It is at the
So we have looked at the life cycle of stars and we understood what are the end stages of the stars and how you can form black holes also. I mean, only some of these things become black holes, not everything. Okay, so hopefully I've given you enough information that you can, maybe I've confused you also. We can talk more about it during any of these break sessions or whatever. So is that tea now or can you check?
It's most probably the gravitational energy.
It's the gravitational energy. That's I think what I also think.
Now, in the last lecture, you mentioned center of the galaxy, M81 something.
Yes.
The center.
Oh yeah. So this black hole that was observed is a black hole which is at the center of this galaxy. Okay. And it's really humongous. It's like it has, I forget now the mass exactly, but it's many billions of suns.
Of suns?
Many billions of suns compressed into a very small region. That's what it is.
There are beautiful videos.
Yeah, and in fact, I had a video, let her come until then I'll show you a video. There are too many slides that I have, so, and I went slowly and we started late, so. Let's see. So this thing shows the sizes of different black holes. So this is the sun. Then this one is a black hole which we have observed and what its size is given its mass. Then some of the black holes can be as big as the orbit of Jupiter. Okay. So the more massive these black holes, they have sizes which become bigger and bigger and bigger. So you can imagine these black holes being even bigger than the orbit of Venus in that case, then orbit of Mars here. This one has a size which is as big as the orbit of asteroids. Then slowly so that's the Milky Way black hole, for example. This is 7727. Keep on going further and further. There are some black holes which are even bigger than the solar system. And even bigger, and even bigger. Okay, so this is the one from Andromeda Galaxy. You see the same. Now you are reaching even the Oort cloud, I think. So as big as the Oort cloud, that's the first image of the black hole, the 87. And now we will end with, I think, the biggest one that has been found so far. This is called TON 618. So they are really, really massive, really large. Okay. Is that
He is just coming.
Just
So I can.
yes. Okay.
5 minutes we have.
So what do we do? Should we go to him or? No, so you were telling about the mission.
Yes, because of the hydrogen. But there is no atmosphere.
Yeah, exactly.
5 minutes means you play video, sir. 5-10 minutes means just play video. That's enough.
Just yeah, okay.
From discussion from
Okay, we can do something.
and then a short sequence of 10 to 15 minutes. You go first, then I will do the movement.
Sure.
Book section is
The images for the JWST we have received. So that are original images and again edited, right?
No, edited
colors
as
and
in
lights
it's just
are-
the colors that they decide. See, okay, this kind of wavelength I will give this color. This wavelength I will give different color. This wavelength I will give different. So imagine if you had light, you put it through a prism, then all the colors separate. Now I can say that I will only observe in blue light and what the image looks like. I can say I will only observe in yellow light or orange light and see how it looks like. And if I want to combine and see what the whole thing looks like in these different colors, then I will put those images together. So there is no editing, as in no one is going and like tweaking from where the photons are coming from. It's just deciding what color I should give. Because see, these red, green, blue colors I can only give to the wavelengths that you know and we can see. These observatories, they observe wavelengths of light that your eye cannot see. So they just, you cannot say that this is red color or whatever. You have to just assign the color so that you can see, right? If they give exactly the colors that they are emitting and they are being detected at, you won't be able to see it. Then how will you appreciate the image? And so they transform these wavelength ranges, give them colors that you can see to make these images.
So what are pulsars?
So pulsars are these neutron stars on which are moving around and they, which are rotating around. And because of these magnetic fields, there are hotspots on top of these pulsars in certain regions. And what happens is the radio emission which is coming out of these pulsars from these hotspots, it basically makes a cone because it's precessing. And sometimes you come in that cone. And so you receive the light from that pulsar.
It outshines the galaxy.
No. The pulsar light is coming in radio, for example. So you see it as radio pulses. You see it as a pulse, and again it rotates, it's coming. But think about it, that neutrons are such a massive object. Some of these pulsars, they rotate in milliseconds. So in 1 millisecond, it will rotate entirely, right? Such a huge object with such a big mass, it is rotating within milliseconds.
So Deepak Groha's
So 1,000 times a second it is rotating. And you can detect it and see all these pulses and measure what is the time period. Some of them have larger time periods.
So when data is being received by watching the skies, there will be a mixture of signals which are coming from
Mixture of?
signals.
Yes.
It would be so hard to identify exactly what we are watching, and I mean,
right. So that's right. So there are two things which help you actually. Okay, one is space is really quite empty. Okay, so one thing that you saw is there is the sun and then all the solar system around it and asteroids and so on. So you feel that the space is also very cluttered, right? But now you consider the distance between sun and the other nearest star. 4.2 light years, right? Just between the stars. There's tremendous amount of empty space. So the light that comes from that star, it reaches you. So unless there are many things in that particular direction, then you can still say where the light is coming. Okay? Of course, there are many different things in the same direction. So you will get radio light, you will get visible light, and so on and so forth. But certain ranges of wavelength will be dominated by objects which are there, and then certain ranges of wavelength will be by other things. So when you make a picture, if you make it in radio, you will see something. If you make it in infrared, you will see something else, and so on.
The cosmic microwave background.
Yes.
So I think it is.
It is this radio thing. It's coming from the earliest stages of the universe. So if you observe in radio, for example, don't see any of these stars. I mean, you do see some gas heating up, but if you see away from the galaxy galactic thing, then mostly you see this cosmic microwave background. And it is the light from the earliest stages of the universe. In fact, that's the earliest light that we ever will be able to see.
We will not be able to see.
Even beyond that, we will not be able to see it. There is some kind of a fog that is created.
So does it
which does not allow light to travel then further before it gets stuck.
Just one thought that popped in mind. So do we call something which is called Big Bang just because before that we are not able to receive any info, so we are calling it Big Bang? Or
No. So you can take general theory of relativity, which is Einstein's theory of how gravity works, right? And you can ask, what the universe should be doing. And it says that the universe should not be static. It does not tell whether it should be expanding or contracting or what. Then you make observations to establish whether you are expanding or contracting. So Edwin Hubble, that interesting man, he actually did this observation. He found out that the universe is expanding. Now, if the universe is expanding now, you can run the clock backwards and ask how small it should have been. So when you run it backwards and make it smaller and smaller and smaller, you see that all of the observable universe should come to a single point. Okay? Or it should come to should become very dense in the early stages of the universe. Once you become very dense, then the rules of general relativity don't apply. I mean, they should apply, but then they start to mingle with the rules of quantum mechanics. And then what exactly happens, we don't know, because we have not probed these kind of things enough, experimentally. There are theories about it. But so that particular stage where you get really hot and dense, that is what is called a Big Bang. But we don't really fully understand the physics once we get to scales where you need to marry quantum mechanics and general relativity. So those early hot and dense stages are what is called a Big Bang. And there is a confusion again whether Big Bang happened at this place or that place, where everything was in the same place and extremely dense and hot. Okay? And that's the place from where the whole observable universe is formed. We don't know how big the universe itself is. And you can tell how big the observable universe is, but it may be extending even further beyond. The problem is we cannot receive light from that place because light takes finite amount of time to travel. So within the age of the universe, it can only travel this much distance. So you only see things up to the distance that light has covered from when it started. What is beyond it, you have not even received the information. So it does not mean that the universe is the same size as the observable universe. It could be even bigger. We don't know what is it. So it's difficult kind of topics. We teach it in graduate school in some sense, but we don't go too much to the edge stages again. There are only few things where our rules of physics that we know apply. Once we go to even higher energy scales or higher densities and so on, but we don't know. Okay, let me see. Oh, yeah, that is right. So T is ready. Thank you. No, no,
तिथे photo काढू का? मी काढू.
that's correct.
त्याची overwriting आहे.
Yes.
photo convert करता. तेच आहे ना, तुला छान वाटतं. नाही, नाही, मी वाचते तेव्हा बरोबर तुला आठवतं. खाली करून. हेच बघितलं. मला कालचं नाही, like second.
Coming out.
Okay, let's get settled. Okay, so next we'll go through phases of moon. We did some activities yesterday about this. I mean, in relation to eclipses, but today we'll go into more detail.
Yeah.
Bhupia?
Yes. Okay. So phases of the moon.
You need to wear the- Oh, you have.
No, it's muted. Okay. So this is a picture of all the phases of the moon that we see in the sky. Do you all agree that this is what we see? So on new moon, we basically see nothing, right? Amavasya. This is a crescent moon. This is called waxing crescent. So this is all waxing, means it is increasing in size, and this is waning. Waning means decreasing. So crescent moon looks like this. You have all seen it.
Have you seen it?
Have you seen it?
Yes. Recently.
Okay. Notice the shape.
Ask who has not seen it.
Is there anyone who has not seen a
Not
crescent moon?
exactly like this. Usually.
Orientation may be a bit different.
Yes.
Just want to know, is there any direction specification for this particular depiction?
Just the
East,
shape.
west or something? Is there anything? Just to know if this crescent and this crescent, exactly where are they?
Yes. Depending on latitude, the orientation that you will see would be different. We will discuss this later. So crescent moon kind of looks like this. Half moon that you all are familiar with. Okay, half moon is half in this picture. Then we call this waxing gibbous. Basically, almost 3/4 of the moon is lit up in this picture. Full moon, everyone has seen a full moon. And after full moon, things decrease again. So here about 3/4 lit up we see. This is we call third quarter. This was called the first quarter. It's a bit of a difficult names to remember. But basically, if you think this is divided into 4 sections, then new moon, then first quarter is finished, second quarter is finished, you have full moon, third quarter is finished, you go back again at half, and then there is waxing crescent, waning crescent, sorry, and then there is new moon. Can you tell me which side is the sun?
That was the left-hand side.
Who all agrees it is on the left-hand side? If you agree, raise your hand.
Not sure.
If you agree that the sun is here, raise your hand.
And which phrase you are asking?
Yes. All the phases.
Sir, that's not possible actually.
So what we are saying, okay, so
Sun is down.
full moon it is on right hand side.
Sun is down.
And then it is changing towards. Okay, so I should specify that this is what we see in the sky. This is not what like a person, if you are like this is earth and this is moon and this is sun. This person from on the top view, that is not this picture. This is our sky picture. Okay. Okay, you think about it. And so the point is not here to tell you where things are. We will do now an experiment and see what happens. The question on the top is, why do moon phases happen? Now, any answers? Yes, we have one.
Amount of sunlight that is falling on the part of the moon, that is the reason why the phases of the moon happens. So जितना light उस पे पड़ेगा उतना phase उतना दिखेगा. That much is will be lit and will be reflected, and that much phase we can see.
Okay, did everyone hear her explanation?
One more.
So what she is saying is that at different phases, on these different times, different amount of moon is lit up. Okay. Who agrees with this explanation? Raise your hand. Okay, I see 1, 2, 3,
Partly correct.
5, 6.
Partly.
Okay. Okay, I have quite a lot of people. Okay, any other explanation?
Rotation.
Revolution of the nation, I think so.
Of the moon. Can anyone? Yeah. Go ahead.
Rotation of the moon around its own axis takes the same time as it takes to revolve around the earth. Because of this motion, its one face only remains
Visible
is
to us.
towards the earth, whereas and with respect to sun, he is moving. So that's why its different portion is lit by sun, but we are able to see only from one side. That's why some part and so on.
So do you think that if the moon was not rotating and revolving at the same period,
Would you not
that
see?
you will not see the face?
Earth's rotation is also matters. Okay, you are thinking Earth's rotation also matters, and some people here thinks that because moon rotates at the same rate that it revolves, that
That's
thing.
why you see the
That's
face.
why you see the phases. Okay.
Even Earth
Any other explanations? We will discuss which one is right and
We
what.
have to discuss all of this because some of these, like you have many concepts that you have heard, you are trying to put them together, but not every concept may be required to explain everything.
Yeah.
So that I think we need to
Yes.
clear. That-
Any other explanations that you think maybe is the reason?
Because of the Earth, Sun, and that is what we are getting the
Earth, sun, and moon.
orientation of that.
Positions. Okay. So because they rotate around things. Okay. Something to do with Earth and moon rotation and revolution. Okay. So next is we'll do the activity first. We'll try to see what it looks like. Okay. So what we want to do is we have two setups. These two will be our two suns. We will switch off the lights. And how many people are there? We want to come in pairs. Pairs of two people. So four people come. So two people will go there. And two people will come here. So what we will do is basically this ball is our moon, okay, and I or you will be the earth. So how we will do this? We see moons only one face. Does everybody agree with this?
Yes.
Okay, everyone knows this. Why or how? This is different question. So let's say this is the smiley face, is the face that you see. Okay. So what you will do is keep the smiley face towards you because you as Earth only see the smiley face. So we will put the moon here. Okay. Don't look at the bulb. Just see. Do you see anything in moon? Do you see any lit up part? Yes, the back side only.
No, for the person who is looking at.
For the, like, you will all come here and do the activity. I'm just explaining what you will do. So you and your friends, so you come in pairs, and then you will see this. So you as art, what do you see here? And as you start to rotate it a bit, okay? Do the rotation a bit closer because the rays are supposed to be parallel. So like this, and then we will do the whole thing, okay? And then the other person, your friend, they should notice what is happening to the moon. How much percentage of moon is lit up at different positions? Okay. Because we have theories that different amount of moon is being lit. That is one theory we can test. Okay, so everyone make a line or something. So 2 by 2, huh? 2 people come here, 2 people go there, and yeah.
Can remove the chairs easily also. Or here is better. I can remove it.
Also, can we switch off this side? It's okay. I want everyone to do this rotation. Okay, make sure everyone needs to do this rotation.
रोटेशन करवा देखती हूँ ठीक
Yeah.
kind of the feeds with the problems.
No, so you are an observer who is outside. So you are the art. You are seeing the moon. So
और तो कुछ कभी नहीं ना
no,
नहीं ये न्यू है
you are like a sign.
Go a little bit farther.
मैंने बच्चों को ये 2 बार एक्टिविटी
Okay.
लो सारी बार ऐसी हो नहीं ना नहीं ना मैं बता रही हूँ करती हूँ तो घुमाएगा मैं तेरे को सब समझ में आएगा
And
the
this
moons are
one,
later.
Then the 50% already made.
और इतना टाइम लगेगा तो फिर
From one side, it's dark, right? This side, yes. Just rotate from your side.
so this is
Now we turn on.
okay. You just see what do you see?
This now here,
no the gibbous one
no, my side,
Okay, only you. Okay, everyone else's perspective would be different because of the angle difference.
that is the reason.
So,
What
okay.
says I am seeing you, maybe, no, maybe
No, it's okay, okay. So, okay, we will start again. Let me just guide one person. So, do you see, what do you see? Light or all dark?
all that.
But from everyone.
That is the you just rotate a little bit. Revolve a little. No, not rotate. Sorry. Revolve a little bit. Okay. What do you see? This is part of it. Move a little bit more.
You don't know.
No, do not look at any other person. Only you. No, you have to think so you will see that the half of all is
Yes.
so let's do one more rotation. This is half, right? So this is half. This is half. Okay. Because this is like passing towards the half. Okay. Now rotate a bit more. What do you see now?
gibbous
What do you see?
gibbous the waxing gibbous
Yours means how much of the whole face you were
Maximum.
फुल मून तो दिखेगा या नहीं अभी दिखेगा ना देखना कब दिखेगा अभी फुल मून अभी डिपेंड्स ऑन हर हाइट अभी इसमें क्या हो रहा है या तो लूनर एक्लिप्स हो सकता है या तो फुल मून हो सकता
Again, this is the main thing.
समझ रहे हैं प्लेन वाली बात
But yeah, if you
तो वीडियो देख बहुत अच्छा वीडियो है फ्री स्कूल का वीडियो देख
Same will be
मस्त वीडियो
in this side, right?
but you continue to do
लिंक को भी
that.
भेज हाँ मैं भेज दूंगी अभी भेज दूंगी मैं अभी फुल दिख रहा है
Now,
Completely, sir.
so the amount of light you are seeing in the little part is less. And then continue to do this. Do you want to use?
अभी हाफ ही दिख रहा है क्या 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 अभी हाफ दिख रहा है हाँ उसको वेनिंग बोलते हैं वेनिंग हाफ मतलब वेन मतलब कम हो रहा है श्रिंक हो रहा है
से न्यून हो जाएगा जब ऊपर से
हाँ तो एंगल से भी देख सकता है क्वार्टर फर्स्ट क्वार्टर 90 45 90 के बाद 125 के बाद ये कितना होता है 180 45 90 प्लस 45 कितना होता है 135 और यहाँ पे आएगा तो 180 फिर से 45 मैक्स
Let's go to the half. Well, you are seeing half of the moon is lit up. How much of the moon is actually lit up?
Again, half of.
Okay. Do you see this difference that you are seeing from this side? If you go to this side here, you see that all of this is lit up because you are not seeing this portion. You are only seeing this
Your
portion.
friends, whoever is seen from
Let's go to
outside,
the
how
full
much
moon
portion
phase.
of the moon is
half of the portion.
always?
How much it is?
But only when she also.
Go here.
How is not
Like this time, this is not getting any light, but this is getting all light. Let's go against the half moon phase.
Whatever is
You are seeing half.
yeah.
And you are seeing half is lit up. The other thing you are not seeing. And in the new moon phase, again we come back. So what do we learn?
For the outside observer, it would be
There is no latitude. Because you are the infrared. All people could be infrared. So see, you are not maybe. If I am cold, if I am in the other. Different amount of liquid force. But always, how much is it?
Keep about yourself as here, for an observer here.
Because it's a
And
ball.
now you keep on going. So right now, everything is flat.
Yeah. So always have. Yeah, okay, no. Now you can also do this and you can do this and you just see. You observe and then we will do this. And we will have questions.
நீங்க அதை புக் பண்ணது இருக்கும்ல போனதுல புக் பண்ணீங்க
Yeah, it's
நம்மளோட அக்கௌண்ட்ல வந்து
actually how much is it and how much art person is it and who is
நம்ம புக் பண்ண வச்சு அது ரொம்ப
because it's
data bases.
okay. Next to
They will show you from outside,
next step.
but they will show you a picture as you will see. So you have to realize that.
Okay.
That's the point that you.
So you
Some of you can also try the experiment. What if you don't rotate the smiley, or what if you rotate it fast? Do you have to keep your smiley at the same time? Even if you work with us, nothing will happen. The phases don't differ.
that is correct. Yeah. If
Even if you
so,
rotate.
that's what the same difference is. If you are shorter, if you see yourself shorter, yeah, then you will see the full movement. That's what.
extended source.
Not the other.
मी जर अजून एक स्पेस मार्क्सवर गेले मार्क्समध्ये मी बघितलं अर्धा पोर्शन बरोबर अर्धा काळा अर्धा लाईट बरोबर राईट पण जेव्हा कुठल्या लॅपटॉप जाईल तर आई अंडरस्टँड की अक्रेसिटी आहे अर्ध
Telling to the students,
this I understood. Right. मी जेव्हा तुझ्या जागेवर राहिली मला आवडतं. पण असं मुलांना सांगतात ना की like also rotating moon पण त्याच्यामध्ये
You are our
light source जो आहे तो
experiment. You don't keep the spike always at 2. Keep on rotating.
and repeating a question on that.
That's fine. Rotation you can do what
Because of what? Physically.
twice the speed at which we go. And exactly get the same speed.
It happens. Actually, if you in front of them only, and it's all right now. I don't carry that.
Looking for this. No, but the sun is also moving because of the sun and the moon are also moving.
That was just pictures of
Oh, those
moon
things,
and
yes.
So like, it's like if I am here, right? So you
But in
are
addition, now we will also be
so like the pictures have this, how many planets are like
yes. No, so this is what we want to do. We want to get you out of the comfort zone by asking some questions more than what No, so it is usually at a 5 degree. See what is happening right now. Your head is too big compared to like all these distances that are required. So you try to mimic those distances when you are the head. Now if you want to get the size of the moon, you know how far you would go. You are 6,400 kilometers. The moon is how much far? You know the number. It's like 300,000 or 400,000 kilometers. Right? So compared to 6,000 kilometers, 400,000 kilometers, it's like 400 times. So you actually have to keep this 400 times more, like you take your head, keep it like 400 times. That's where you have to actually hold it. How you are making it simple. That's the reason why you have to exaggerate. Otherwise, it is a 5 degree thing which you do. But if you do it 5 degree here, it will not be easy.
So what is that 5 degree?
5 degree is the difference between the Earth is rotating around the sun in something.
Cone is smaller.
Mostly circular, a little bit. And then the moon is rotating, revolving in a plane around the Earth, which is slightly different compared to this. So if it was just like this, then you will always miss this between each moon. But instead it is not. What happens sometimes it is here, sometimes it goes a little bit up. Then you move to a different part of the year. There are small pieces. So there is, by the time you complete one rotation, The moon is moved in its orbit, not the Earth moving. That's before. This 24-hour circle before the Earth, that happens in 24 hours. So it does means it exactly at the same time. You will come back at the same place. But by that time the moon is also moved. So now no, 5 degree has nothing to do with why it rises. So that's what I'm saying. So let's put the moon. And if it was stationary, like this, I'm looking I will come back to the same place in 24 hours. I should see it at the same place. But the moon does not stay in this. It also it will move. By the time I come back, at 24 hours, it will move somewhere. Because the moon is not stationary. Because stationary, then that's what it is. Because yes, Earth rotation is every day. It is like once in 24 hours. But the moon is once in 30 days. So this speed is quite slow. But by the time the Earth rotates and comes back, this would have gone there. So you need to come a little bit more in order to see how the moon is.
That side. Okay. Okay, yeah, go ahead. Everyone, repeat this activity here.
Outside of from outside, from
Forget the what? This motor happens a lot.
you are the sun. You always see that you are the one shining there.
This is how much, like if the whole thing is gone, how much is it?
Yeah, of course. I'm saying you are right at the surface of the moon. It's really good to always see a big sign.
Okay, rotate a bit more. So now it will be again complete. So 3/4 हो गया. After 3/4 half, then little bit present. हाँ, वही present. Okay, so you as a space observer, did you notice how much of the moon is actually lit up? Okay. Okay, you now you can move around wherever. You see how much of the moon is actually lit up. This is the whole ball.
No, the whole ball. You can go around everywhere.
This part, one front part. Half is lit up.
Now you
Go to the
go
half. No, you can move wherever.
You can always move wherever.
You can move around. See how much of the moon is lit up.
यहाँ का हाफ यहाँ पे
It doesn't have any.
वहाँ से और
Half was lit up there, half lit up there. Okay, back to the full.
अगेन यहाँ का लिटिल में यहाँ का
If you so how much of the moon is lit up? The same way. You are related. But as an observer, two and three different position of the ears. That is the position of
ये concept थोड़ी अलग से
from space.
Will you look at it now from here? We want you to appreciate this, then we can of course convey to students in the
Imagining is very Yes.
Not even half.
What is the time? What time is the time? Yeah, we will also discuss this. And this is another question. Yeah, we will discuss.
Good. So that is exactly our point. We want you to again think about
Yeah, just keep sending us what next.
For me, put it here. This is on.
चलो फटाफट
Do you see that? 200.
How much of the sphere is
Always late. Does it?
Do you see half again? Do you see half again? And you think
It might be
one is not
the same.
exactly half. As an external observer, you always see half. So for me,
These distances are really far. Not the space.
Yeah, you do that.
You can move around freely.
Because of this is
It's all state like this. It's very far away.
this is like very far.
It's very far away.
So if you have like 3 lamps and then you blend it, then so since the distance is
You also do that. You just say.
There are all sorts of policies that can happen. So it is good to realize.
that's okay, fine.
Temporary eclipse.
Yeah. Okay. Now, if I keep the picture from here to there,
Exactly.
but if I see at one point, I've always seen it half lit.
Wherever you stand, that's all.
And the confusion was because it is.
Sometimes I want to break this notion sometimes. And you guys break it for me.
Okay, is there anyone who has not done it? This is free. I mean, this lamp is free. No, the activity, the whole thing is free. Yeah. Everyone has completed? Oh, excellent. We finished in half an hour.
So like this will be very far away. Rays will be.
In fact, like her head is also too big compared to this distance at which she's going. It have to be like 400 times her height or something. Okay, good. Switch on the light.
Okay, yeah, we will take it. We will, okay, I'll keep this in mind. Okay, everyone has done it? It took half an hour, right? So I think you can do it. Do you think you can do it in your class? We have about.
Representing just one pair, not all.
Yeah, you got it, ma'am.
It cleared many things. Thank you so much.
So, I mean, you think about it whether you can do it with one pair in the class or not. But at least ask these students to go home and try it, because it is very instructive, because it gives you the feel of what is happening.
Also, we understand what the difference between an unit and what we are starting.
Exactly. Very good.
Okay. And you can, at home, instead of lamp, you can also do it with your mobile flashlight. That also works, we tested. Torch will also work. Okay, this we have already done during the activity. Do we see only one face of the moon?
Yes.
Yes.
Besides the temperature.
I will tell them. You put this.
Okay. Okay. So we will here address a few questions about the moon that we might have. Some of you might have this. I had this question when I was a student. They said to me that moon's rotation and revolution both takes the same time, the same period. And it was, as a student, it was not clear to me what that means. Okay. So, what do we mean by this? Moon's rotation and revolution period is same. So, anyone wants to explain?
Around the
Time
around the
by
earth.
one revolution is the same as.
Okay, so revolution means that, say, it starts from this point. So if this is, so if I am the earth, so the moon started from here. Okay, revolution means this, right?
Correct.
One revolution is finished. And now they are saying that moon also rotates around it in that period of time. And that looks like what exactly? So I do nothing. Let's solve for the first thing. We said that we only see one face, huh? So this smiley face, and I just keep smiley face, and like this. We saw only one face, but did it rotate?
It did. With respect to other, it is rotating.
If you see from the top.
From the top, the moon is rotating.
Okay. If you see from the top, the moon is rotating. But did you? Is it clear to everyone, or maybe some light will put us
So,
in the back?
for whom it is not clear, that's what we want to clarify, right?
Yeah.
Because we cannot be driven by some people saying that it is done. We want everyone to
Okay.
understand.
It is not very intuitive.
It's not intuitive.
No, I mean like, see like this, I mean rotation means what? This rotation.
Yes.
And when did that happen? Like, it will
When you-
this is no point. So here and
It rotated.
or in other words, what will happen if moon did not rotate? So what would we see? Like so this is what we see. If the moon did not rotate, what will we see?
You will see different parts of the moon. You will be able to see that side.
So, can someone enact what happens when the
Yeah,
Moon does
someone
not.
comes. Someone for whom you think this might be a bit difficult to explain to students. Anybody come, and then we will do this. What happens if moon does
Maybe you
not?
can go and show what will happen if the moon does not rotate.
And it does rotate.
And it does. So maybe moon does not, moon does not rotate.
means
Then what will happen? And do it slowly so that people
It will be better like yesterday's person.
Yeah, we can do that too. Okay. Yeah. Okay. Someone else comes. Please volunteer to be a moon. Anyone? I can be, yes, but I want other people to.
in fact, people who are having difficulty understanding.
They should come and see. Okay. Yeah. Come. Okay.
So who is who?
Who is that?
Okay. Oh, but she said that she does not fully understand. So then you have to be the maybe. Okay, we want to see the moon is not rotating. Then what?
The moon is not rotating, then what happens?
Yes. So can you please show moon is not rotating?
Start from the position where you face her. Okay?
The moon is not
The moon is not rotating, then what happens? Okay, that's what we are going to see.
Okay, stop. So you see what? You see a different part of the moon?
Yes.
Like you see the side profile of the moon?
Yes.
Okay.
See, Earth is also rotating, right? So Earth can see whichever
So you
part.
are seeing
Back
that
side,
part.
right?
Different, right?
Now this the
Different
other
side.
part, right?
Other
hand
side.
part. Yeah. Then back again.
It's like that. So when moon is not revolving, as the moon is not rotating, as the moon revolves, the earth will be able to see different portions of the moon. So from when you want to see only my front portion, then what I have to do when I'm revolving around it, I have to rotate just like
Slightly. Just enough.
So from here to here, see what happens? I rotate it like this.
You can take the mic.
The perspective.
So when I started from here, when I went for my revolutions quarter cycle, I made my rotations quarter cycle as well. When I'm moving here to get my half revolution done, I was like this. I came like this, and now I'm making like this. So I have rotated myself half as well. Okay. So when I go, I continue. 3/4 of my revolution, I have rotated myself 3/4. I was like this, then I become like this, then I become like this, I have become like this. So 3/4 of my rotation as well. And as I complete my revolution, I have completed my phases. I mean my rotation phases. Sometimes.
Okay. Do you see the difference? Okay, this is shown by this diagram. So the two phases of the moon, like the smiley and non-smiley. So here it is shown by the diagram. So the smiley and non-smiley part is basically the red and green part. So if the moon rotates around itself, this is what you see. The person on Earth, the Earth rotates. So that's why this stick figure person is at different positions on different days, on one day, different times. So anyway, so they will always see the green part of the moon. That's what happens, right? We see the one face of the moon only, that is the green face. Okay. And to understand how this is, and what is the moon does not rotate around itself. The moon at the top and here it stays the same. Do you see the difference? Yes. What is the? Oh. Yes, like she explained it very clearly. If it did not rotate, the same sphere is basically copied and pasted here. But here, the sphere has changed its orientation by 90 degrees. Is this, do you see that?
Yes.
Like this sphere, if you rotate by 90 degrees, becomes this. And then this sphere, if you rotate it by 180, it becomes this. And then more 90 more degrees, and then it goes back. So it is doing the rotation only slowly over one revolution time. So it is doing this, what we think this is, the rotation, only very, very slowly. Okay. This question, is it clear to everyone now?
Yes.
Okay.
And
So
also,
this is not the phases of the moon, huh? That's clear. Because the sun is farther away. We are just painting the face which can be seen, right? Which is towards the
Yes.
and sir taught yesterday, this is because of the locking of the
tidal lock.
That's right.
tidal lock.
This is because of tidal lock.
That word is nice. Tidal lock.
That also we can tell you how that happens, but later on maybe.
Yeah. Question. We have heard things and we have probably seen news articles that people went to the dark side of the moon. Chandrayaan went to the dark side of the moon, they said.
Yes.
Okay. Is the dark side of the moon always in the dark?
No. No.
No.
No.
No.
It's just about facing Earth.
Okay. Whoever thinks no, put your hand up. Okay, I see
It's not always.
what 6, 7, 8, 10. Okay. Whoever thinks this is yes, it does stay in the dark, put your hand up. Okay, I see a few and some are non-committed. That's okay. What did you see when you did the experiment? Do you remember this? That there was a sun here, huh? So, and this part of the moon was not lit up, right? You did see this. So this part, the smiley part was in the dark. The other part was in the sun. In the full moon phase, the smiley part is in the sun, the other part is in the dark. And then everything in between. So is there any part of the moon that never got sun?
No, they are always.
All got
All got sun.
Only polar region might be a bit.
The polar region does not get much sun. This is, but there is no half of the moon, no half circle, half sphere that is always in the dark. Notice the red half, say any half you can notice, but the red half on the this phase here, red half receives the sun. Here half of the red is receiving the sun because the sun is here. Here the red does not receive any sunlight. Again here some of the red receives sunlight and so forth. And same for the green part, right? So now you can tell your students if they ask that there is no dark side of the moon. But we call it dark, the side that we never get to see, we call that dark. It's dark for us.
Out of reach, out of sight for us.
It's the far side of the moon. That's the better phrase.
Out of sight.
Yes.
If a person is standing on the moon, will he observe the phases of Earth as well?
Very good question.
Very good
I want
question.
you to answer this. Yes. Exactly. I did not bring it up because I didn't want to confuse.
Yes.
Okay, let's think about this.
Yes.
The person is on the moon, say, and the moon is here. Okay. What does it see?
Earth will be lit up. Whole Earth.
Whole Earth is okay. Who agrees that Earth is lit up? If the person, the stick figure is on the moon, huh?
Earth
What
eclipse
is
हो रहा है, Earth eclipse हो रहा है.
No, eclipse.
Okay, let's not
Eclipse का भूल जाओ.
You're right. If it is in straight line, you will get it. But let's suppose it's not in straight line.
That is true. Yeah.
Then a phase of Earth will be seen.
Face of the Earth.
Full moon, full Earth will be seen.
Full Earth.
So, so do you agree that this is the sun? So half of Earth, this is not shown here. Top half is lit by the sun. Top half, the bottom half is not.
No. So moon person will
So
see.
day for this person, night for this person. This is fine. So this part is day, huh? This part gets light. So moon person, if there is a robot here, does he see the lynch part of the earth?
Yes.
Yes. Is that
Full part.
here?
Yes.
So for this person on the moon here, for new moon person, they will see a full earth. Okay.
Full Earth.
And then if the moon is here, now what do they see?
It will be dark side of Earth, so no Earth.
New Earth.
No Earth.
New earth. Do you all agree that if the
Yes.
Everyone is following, right?
if there is any question, please ask.
Not understand, please let
Because your students will have questions and they will ask. Right?
Correct.
So we want this to clear everything. So basically here they will see the night part of the earth, so it will be new earth. So just like we see moon phases, a moon person will see earth phases. Full and new we saw and everything in between.
Okay, one more question.
So
If that person was on the red side, what will he see?
For the red side person.
He won't see Earth.
he won't see us.
He won't see it.
For him, Earth is not existing.
For that person, the earth is not even existing.
That.
He won't know.
Like we never see the red moon or the red
The
moon
person in
does not
the
see.
red side or the far side, they are never able to see the earth. So they are like going around, but they don't know what they are
It
seeing.
is just on the back side.
So imagine that we are living on the earth, we can see the moon going around, etc. We can see it. But if someone was on the moon, they will go like crazy. What is going on? Why am I?
Around whom we are rotating.
So the person who is standing on the green part can see whole earth.
Not whole earth. If you
I
see
mean,
the
when
earth,
but Earth's rotation.
earth's rotation, they will see all the time.
So full earth.
There is another funny thing that happens, which is the earth stays exactly at the same place all the time. Ignore
For
it.
him.
Okay, like on the sky, we see the moon growing and then coming down and whatnot.
Exactly, because we are.
But for the person on the moon, the earth stays at exactly the same place. It just undergoes phases because of this thing, but it stays in the same place. It does not rise or set.
Okay, there is a rise and set after this.
Oh, okay, sorry.
No, but this is a good place to change.
Sir, one more thing.
Yeah, next.
If the person is outside, he will be able to see Earth and Sun both half lit, right?
Earth and moon.
Earth and Moon, both of them half lit.
Yeah, they will see the true nature of what is happening. Here we are limited by our position.
That is all the bodies in the celestial body, they all will be.
Yeah, because everything that is facing to the sun
Will
be half lit.
that half will be there.
Sir, I have seen some picture, Earth rising
I
on
will
the
tell
horizon.
about it. I will tell you.
Which direction does the moon rise?
East to west.
Somewhat
East से rise होता है. East.
Okay, we have boards for east. Any other boards?
Around east.
Kind of east. Okay. Anything else? West. Anybody has seen the moon rise in the west?
Yeah, you tell.
It changes as per season as well.
Exactly.
That thing, equinox and all.
Season also it changes.
Does it change or not?
So you are thinking northeast, southeast kind of thing? Or is it like totally north or totally?
No, it changes.
Okay, like the sun has a motion, right? Like this is the east, then sun goes like this, comes back. Does this उत्तरायण दक्षिणायन जो बोलते हैं, उसका इंग्लिश में क्या है?
Northern,
Northeast.
There's a Sanskrit. Okay, everybody understands. Okay, then it's fine. Uttarayana Dakshina. Okay. Okay, so which direction does the moon rise and set and why? East. It rises in the east. Yes. Both, yeah, 100% both. It goes down in the west.
Yes.
Why?
Because Earth rotates from west to east. Earth rotates from west to east.
Questions? Yes.
So is at one place and Earth moves, so why rise and set?
Sun is at one place. Yes. But okay, so let's just think about sunrise and sunset. Okay, forget the moon thing for a while. So Say I am Earth. Yeah, he will be the sun. And so this is the this is the person on Earth. Okay. So okay. Oh right. So I am Earth. This is my person. So this person is she seeing the sun?
No, it's a night time.
For her, it's night. Okay. Now I have rotated, Earth has rotated, sun is still there. This person here.
Sunrise.
It's a dusk.
Yes.
It's a dawn. It's a dawn period for it.
It starts to see a little bit of sunlight, and here
Midday.
Midday.
Noon.
And then
Evening,
here
evening and dusk.
because here it will stop seeing the sun because it's a round body. Because it is all sphere, things are happening like this. So because Earth is rotating, we see the sun rise and set, but the sun is not doing anything. And the east and west happens because we are rotating anti-clockwise. If we see from the top, I am going in opposite direction of a clock's motion. So like they say that the Earth rotates towards east. So we define east as that direction. So I rotate like this. So that's why I see that sun rises in the east. I start seeing the sun when I go east, and I stop seeing the sun when I go west. And like the sun, everything else, which is the next slide.
Stars, other planets.
Yes, stars, all celestial bodies, everything, because none of them are moving, only Earth is moving. So
they are moving slowly.
They are moving very slowly compared to Earth. So everything that was there, everything on the sky, they are all, I see them as moving from east to west, including moon.
And you have to think about that person standing like this. Okay, so over top on top of his head is that here. Then there is something here which is east and something here that is west. So we think that east and west directions stay the same because for you they are staying in some particular direction. But then as the Earth rotates, my west which was here now has become
That's correct.
So it's the directions which are moving because you yourself are everything else is staying in the same direction. You are moving with the direction. That's the reason why you see there's something coming up in the east and then rising, setting.
But directions are changing every time for us, right?
Yeah, exactly. Because you are moving. So you do it with respect to your direction, right? Your position.
Or
so
surface.
That's something that you have to keep in mind. It's again like very subtle things.
To be fixed.
It is better to.
For the better observation, anything has to be fixed as 0, 0. That is a better option.
If you go outside and see.
That's the best way.
Look, when human beings were
in
the early times, it was not possible even to think what it means, right? And how far these things were. Nothing was known. So
we need one reference.
We just directly wanted to make the observation, see where things are moving. That's
yeah, but you can put a reference point, and but then you have to do all the calculations like that. Generally, we put sun as the 0 point, and then all the solar system as sun. Okay. This is a question that.
One question.
Oh, okay.
As phases of moon as well as this eclipses, both are related with sun, moon, and earth. Correct. But we see phases all the time in same size. But these eclipses sometimes happen some. What is the main basic
eclipse?
So this is a very important question.
Very important question. Yeah, we need to.
There are a lot of confusions even among our PhD students. So when I ask why do phases of moon happen, some people say they happen because of the earth shadows.
No. Oh, can you?
That's not correct.
That's not correct.
So of course, so that's what you will say. But believe me, there are many students who will believe that. And who will have this?
I think
so you have to clarify this.
That picture of the eclipse, that picture is the best picture to illustrate this.
The moon one?
No. Yeah, where the 5-degree plane thing. I don't have this here. But okay, can I come back to this after this presentation?
Just like what I know, maybe because of the inclination of the earth and moon and the directional.
distance from sun, moon and earth, we have these two eclipses and this.
No,
there is
inclination of the
constant-
earth does not have anything to do with
Phases
it.
have constant, but
No.
eclipses sometimes happen, sometimes not.
Yes.
So that question that why full moon is not always eclipse.
One by one, let's take it one by
One
one.
by one, okay. I will just take this that okay, she is asking why eclipse does not happen every month. So did you see when you were doing this activity, this? Yeah, okay, I mean it may be clear for a lot of people, but it may not be clear for a lot of other people, and also many students have this confusion. I had this confusion for a long time, and I will tell you a little bit more about it at the end of this lecture, okay? So the question here, but in short, it's like, so if the sun was here and you are here, this we said it is full moon, but like you are standing, so sometimes like if you do this, you could see the full moon, right? It's lit up. But if you are like this, you are blocking the light. So like in reality, like if the moon is in the same plane with you, yes, it's true that like it is supposed to be full moon, probably will be full moon, but then when it comes to the full moon phase, you don't see it because you block it. But then the earth is blocking it. But in reality, this is not in the same plane. So it's like this. So we do see the full moon. But there are certain positions over the year where they will be in the same plane, same line. And that is best explained by a picture, which will come.
And distance will also matter over here.
Elliptic.
Sun, moon and earth,
Yes.
because as it is more closer, we can see more darker area. Or
Yeah, the distances matter when you see, like, would you see an annular eclipse or would you see total eclipse? But would you see eclipse or not? That's not.
Yeah. But even this thing, like you have to keep it like really high, right? This is not 5 degree.
Okay.
The 5 degree thing happens because actually right now your sense of like how big your head is compared to the distance between the moon and the earth, that is completely wrapped up in this picture, right? So if you take the size of the moon, the distance between the moon and the earth is so much that you will have to keep this ball like really far away.
Exactly.
And both of
So
them are very
then
tiny
even
balls.
like small 5 degree angle makes a difference. Okay, so then the shadow does not fall or from the earth will not fall exactly on the
Correct.
Okay.
So this 5 degree, it's not 5 degree when you are showing and conducting this experiment. It's only because these distances are wrong. So when you make the right distances, you only did 5 degrees, and then it will not happen all the time. But the phases, it happens with every rotation, right? Every revolution. So phases you will always see. For eclipses, you need a very special condition that the sun and the moon, the sun, earth, and the moon have to be in the same line.
Right.
Okay? In the same line.
Line and plane.
No, they won't be in the same line at that point. So if they are not in the same line, you don't see an eclipse. 3 points are always in a plane. So that's the reason why I'm being careful and not using plane.
Yes, sir. Very true.
3 points, they always lie in a plane.
Yes. They always define a
So that's the reason why I'm not saying plane.
revolution planes become the same.
There is the revolution plane, the line joining here. So, yes. I'd like to be a little bit so careful. That's all.
Yes, sir.
And then right, yeah, this we can do. Okay, let's do it after we finish. Okay, this question, I'll put it in presentation now. Yeah. What is the rise and set times of moon throughout the month? Okay, I mean, does the question even make sense? I mean, it always does it always rise in the sunset time? I mean, in the evening and it goes down? No. Okay. So it changes? It changes. Has it happened that you came out and you did not see the moon and it was the evening?
Yes. Yes.
Okay. So, have you noticed that different phases of the moon has different rise and set times? Okay. Have all of you noticed this?
Yes.
Yesterday you learned. The moon, yesterday the moon was in the sky though, right?
Yes.
It only clouds and stuff.
Yes.
Okay. So let's think about this. So now we kind of know, from experience we know that it is different for different phases. And so how? So first, we come back to this picture. It's a similar picture only. So there is the sun. This is the moon I have put here and earth. The earth rotates like this. So the same person can be in A, B, C or D position. Okay. Okay. Forget the moon. Just consider the sun. At which position the person will see sunrise? A, B, C or D?
Sunrise.
A. Okay. Any other answers? Okay. So we say sunrise. Sun is always in the sky, I mean clearly. But we see sun when it is above the horizon. And this is a spherical body, round. So for them, the horizon is this line, right? What is this called? Tangent. Tangent line at every point. So the horizon also keeps rotating. So, it's a plane, right? So at position A, the plane goes to like this. So you can just start seeing the sunrise.
Correct.
Okay. So that's what the sunrise is. Let's say that is the morning. Okay. Next question. At this position, what is the phase of the moon? Although I have already written.
Full moon.
Full moon. Everyone agrees. So consider the moon is full. At which position A, B, C, and D, the person is seeing moonrise?
Moonrise.
Moonrise. C. Everyone thinks this is correct. So this is similar thing. So whenever we see the moon just above the horizon for C is a plane which is tangential to the Earth's round body. Okay. What is the approximate time? What is approximate time when they are seeing moonrise?
7 to 8 years.
Okay, not that. So like sunset.
Around sunset.
So C is with respect to the sun, it is seeing sunset also. Yeah, okay, let's ignore that. Like sometimes the sunset happens at 4, sometimes at 6. Let's ignore that. But here, basically we are seeing that full moon rises as the sun sets. So the C is simultaneously seeing the last of sun and the first of moon. So you will see that the full moon rises at sunset.
Have you seen that?
Have you seen that?
Yes.
Full moon, when you see, it happens is the sun just sets in the
full moon rises in the east.
Purnima, etc. You look, the sun sets and immediately the moon is in the sky.
So you can see it for the full 12 hours. Okay. What happens if the moon is a new moon? That is not shown in the picture, but the moon would be where if the moon was new moon?
Above B. Above B it would be.
Above B. Somewhere here.
Right.
Is that correct, everyone?
Yes.
Okay.
There are confusions? No, right? Or
Okay.
yes? If yes, tell us.
Okay. So new moon is somewhere here. So which ABCD will see the moon rise? Forget the where. Which person?
Whenever you get confused about new moon, think about this experiment. When were you seeing new moon, right?
A.
Person A will see sunrise. Person A will also see the start seeing the moon, if it was possible.
New moon.
Okay. So
No moon, but you can see that little bit.
That's it. And so the new moon does rise,
but is not visible
in the morning, but it is not visible because of how the position works out with the sun, like we saw.
So there is one more thing that I want to ask. So let's suppose there are stars which are in the background. You wanted to see the moon, right? Then how will you say that yes, indeed there is a moon there? It's a new moon phase.
behind that something should be there, it won't be visible.
Okay.
In the
Is that
sky.
clear? It's blocking the light from the background stars, right? So that will still happen. Even if the moon is seen as dark, you won't be able to see like stars through it. Okay? New moon does not mean no moon. It just means that it is there, but you are only seeing it as dark.
It doesn't have like.
So if there are flags which show stars within the.
Oh, I have that too.
Oh, you have.
No spoilers. So okay, so half moon. Okay, we have seen two extreme positions, but I mean your students, if they go to some exam like talent exam or something or Olympiads, they don't ask full moon, new moon. They will ask something else. So let's say the moon is half moon. Where is the moon?
Either above A or above C.
Okay. Any other answers? Half moon. Where would they be?
At A or C.
A or C? Everyone? Okay. Let's say they are at A. They are at C. Let's say here. Okay. Half moon. So the moon is here. Which person will see moonrise?
B. B will see.
Moon is here.
B will see the moonrise. Actually, D. B for ball. No?
Also notice how the earth moves.
Right. Moving like this. So B point is going to see first. D is going to set it.
Who is going to see it?
Moonrise.
Moonrise will be at
Moonrise. Okay, let's take some boards because I see different answers here. Okay, moon is here at this position of the green laser. Who thinks moonrise? A will see moonrise.
No.
No one. Okay. Who thinks B will see moonrise? Okay, lots of people. Who thinks C will see moonrise? No. How about D? Sunset. How about D? No. Okay, so everyone agrees. So basically, the art rotates like this, and if you are at D, your horizon will be just able to see this. So at C,
Far away, huh?
moon is very far away.
That's the reason why you start to see.
So here. Okay. So B will start seeing the moon. That is clear for half moon. What is the time for B? For B, what is happening? What is the time? Evening.
For B, it is mid.
For B, you think it is evening?
Midday.
Some people think it is midday.
It will be midday now.
What do you think?
It is midday.
Midday, you think? So the time of the day, you look at the position of sun. So all we are looking is morning, noon, evening or night. So for person at B, is it morning time or noon time or night time?
It is midday.
It is noon, right? Because the sun is overhead. For B, the sun is overhead. But then B will start to see moonrise if it was possible, right?
It would be.
So yes, have you seen? So this does happen. So at C half moon, a person will start to see half moon in the noon time.
If it is possible, because sunlight is
very bright. Yes. But have you seen ever moon during daytime? Yes. Lots of people think it is not possible. But I mean, you just have to go out and see. It is totally possible, and it is possible we can see from here, right? So moon can rise at all times of the day, at sunrise, noon, sunset, whatever. It depends on the phase of the moon. Only the relative position of moon sun art system. So you can just whenever they just ask like any random thing like at third quarter when the moon rise, you think of this kind of diagram. You can like do a little diagram on a paper and it will be apparent. You don't have to remember.
Is there any periodic like fixed time of rising of moon and setting of the some fixed time is the difference?
50
No,
minutes.
because like we are seeing here, full moon, but we do know that full moon will rise at sunset. This is true.
No, she's saying
the time on the clock?
Yes.
Yeah.
50 minutes.
No, that is not set, right?
So I mean,
It's set with the
what you can do is you can see that as the Earth is rotating, like if the moon was stationary, right, then you will always see that, so let's suppose the moon is here, and now the earth is rotating, right? So the earth starts rotating, then you start to see the moon rise here at sea, then you go back again, you see it again at sea, right? But remember, the moon is not stationary, moon is also moving, right? So within that one day, the moon will also have moved. So when the moon moves,
Here.
in which direction does it go?
It goes like this.
So if it moves like this, what you will notice is that the earth has to now,
Rotate
you
little.
cannot now see it at sea, because it has moved in its position. So now it will be seen at a different point of time.
Little more.
Then at a different point of time.
Yeah. So like the new moon will rise at say 6 a.m. and then the next day it will rise at 6:15. I'm not saying this correctly, but there is a difference. Huh? Every day the rise times will
Change by like 60
change
minutes.
by some time.
How much difference will be?
It's like you can actually work it out.
You can work it out because
What you do is you take the
divided by 14.
30, right?
Oh yeah, I mean
Yeah,
6 a.m. it rises when it is new moon. Full moon it rises at 6 p.m. and in between there are 14 days.
Okay, like that.
And then so how?
That's another way to do
So 12 hours.
Exactly.
Okay. Yeah, so these are simple calculations. Only the geometry, if you remember, it's pretty simple. But otherwise, it's a bit difficult.
So these calculations are given in Pancham.
That's what they use, but you can also do it. I mean, there is nothing complicated. It's just you need to know how much it moves and what the periods are. That's
Periods are, yeah. So colloquially we say that the moon goes around the earth in 28 days, but the exact number 29.5. Okay, we got one vote. Have you heard of this number 27.3? No.
There is Titik.
Okay, some people have heard. So yeah, so these both are correct, but their interpretations are a bit different. If you ever see these two numbers, what this means is this. So say it starts from here. Okay, so this is the new moon they will see, right? So 27.3 days later, the moon comes in the same position. So this figure copied and pasted here. So the moon will be here. So with respect to some very, very distant stars which are like there, the moon is back in the same position. So with respect to say this check, its input signal, this thing, the moon is facing this, and 27.3 days later, the moon is again facing this. Okay, the moon is back in the same position,
but not the same thing.
The earth has moved a bit during this time. So even the moon is in the same position with respect to the distant stars. It is not blocking the sun rays. For this, it has to go. The moon has to cross a little bit more distance. So that is 29.5 days. So new moon to new moon it takes a bit longer.
Why is the earth change? Because of the parallax?
No. Earth is going around the sun. That's the revolution.
1 month time, no? So it goes
1 month. So it has gone like 1/12 of the whole circle.
almost.
Okay, so these two has different names. 27.3 back in the same position, called sidereal month, and this is called the synodic month, new moon to new moon.
In Marathi calendar, we see that some tithis are kshay, means they are merging into one another. So it is just to have those 30 things crumbled back to 29 or something. So they just that.
Yeah, so because they have to, I mean, it is based on the moon, and the moon has all these complicated features. You are trying to fit in some number
30 and 30.
which is related to the Earth's rotation period and so on. So that's why you have to do all this stuff.
Okay. This question, I think someone asked this today. No. Okay. Someone already has said no. I mean, we do have the same, I mean, we do have only one moon, right? But the directions are different from where we are.
The parts of the moon will be different.
Parts of the moon they are saying instead. Okay. So this can be divided into two questions. Do they see the same moon phase?
No.
Yes.
Okay. I see yes, I hear yes and no. So I am in India. If I see a new moon, a person in America, will they also see new moon or something?
They will see new moon.
No.
Okay, different. Okay, some people are saying they will see different phase.
Yes. How is different? No. After
Okay.
some time they'll see the face, but they'll be able to see the same face.
But at the same time. Same time.
No, not same time. I mean at night and night. Or whenever.
So by 12 hours, how much phase?
Okay, okay. We have two, both we have. Okay, we will discuss. Are they exact same or do say anything different? Yeah.
Slightly different.
So the moon phase, I don't know if I have another slide.
It will be 12 hours difference in the 12 hours, right? It depends on what light.
So think of this. The moon phase, the phase of the moon depends on where the moon is, right?
With respect to
Like
sun.
you are here, yeah, here. So the new moon is here. So as the earth rotates, everyone will go back and see the same position, right? Like even in one day, the moon will not move that much, right? So like I see moon when and a person on the opposite side of earth, for them they see 12 hours later. But in 12 hours, the moon will not have moved that much. So practically moon will be in the same position in space. Right? So when I see the moon, I see that the moon is moon. I cannot see because it's new moon. And when sometime later the other person from other side of the world, they are also going to see the same configuration.
Almost.
That the moon is here and the sun is here. So for them, it will also be
The same.
the same.
My question is about latitude. Latitude. If
Okay,
I'm
yeah. This is the next question. Okay, we'll just get to this. But does everyone agree that they will see the same moon phase?
Yes. Almost the same.
Is there anyone who does not agree?
Almost.
Or
the
does
same.
not fully understand?
Does not fully understand.
Yeah. Please repeat.
Okay.
So please always feel free to say.
Please, because then that is the point.
Explain it with an example.
You are saying not
Yes,
that
yes.
much of moving, whether it is moving or not.
It is moving, but that's not noticeable.
Not that much of moving is the word which.
So let's say the new moon phase we are showing. I am Earth. Okay. So this is the new moon phase for a person. Okay.
Someone has to hold it for
Okay.
you.
Yeah. No, okay. This. No, it's fine.
I can act.
This. No, it's okay. This is the person. Okay. On Earth, right? Okay. So this person, this person sees what? New moon?
New moon.
That's fine, right?
Someone has to hold it for you.
Oh, right. How am I going to do this? Oh, okay.
Smiley towards her.
Okay. This part, okay. And then I rotate, right? So this person in the back, like my hair, they haven't seen the moon yet.
Yes.
Okay. Okay, right. So my hair, whoever is this person, my hair, they are seeing the moon now.
Yes.
They are also seeing the same new moon.
Yes.
Right?
But at the time of your spin, that is also having.
So let's try to calculate that, right?
Well,
How much time does it take for the moon to go around the Earth?
29 points.
29 days. How much time does it take for this rotation? So how, like which one?
12 hours. 12 hours.
Just 12 hours. So 12 hours compared to 29 and a half days.
It's very
Yes, it does move.
Move a little bit.
Not much. Exactly, but it won't be like, okay, suddenly from new moon you are seeing like something like a vaccine.
Number identifies only. 12 hours and 29 days. Compare.
Yeah, that's right. Yeah. That you can give this as homework to students. Compare. Are they exact same or do they see anything differently? And this was a question she asked. Okay. So the answer is this. The moon is the same. So look at the two persons.
Okay, their location in the sky.
Look at these two persons. For this person here, this part of moon is the top, and they think this is the bottom. I mean, that's what their perspective is. And for this person here, so for them, this is the top, because that's where their head is, and this is the bottom. So that's why this is a real picture from UK. So if you look at this square, so UK, this is at the bottom, and Australia people, they're seeing it as the top.
But
The moon is same, the portion is different. The moon is same, portion is different.
No,
This is the same. They are both seeing full moon.
but
The orientation is different.
But if it is a half a day in this or say vaccines, if that person is seen like this by this fellow, that fellow will.
Yes, that's right. That's exactly right.
Dark part will always remain the same dark part.
Same dark.
Only
its orientation. Just
So the
because
C might be like this or this or this, but it will be a C. It will be a crescent.
and it's the same part which will be lit.
Same part would be. Okay, not much left.
What happens to the polar people?
They say always.
Polar people. They will also see the
Nearby polar people.
So can you go a little bit back? I want you to ask you to do another calculation. Okay?
Yes.
Then horizon.
This one, okay? So you see, we have drawn this in an exaggerated fashion. Is a man so tall compared to the size of the earth?
Of course not.
No, right? It's extremely tiny, right? But if someone was so tall, then they would see slightly different portion of the moon.
Yeah.
Slightly different portion of the moon. This one would see slightly different portion.
Right. The thing which
So
happened
it will be a little bit different, but you should calculate how much different. Okay? And this depends upon the ratio of the size of the tank to the size of the earth. And you can compare how small this is, and that's why it will be basically the same. There are other interesting things that happen. So we were saying that you only see 50% of the moon, but in reality, if you like observe for a longer time, you will see that you actually see more portion of the earth.
60?
So it's about 60 to 70%.
No, these are full of-
I think 60%. We don't have it. So you see actually a little bit more of the. Can you guess why it might be?
Precision
angle.
The planar position is.
Planar position.
See,
There is also a tilt. Yeah, so you see, there are multiple different things. One is that the orbit of the moon is elliptical. That's the first thing. That's the reason why you see slightly different portion. So there are chalk.
It is supposed to be such a simple, but what?
This is the earth.
Details.
And this is the moon. Then from here you are seeing this portion. By the time the moon reaches here and looks something like this, you start to see also this portion. Okay, so it's not just the same half. Okay, here you are seeing this half, but by the time you go there, you start to see also the other half. So not the other half, but a little bit more of that, just because of the elliptics. Okay.
And
In addition, there is also tilt, right? And so because there is a tilt, now let's suppose this is the moon's or the Earth's orbit, in the plane of the Earth's orbit in the sun, around the sun. Now the moon is going like this. So when the moon is here, you see this bottom part. When the moon is here, you see the top part. So in reality, it is slightly more than 50%. And that is another calculation that you can do, which will allow you to figure out what the tilt is. You can also figure out the ellipticity of the moon's orbit with these kind of numbers. Okay.
The spin geometry is elliptical only. The modes of.
Yeah, this geometry is elliptical. Their orbit, it's just dependent upon the gravitational force and how objects move in gravitational force.
And
that is in ellipse.
Even elliptical plane helps to visualize a more dimension.
The only problem is when you show the ellipse, don't make it too elliptical, because if you make it too elliptical, then people again get wrong impressions.
Right.
If I draw the Earth's orbit, you will not even notice the ellipse. Okay, so there's slight more complications than will be covered in the textbook, but we are just telling you that this is also something which is there. Doesn't have to go to students at this stage. But
okay. Does the moon go around the sun?
This was a question. Along with Earth it goes.
Okay. Some people think yes.
Along with Earth it goes.
Anybody thinks no? Okay. Some students do think no.
There is a word they use now, epicyclic path.
Yes, that's the word. You're right. I didn't find a good jeep. All the jeeps were pretty much wrong. So I'm just showing you this picture. So yeah, basically moon goes around the earth, but the earth goes around the sun. So moon will be doing like this.
Jumping part. They call epicyclic.
Epicyclic, yes. And so moon in a fashion does go around the sun as earth goes around the sun.
Yes,
dragging things like that, okay?
Where is jeep? You are going to show jeep?
No, I didn't find a good jeep. They were doing wrong. This question was asked yesterday, so I added it this morning. The blue moon, the pink moon, and other things. You have heard about it, and what is it? Even I didn't know about it. So honestly, I googled it and I found what information. I'll just show you. So it doesn't have anything to do with the actual color of the moon.
I said blue moon.
No. The blue moon is what they call. So we have 12 months, and so we should have 12 full moons in a year. So there are 4 seasons. So each season should have 3 moons, 3 full moons. Sometimes it so happens because the year has 365 days and the moon is 29.5, it becomes a full moon again. So because of this, in some seasons, some years, there will be 13 full moons, not 12. Like a leap year kind of thing. So in a season, there will be a 4th full moon. If that happens, they call it a blue moon. There is another definition. If in 1 month 2 full moon comes because of these reasons, they call it a blue moon. That's it.
They're just happening once in a time like that.
Once in a blue moon. Once in a blue moon. The pink moon, so these are from, I think, North American or European mythologies. So they call it the full moon which comes in April, they call it pink because there is a lot of spring flowers blossoming at that time. The moon is not pink. So they have this whole kinds of things. So this is from something called Farmer's Almanac. So in North American farmers, they have different names for different months full moon. So like there is snow and then there is April is pink. So they start from January and April is pink and then this is called flower moon. The May moon is called flower moon and then you have all kinds of different things. So this has all to do with the Native American people who used to live there. And so they grow these things. So whenever like the growing season happens or that particular animal is like seen a lot, that's how the mythologies are born. And this is the last one. Do you see anything wrong with this image?
The crescent is too much deep.
Crescent is too much deep.
There are stars in the dark part. Crescent should be on the other side.
Crescent should be on the other side.
But it can be on this side as well, no? Both sides. Oh, the round, the shadow, naturally, it is the same thing. It is the same thing.
We are getting many different right answers. Multiple things they are wrong.
We will not see so many shining stars around the moon because moon ka jo light hai.
But it's only for full moon. Yeah, it's not like that.
Yes.
Crescent is 2D and the shadow.
The stars it's a crescent.
That is the main answer we were looking for, but we also got some other right answers.
What? What was wrong, please?
This is a Shahid's drawing. But the moon is basically this. I mean, moon is a solid body. So, even if this part is dark, you cannot see stars through it.
I missed that.
If you see the difference, yeah, like they put stars here. They shouldn't.
Yes. So nice.
And you are also right that the horns of this crescent should be a half circle. The crescent should be a half circle exactly, because when you do the activity, you will see that it is always the light can always reach the topmost part and the bottommost part. So this will be like the C.
Connective arc in between.
The arc is always a half circle, like this. It cannot be like this. This you will see some places they do draw crescent moon like this, but this is wrong. Because the sunlight can only reach this, right? How will they reach this part? They can't.
That's good.
Ma'am, can you show previous slide, please?
Yeah. Yes.
Eid.
Eid
festival, yeah. So that star is also seen along with the moon.
But on one side. It's one side, either it is Venus or something.
Like this image they show.
No. On the bottom side it will be. It's above the below the crescent.
I don't know what this is.
Not in the dark part. So if any star or anything is shown, it cannot be here.
Yes.
It has to be beyond the lit part. I mean beyond the
unlit part.
And so there will be many flags that you will see which will get it wrong.
Correct.
So you have to be careful about these aspects. There will be multiple flags in which these things are wrong, even for existing flags of countries.
Yes.
They will show moon and a crescent, and then they will show some star. So you have something like a star in between, and that of course cannot be done. And then the second thing, as she said, like these 2 points are diametrically opposite. The horns of the moon, they are always diametrically opposite. So sometimes what people will do is they will draw a moon like this, and then they will draw another smaller circle like this. That is not the right way. I mean, that cannot happen.
You
But now
exactly
you
cut it
have
off.
observed.
You cut it off and you connect it.
You cut it off and then you connect it
Yes,
somehow.
exactly. Then you connect it in different ways.
Okay, that is all the moon fact, and I have like 1 or 2 slides on a little bit of the astrophysics of the moon. Just to get into the science behind it a little bit.
How was the moon formed?
Yeah, how was the moon formed? That is the question. Formation of the moon the formation of the moon is connected with the formation of our solar system. The solar system, you have learned about how stars form. So when sun was very young, so it was a protostar at that point. So the sun is here in the middle. So the sun starts to burn, and then there is a lot of gas and dust and rocks beyond the sun. So this is distributed in a disk fashion. Why is it a disk and not some random structure? It has to do with physics, because the whole structure is rotating. So the disk is the most stable part, stable orientation where it can be. So this is what we call a protoplanetary disk. protoplanetary disk has a lot of this material. So there is like all this gas you see, this chunks of rocks you see. So as time goes by, all of this gas can come together. These rocks are also have gravitational pull towards each other, so they can come together. They can form bigger rocks, bigger bodies that will eventually become all the planets. And in the process, some of the littler bodies will be captured by gravitation of these bigger planets. They will become the moons of these planets. Earth has only one moon, but other planets in our solar system has many moons. So the bigger the gravitational attraction is, like for Jupiter, it has how many moons?
92
moons, because Jupiter is so big and has so much gravitational pull.
I think Saturn has 140 something.
Saturn has 140. So yes, Saturn is also very big, and Saturn has all the other things going on, the ring and stuff, which we discussed during the tides. So I will show, this is the last slide. I will show you a video. This is a simulation. So scientists think that there were some ancient planetary collisions which happened. So at this time, the Earth is not a fully solid thing. It's like a jelly kind of thing, like the molten core that we have still. So at that point, there was another big, like smaller than Earth, like Mars size thing that collided with Earth, and that gave rise to a lot of different interesting phenomena. So do you see this? It's like it's going through a jelly or a liquid at that point. So some parts of the Earth, it got dislodged during this. And this little part here
got back again.
Yes, these are very violent collisions. So only after some time, at the final product, so this is a zoom in part of this. Yeah, so that part, this going back to Earth, this little part becomes the moon. So this violent interactions also tilted our Earth. That's how the Earth got the 23.5 tilt.
The very rare events.
Very rare events, yes. So if the moons can form like this from a collision, and parts of the planet becomes the moon, but also in most cases it is captured. Things are captured and then it just goes round and round into an orbit. And this is why the composition of the moon is very similar to composition of Earth. Yeah. So that's it.
I have one question. The Earth's axis also changes sometimes, maybe because of tides, as yesterday you discussed, or maybe because of tsunami. Read it somewhere.
The Earth's axis has a precession. It is on a very long time scale, which will be discussed, I think, in the afternoon session during seasons. But like right now, the Earth's axis is like this.
Yes.
This axis goes around in a small circle.
Okay.
So to do this, I mean, it's like a top black two. So like this, it precesses, but this whole thing takes about 22,000 years.
Okay.
Yeah. So that's why they say that so we are at this point. So the pole star. Yesterday you may have seen the pole star. So basically the north pole is pointing towards the pole star. But you can see from this picture that when the Earth's axis will change and it becomes this, then it will not point towards the pole star. It will point towards something else. So if
that
you
will
see
be
like
proposed.
text from few thousand years ago, they talk about something, some other star that is their guiding star. Because the stars don't change their positions. Art is.
Right. Just because it was connected to solar system and moon, so when the sun was forming and the planets were forming, isn't like planets like were not able to form sun, like they could have formed sun also, like in a solar system also, can they be more sun or
But
star?
size is very small.
Because for planets, but
So yeah, so there is a phenomena where if you don't have enough gas and enough mass to start the fusion process, you don't become a star. You become a dead thing. I think it's called brown dwarf. And there are lots of brown dwarfs. They are slightly bigger than Jupiter. So our Jupiter could not be brown dwarf. They become a planet. But it's basically everything here is a function of mass. Depends on how much initial mass you have. Because depending on that, you become a star or you become some planets or something in between.
Earth also would have been once sun, star, and then the planet.
No, Earth is a rocky planet. So these rocks were, so Earth never had like this gaseous body because fusion is only possible if you have hydrogen and helium, hydrogen gas inside it. So Earth, these rocky planets, they form from rocks that are floating around.
Okay. So Jupiter
So
once
when
it had the potential to become a star.
Not enough mass.
Not enough.
So when the planetary disk was getting formed, the rocky material could not be thrown away at a longer length. That's why those rocky planets are the inner ones. And the gases could flow out little longer.
That's why the gas planets are far.
So which planets they got collided or whatever has happened, they only have moons. Exactly.
No, the moons can happen like collisions, but it can also happen that this like Mars is here, some random solar things, it just gets caught in its gravitation and it cannot escape. Like
So
sun is pretty far away. Like so they are all moving randomly. So when they come close to this planet, they may be captured by the planet's gravitation and then they start rotating around.
Some of the moons are captured.
One more smaller part would be there, so we will be having one more moon. We would be having.
So that's why I said the collisions are quite rare because the Earth is also small, right? So in this case, we just have a moon. But yeah, I mean, it's quite violent, of course. If there are things which start to fall, like if this kind of a big thing comes and impacts the Earth, everything on the Earth will diminish today. All life will almost be
We'll be starting from the beginning.
Yeah. So there is one small thing which I.
Oh, we want to discuss the eclipse.
Oh, eclipse, yes.
We said we wanted. Yeah, you will say I will find the picture that I want.
Okay.
And it was describing an activity which is.
Oh, sure. Yeah. No, so one other thing that I wanted to mention is between this life cycle of stars, right? So you saw that most of the universe is actually composed of this hydrogen. But then in our bodies, we get all this carbon. I mean, all these organic compounds are formed from carbon, oxygen, and hydrogen. So where do these things come from? These things actually are manufactured within the guts of stars. So that is another important thing to remember. It's whatever is there in your body at some point or the other was in the stars. And it got formed inside of stars. It's only when the stars exploded either by this planetary nebulae or the supernovae that the guts of the stars got spilled out. And it is from these small things that then you start to form planets and even things like us. So you cannot manufacture the carbon that is present in your body in any other place than the sun. I mean, than the stars, not our sun. It must have been a star before the sun, from which sun is made now.
Yeah.
So that's a very important fact to remember. I mean, we have People have all these divine connections that we try to make, but we have this own connection with the universe itself. We things that we are made up of. Many of these things were part of stars themselves. So we have this cosmic connection with the universe. It's something that every one of us has. That connects us.
But the procreation that the animals, I mean, the living beings do, isn't it getting diluted with every generation?
What is getting diluted?
The connection.
No.
No, we are only
No,
recycling.
because whatever you do, you are not creating and changing other atoms into, like other nuclei into different nuclei. Right? You are not doing nuclear reactions. No. Procreation is not doing nuclear reactions. It is just rearranging material which is already present on the Earth. That's another thing that you should think of, right? That all the material that is there on the Earth is just getting recycled.
Still coming from there.
No, not coming from. I mean, there's very tiny material which still rains down, but that is nothing. I mean, in terms of kilograms, it will be a huge amount, but compared to the mass of the Earth, it's nothing. So whatever we have on the Earth, it's all getting recycled. Like molecules which were there inside me at some point will go inside you, and all these things. Right? So it's all the same thing. And at some point or the other, it was in the guts of, it got manufactured in the guts of stars, and it got split up. The cosmic connection is there for us. It's just not in the way that many people had imagined. Right?
Will we be touching neutrino and those other things? Shower of neutrinos and cosmic radiation, will we be touching it or?
No, I don't think we can. We will get time to do that.
Yeah, I mean, it does come. We do see it. You can also have these cosmic ray detectors. If you go to some science museum, you might be able to see a box, cloud chamber.
Cloud chamber.
Yeah. So you will see things coming, but neutrinos are extremely tiny. I mean, the masses are small.
We also have one.
The mass that bombards Earth, if you count in terms of kilograms, it will be large, but in terms of the mass of the Earth itself, it's very.
Yeah, you had a.
I just wanted to share, like I read that, the gold that is there on Earth, it was formed in the position of the neutron star.
Yes.
It's true. So everything except for hydrogen and helium, nothing was there in the universe. So like inside us we have carbon, nitrogen, oxygen. We have a lot of water. Water has hydrogen and oxygen. So all of this oxygen, they've all got made inside the stars, like you were saying. So everything that you see, they talk about gold because that's a fascinating topic to write about, but everything.
Periodic table.
All the periodic table.
Until iron can form in the guts of stars. After that you have to go through some extra processes which require like neutron-rich processes. So then some of these happen when neutron stars collide and either form a bigger neutron star or a black hole. At that point of time, you can synthesize these even higher kind of things. Because you need this neutron-rich and so all these things, they form. I mean, there is an astrophysics connection to it. You cannot just form it out of nothing. Okay.
Okay, eclipse. The last thing. So why eclipse happen? Why eclipse does not happen all the time? That is the question. So we can show it by objects here, but let us first understand this picture. I think this picture is very beautiful. So basically, the sun was this bulb, you were this person, Earth, and you saw new moon and full moon. But do you see that the two planes are not in the same plane? By that we mean that there is like this, it's a bit tilted like this.
5 degrees.
We are showing a lot.
Exaggerated,
but 5 degrees must be like this. Okay. So imagine in this position here, this moon, let's just talk about full moon, okay? So here it will go like this. The full moon is a bit below the plane. So this is the Earth's plane. This is the Earth's plane. So this is the sun. Okay, this is the Earth's plane, and this is the moon's plane. Okay, so this is where the moon is. then you can see the full moon. Because the moon is not being blocked by the earth. Is that okay?
Yeah.
Like the activity yesterday, this short person and tall person, things like that. So here we do see the full moon. When I was a student, this was we had this our syllabus had this thing a lot, and we always had this question asked in the exam: why don't eclipse happens every new one? This answer I knew, 5-degree angle. But what I did not understand until quite a long time is that why does it happen at all then? I mean, it is always like below, so how do we see eclipses? So that was not answered in our book. This was West Bengal state syllabus book.
I don't think it is necessarily answered in any book.
In every book, yeah. So I think it is not really discussed, this later part.
They are intersecting somehow. So in that intersection,
Yes.
is it,
So imagine that this whole plane gets moved, right? So this plane, no, I think your activity will be what you were showing. Huh?
So, say, can you show the, can you put on touch later?
Put this.
Just hold it.
Okay.
Towards this side. You just hold it
Someone's eyes.
No,
Oh, just here.
no, I will do it here.
Okay. So, say this is the solar plane. Okay. Solar
Plane of the earth.
plane of the earth. Sorry. Yeah. And say this represents the plane in which the moon is rotating. Okay. Say you have this Dell logo in between. Say this is your earth and your moon is going around like this. Okay. If you put it like this, so this is, say this is exaggerated, say this is a 5-degree. Okay. Whatever tilt you decide, keep it like that only. The plane doesn't rotate like this. Okay. So
Shall I put the laser
on this?
tail?
Yes. So okay, right now I can say it, but you see that if
They cannot see it.
yeah,
I'm like this if you can.
No, no. You can do it.
Yeah.
yes. So maybe okay. So maybe this is, say this is a moon, this is a sun, and this is earth. So you do see this part lit up. Okay, but if this goes on this side, put your torch on here. So you see this is on the edge. So if the moon is at this location, this light gets blocked. And you don't, so this is the location where your eclipse happens. Okay. If the plane, notice the plane doesn't change. Okay. If this is on this side, you have earth, say you have a moon, you don't get eclipse essentially. You get, say, new moon on this side. And if it is, the laser is on this side, it's a full moon. Yeah.
Just think about these distances, okay, and the shadows and how long these shadows are. You can make some of these calculations very easily. Just realize how big the moon is compared to the shadow, etc. You'll see how tiny these angles are.
Yeah, so the same thing is shown in this picture. So the same plane is just transported here, but you notice that it is possible for moon to come in this Earth-Sun line. The moon is crossing the Earth-Sun line here, but here the Earth-Sun line, the moon is in a different plane, so it is not crossing. So here in this position only, eclipse is possible. In either this position or anywhere in between, eclipse is not possible. That's it.
And if the plane was moving like this and tilting on this side, then you will never see the eclipse. Right? Because this thing, this thing would have become like this, then I mean tilted at still 5 degrees. But the orientation, if it would have changed, then you would not have seen an eclipse. But this orientation just remains the same. That's the reason once in a while it does appear. So you may have heard about this thing called Rahu and Ketu.
Yes.
So that is the intersection of these two planes. The imaginary points along those lines, they are called Rahu and Ketu. And that's the reason why when the moon comes in whatever Rahu or Ketu, one of these directions, that's when they say eclipses are. Because it's these imaginary points in the sky which correspond to the intersection of the moon's plane of orbit and the Earth's plane.
There is a connection between astrology and astronomy.
That's not what I'm saying.
Definitely not. Definitely not.
All I'm saying is they used to do the calculations. Doesn't mean that they got the physics.
There is no
Because
Rahu, there is no
calculations correctly and still get the physics and the interpretation. So, for example, yeah.
The horoscope.
Yes.
What they say is the Leo is in August. So what that means is, if you see the sun, behind the sun, this particular constellation lies. That is true. So in different months, because we see so the sun is there, I am Earth, right? So and background is all stars, right? So for this position, I see sun, and behind sun there is some constellation here. Okay, there is some constellation, say Leo. Earth moves every month, and then I see constellations which are over there, which is different, right? So every month, that's what they call that the sun is in Leo. It's not. I mean, its sun is in sun's position. Those stars are very far away. For us, it looks like that they are belonging in that constellation. So
It's the same direction, but not that sun is moving somewhere.
And this constellation stars also has nothing to do with each other. We just see them as a group or some nice looking structure, but they may be very light years away from each other.
But in many astronomy books it is mentioned that sun is passing through the constellation.
No, sun appears to.
That is apparent movement.
It is apparent. It does not go to.
It doesn't physically move to the Leo constellation or Leo stars, but it appears to be in sky, which is completely true. What is not true is that because I was born during the month where sun was in Leo constellation, I am having this characteristic. That's not right.
Otherwise, 1/12 of the people in the whole world would be like Elon Musk. There will be always someone who will be born in that month.
They will say all Scorpio will be getting promotions and that does not. So yeah. Okay. That's it.
Okay, so let's go and have lunch. It's 1 o'clock almost. Shall we?
So we leave them. I will leave.
Okay. No, okay, don't leave.
Oh, I will.
Yeah. So that we are recording it also to YouTube, so then you can see it later also. Of course, see, we have only one camera, there is something, so not everything you will get the right thing. At least whatever we are saying, you should be able to.
Because we can not eating.
But those two, right?
Yeah. And it's a folder.
I'm not so sure. Okay, actually, there are that. So there
Yeah, when you go, can you
Just to show.
just keep everything on that side. All the things that we can keep.
Locker. Okay, the lunch is at the same place as yesterday.
No.
If I mess up something.
We put a password or something just because not every credits may be given, etc. So they want to.
What do translation? The whole sentence, what does it mean? I got you back.
So me, तुझा मैं तेरा. Patisha is like what?
Oh, yeah, this is bag, your bag is here. Below the table.
Okay, let's go.
Lunch, I realized it was
Portion of my day doing this stuff.
okay, great.
Are you from?
I am partially, you can say. I've been here for 7 years. So that's बच्चे अपना स्टार्ट हो रहा है.
हाँ, तो
कॉलर हा तुला होता आता एकच राहील एकदा मध्ये स्टॉप झाला ना तेव्हा मग नाही लागत. हॅलो
What do you want? Fill the bottle. What are you
Right? So batteries are and okay, Shivnesh, sure. So, send it to me. Okay, send it to me. What's up? Indian space mission. In the oh, yes, yes.
But that's just not actual sign.
Oh, well, it's just right. You keep 3.8 meters.
We got half of the
But the rest will be like
We'll do it. Okay, first, you can make it.
It's a possible planet.
It will take 5 minutes. Okay, then you send me email.
मध्ये काही नाहीये
This is your computer.
Marks.
Yes. Yeah. Well, how do you and then I will tell people about this, what you have done, then you can also practice. Just give me 1 second. And he has to start in the
I'm 2 years old.
My videos here. Okay, so sorry, Sudhir Phakatkar, right? So we also have Sudhir Phakatkar here who is attending these sessions. One of the things that he has done is to create a models for the different planets and also our moon to actual size or actual, maintaining the scales. So he also has brought them. So in principle, we can take a look at these things.
Basically, what I have done, I have divided diameters and distances with equal same figure. Means you may say this is million time downscale, 10 lakh, and then you can everyone can create those planets and moons. So with that scale, Earth will come in this size, and from here 3.85 meter away, this will be the moon. So you can explain in detail with proper way to students. This is the Earth, and there is the moon. With this.
But this is exactly good for us to explain.
And you can also tell that from outside the atmosphere, you can see the Earth like this only. And what is the width of atmospheric layer? That is just 0.5 millimeter is the atmosphere only. Okay. And this is the Venus. Okay, this is the Mars. And
so it's all to scale. So now you can see and appreciate that.
This is Mercury. And then another table is there. That table I have prepared.
What material have you used?
This is wood. Wooden.
Wood. How do you get it?
You can polish it and.
Can you place those?
Yeah, that's what I was telling him. Try to place them. If you can place them on a table.
Sir, you stand there, sir. You stand there, sir. I'll show.
The only problem is you cannot place them at the right distances. That is also something he has calculated, and then you can actually show that. Yeah.
Yeah. No, this one is Kshitij.
I wanted that one. I wanted that copy of the thing that you had done the cutting of pages of the two round things. One copy of page, but it's not without cutting.
Shivani got out of he must have called.
Today, can you?
I'm not sure. I'll call her. If something is available in science center,
Okay.
5, yeah. 5 into the center, right? Okay. I think this is 3.85 meters.
Roughly 3.8 meter. Okay, so when you look at the size of the Earth, and this, look at how far it is.
Yeah.
That's why you don't have to do like.
And all planets are not possible.
Very nice, sir.
That's why you can have
So we have to
asteroids.
explain referring some other diameter. Those proportion. Jupiter will be tractor size of tire, or tractor size tire. Saturn is truck size tire. And again, Pluto will be same, almost like moon. But and distances. This is our to moon distance. From this Earth, Sun will be 1.5 kilometer away of this whole size.
So we are keeping the bulb here, but it's actually really far.
And
1.5 kilometers.
1.5 kilometers.
With this scale. Sun.
And yeah, and Pluto will be 58 kilometer away.
Think about how much energy it is actually emitting. It's so hot.
And Pluto is, sir?
58 kilometer away.
From Sun?
From this. In this proportion.
In this proportion.
When to go outside the campus and then
outside
campus. Outside Pune. Yeah, outside Pune. Yeah, outside Pune.
Usually in our science center, I start asking them your address at post some village, then taluka, then district and state and India, then continent, then Earth, and then your time. Then distances are to moon is this much. Then explaining every planet, Mercury, Venus, and other side Mars. Mars is around Mars orbit is different. Mars orbit is different, and because of that different distances, it will be nearer to Earth with this proportion 400 meter to 2.5 kilometer away.
Okay.
So that is why Mars we can see much more brighter and much more bright.
Okay.
And then we can explain all other planets, and then temperature. So which planet will be too hot? Of course, nearer to Sun. Then that temperature will get increased. So this way, and then students start asking many more questions. The impact of planet. That is again another topic. So we explain this.
Sir, can we change the scale into 58 kilometer to out of Pune हो जाएगा अगर इसको कुछ और space दे सकते
तो ये इनके
So you have to reduce, but then these sizes are extremely tiny. So
yeah, थोड़ा सा technical कर सकते हो.
So those are the
This is little bit easy to understand and manageable. We can take in the hand and explain.
Okay, good. So let's start with the next thing. Beautiful to show. I mean, we had all these experiments we had to plot on the A4 sheet, etc. So since he has a live model, we show it. So Kshitish will go next. He'll talk about the future space missions. He is a project engineer here at OAE. Yes.
Hello.
Yes.
Okay. So I'm Kshitish Chaman, working as a project engineer here. I will give you a brief introduction of future missions. This is just like a tip of an iceberg. I'm not giving you like all the missions that are going to happen there. I mean, in this world. So even I don't remember what I have placed in slides. So we'll just go as go ahead. Any of the image that you see in this presentation is not owned by me or IUCAA. These are from space organizations like ISRO, NASA, JAXA, and likewise. So let's start. So okay, so this is how my session will go. Initially, I'll just give you a brief introduction of what India did in 2023. Then I will go towards what are the international efforts for space programs. And then I will come to what are the Indian efforts and contributions that are there in the future. Okay, so in 2023 we had this IUCAA launch, which was the first ever mission to study sun, exactly. And where is the pointer?
Sharing the screen.
Yes. Okay. Okay. So this that you see here is soot payload, which IUCAA specifically worked on. Many of our engineers here have worked on the soot payload on board IUCAA mission, and there are some other payloads. For example, as you see here, I've shown.
So can you spell it? What you just said, the name of it?
Sorry,
payload.
Soot. That's soot. Solar Ultraviolet Imaging Telescope. SUIT. Yeah. So this is a collaboration between IUCAA, ISSC, URSC, PRL, and US. After that, okay. Anyway, we had this ExpoSat launch on 1st Jan, just this year. I didn't even know when this launch exactly happened. After the launch, I got sorry, but
Yes, I just had a question about the types of materials used to make that suit, because children ask material in the topic here, तो उसमें हमने question दिया था कि अगर आप astronaut बनते तो कौन सा material use करोगे to survive in space. तो अभी इसको space में जाने के लिए कौन सा material is the best material that you have, like different types of materials that you use?
okay. So the only thing that I know in all this is the base that you have is of titanium. Okay? Titanium. Okay, that is because the heating effects on the titanium are quite less. That thermal coefficient is very less. Because of that, if something hits up, it gets expanded, right? So that changes geometry of your whole instrument, and so that's the only thing that I know. What other materials that they have used that I'm not.
Because the temperatures varies from minus to.
I mean, it has to bear the harsh temperature variations that happen.
And the solar.
So that is one thing. Plus, there is the detector itself. So it needs to be able to detect ultraviolet radiation. Right? So all these kind of different technologies go in before you can actually create something. So again, we are not fully experts in the detector technology. There are some people at IUCAA who do these kind of things. So they can tell you more.
So, yeah, actually, they have like certain standard of materials in ISRO, which they use for space qualified products. You can't just directly buy from market and use them. Right? So quite a bit of like material science research goes in that. Okay. Yeah. Then we launched X-ray polarimetry satellite in January, but the thing is, this the previous mission was to study sun. This mission was to study extraterrestrial objects. Sorry, not extra. Objects outside our solar system. For example, black hole, neutron star, and you see active galactic nuclei, which there are basically two different payloads on it. which detect X-rays at different wavelengths basically. Then we had Chandrayaan-3 soft landing, and India became the fourth country to do so in 2023. Now, after that, let's come to international future missions. So, the Chandrayaan-3 landed on the south pole of Moon. Yeah. So, why that is important is because we found liquid trace. I mean, sorry, not liquid, but the traces of water. Okay, and we want to explore if we can use that for our future human missions in any way. So this Viper space program has basically a rover that will go there and study those soil samples. Similarly, there is Artemis. So this is like NASA's way of coming back to Moon after 15 years. Okay. So recently they had Artemis 1 mission last year, which was basically to ensure that throughout the journey, astronauts will be safe. Since that was successful, they are pushing on to Artemis 2, in which astronauts, 3 astronauts will be sent to lunar flyby. They won't land on the Moon, and that will be about 10 days. So you will have the lunar flyby for 10 days. Once that is done, and if everything goes well in that mission, and based on the feedback, they will modify things in Artemis 3, which will be actual landing on the Moon for astronauts. And these are 4 astronauts that have been selected for the program. Out of them, 3 will go, and this will be the first lady included in the mission. Then JAXA is Japanese Aerospace Exploration Agency. JAXA is, we went to our own moon. JAXA is trying to go to moon of Mars. Mars has 2 moons. The bigger one is Phobos, and then Deimos is the smaller one. So they have the schedule launched is on 26-27. You see, that's a lander. They are going to land on the moon of Mars. Okay. Yes. Okay, the moon of Mars is not called the moon. I think it should be satellite technically. Yeah, satellite of what?
Yes,
Mars.
satellite of Mars.
Yes. Okay. One more thing I want to emphasize on, since I can't cover lots of information here, I'm putting the source links on each and every slide, where you can go and find out interesting videos that they have made or some article information that they have published on it. Okay. Next, NASA has Europa Clipper mission. So Europa is one of the giant moons of giant satellites of Jupiter, and its structure is like you have icy shell, and underneath that you have water bodies. So to study, and since there is like quite a bit of chemistry and water available in abundant form, they want to learn. We as a human want to learn if there is any life existing there, and if any life does exist in that place, then it will mean that life is not that rare as we thought of, and there might be multiple places inside our galaxy as well as outside where extraterrestrial life is there. So this mission is not a lander. This is orbiter, and it is going to study the icy surface as well as the inner water components, whatever they are available. I don't know how that is exactly working. but they are also planning to search for landing sites in that region. So if some good landing sites are observed, then they will also propose for a lander on that satellite. Yes. Then next is Hira mission. That's ESA's mission. Yes, that's ESA's mission to basically, sorry?
ESA stands for? ESA.
European Space Agency. Yes. So, I think few years ago, I don't remember the exact year. Anyway, ESA had launched a DART space satellite, and it's not satellite. It's what do we call it? Space probe, space mission. Yeah, a DART space mission, which they intentionally slammed on one of the asteroids, so that's to see if it can really change the trajectory and to study the aftermath.
The moon of an asteroid.
Sorry?
They targeted a moon of an asteroid. Yeah, asteroids also.
Yes. Yeah, sorry. Yes. And now to study the aftermath of that, they have this Hira mission, which will be two satellites revolving around that same moon of asteroid. Yes. And yeah,
That was really a great mission.
yes. So to study the aftermath of it.
Then what happened?
I can actually show you a video. You can continue. I will find out the video. It's beautiful.
Okay. Okay. So let's come to Indian missions. So we have the first manned mission, which will be of completely Indian origin. And that's called Gaganyaan. We have certain set of what we can say. We have not finalized the astronauts, I guess, but these are people that have been trained in Russia for the whole mission, and about 3 astronauts will be sent to space, and that will be for 3 days, and that will be about 400 kilometers above the surface of the Earth. That's right now, as I said, this is in testing phase. As you see, I've just shown a picture of a parachute deployment test. So it's still in testing phase. We don't want to risk anyone's life, and they have made some robot which will also go on board that mission, Gaganyaan mission. This is not a scientific mission. This is just a demonstration mission. Then what do we have? We have INSAT 3DS. So this is a meteorological satellite just to study study the Earth itself, study land, oceans, and accordingly do weather forecasts.
Is it launching today?
Yes. Yes. I guess so. Yes, exactly. I don't remember if this was the one. Okay. That's the one. This is launching today at 5:30 p.m.
So it will be live for us.
Through speed, so if they are still running, then yeah.
Can you see, sir?
Yeah, I'm checking.
I got it.
Okay. Then there is the collaboration between NASA and ISRO, which has NASA, ISRO, SAR.
Yes, sir.
So that's synthetic aperture radar. Okay, that's basically going to study Earth itself. We want to study deforestation where we have a wet land, dry land, and what are the different changes that you see in glaciers, in icy bodies, and likewise, if there was some report by NASA which said that New York is sinking and rising for certain kilometers. Sorry?
Climate change.
Yes. So that all we want to observe that, and this will be the most expensive satellite, Earth imaging satellite mission in the
Sir,
world.
can you repeat SAR full form again?
What did I say? Synthetic aperture radar.
Aperture?
Radar. So NASA is going to give one of the radar, and India is building one of the radar. Both will be working at different frequencies, and will observe at two frequencies simultaneously for the same ground will be observed at two different frequencies simultaneously. And basically the whole thing is getting come together in ISRO, your SC. Okay, and these are few of the more Indian missions that will be more ahead in the future. That's not very far, that's near such steps. I've placed this separately, that's because I couldn't find official resources for these exact missions, but there have been different different news about these missions. So we have Shukrayan 1, Mars Orbiter 2, Chandrayaan 4, and Astrosat 2. This Chandrayaan 4 is similar thing of Chandrayaan 3, but it is a collaboration with JAXA, Japanese Space Agency. So that Japan is going to provide launcher and the rover, and India is going to provide the lander. So you see, we have different collaborations that are going on with different countries. Astronauts are getting trained in Russia. We have NASA ISRO's synthetic aperture radar with NASA, and we have Japanese agencies as well that are collaborating with us for this Chandrayaan 4 mission. So yeah, the future is bright. Thank you very much for your attention.
So I have this movie that was made by the DART spacecraft, which actually crashed.
So one thing I want to mention that I haven't shown many ground-based observatories here. We have 30-meter telescope coming up. We have SK observatory coming up. We have LIGO India observatory coming up. So those I haven't placed in here just because of shorter time.
But they are major missions.
Yeah, but they are very major missions. Similarly, there are missions by SpaceX, which are basically space tourism missions. You must have heard of Starship. So it will be the biggest spaceship. Oh, we have a video.
No, you continue. I'm trying to find the right position.
So we have space mission that will just basically orbit around the Earth and return space tourists back to Earth, and it will carry about 100 travelers.
How is that? When will it start?
It's still in testing phase. I think in 2023 they did first test, so it will be quite in future until all the certifications. So that's why I'm saying that this is just tip of an iceberg. There are many.
Okay, so you see this. So this one is the bigger asteroid. Okay, and around this bigger asteroid, this one continues to go around the ground. And what they did is they slammed the spacecraft onto this smaller asteroid. Okay, so you are seeing the spacecraft approach that smaller asteroid. These are real images taken by that spacecraft. You see that they have to make small adjustment here and there such that it actually hits. Okay. And at certain point of time, it will get closer and closer and closer and closer. And then basically it just crashed. So after that, the camera basically just died.
There wasn't any other camera to check.
No, so the Italians had launched another mission which was following it so that it could see what exactly has happened. There were other observatories in the world which also observed this thing. So this is still an artist impression of what would happen. So as soon as it after it hits, the orbit of this object changes. Okay, so here it loses some energy because it hit it head on. So after that, the orbit becomes it shrinks.
Lose energy? How? It should gain.
No, so it depends upon how you hit it, right? So if there is a car here and another car here, they both crash, then this thing will lose energy, right? If it would have hit it from the back, then it would have gained some. And so now here you can see. So this is a picture taken by a telescope as to what happens after that. So so this thing, you can see that it actually left out some debris. What you're seeing here are both the things. Okay, it's the bigger asteroid and the smaller asteroid. From ground, it is very hard to resolve, and that's why you only see one thing moving, and then some dirt coming out because of it. What this does is, so you keep on observing now, like how the orbit of this smaller moon has changed, and that did change by like 30 minutes or so. Okay. So in order to do that observations, of course, many of these telescopes were doing things. So yeah, let's forget about that for the moment. Okay. And then you can ask, okay, why was this important? So imagine there's a lot of debris around the Earth. That debris keeps on hitting us, and once in a while there are big objects which come and hit the Earth. So if you notice something big like this coming towards us, then what do you do? And so this redirection technique is one of the things that can be used. So you try to put an impact such that some portion of the velocity reduces. Then what will happen is, by the time it comes, the Earth would have moved away. Okay? So these kind of techniques are used in order or are being tested. It's called planetary defense.
So is it happening?
No, it's not, right? So, but you do see falling like these meteors, right? And these meteors are just debris which is falling down, but they are tiny. So if you, yes, it's called shooting stars, although they are not stars, right? So if they are really big, then in fact they can create problems like this. Okay? So if you know the lunar lake in Maharashtra, that is caused by a big impact many years ago, of course. Just recently, maybe 10 years ago or so, there was an event which happened in Russia, and it was not that big, but it still caused like all the windows in a certain region to get shattered. So this kind of thing is real, the danger. And that's the reason why we are trying to.
So basically, that mission to move the moon of asteroid away from them.
This was just as an exercise for us. That was not going to come and hit us. It's an exercise to show that this will work. In future, if it happens, something like that. There are many observatories which try to map out these near-Earth objects, which are objects which may at some point of the time come, like they intersect the Earth's orbit. And because they intersect, there is a possibility that they may hit. And so we keep on mapping out these objects, what are their orbits.
So you just said about the space debris. Yeah. And they show some pictures wherein so many satellites are there.
Yeah, there is a lot of clutter, but it does not mean that it's like the dirt in our house, right? Because there is a lot of free space in between. So the probability that you will hit is quite small. The problem is, even though the probability is small, if something hits, then it is very dangerous, because these things are flying even faster than a bullet. At those speeds, when they have to orbit, they have to travel really fast.
So they are not under control of anyone, right?
No, it's just under the control of the Earth, right? Gravity.
So that is how they just keep moving.
They just keep on orbiting.
So newly launched satellites are also in a great danger because of this.
No, so great danger isn't, there is a probability, and then we are trying to map out each of these small things. So
their movement, speed, everything.
Exactly. So there is a catalog of these objects that people will keep. Okay, so next, we will go through
Yes.
seasons.
Sir,
Yeah.
why it is so difficult to get these non-functioning debris down or destroy or something? What?
See, you have to get its speed to go down, right? Somehow, because just like we got that asteroid speed or the moon of that asteroid to become smaller, only then it can fall down. If there is nothing changing that speed, then it will just continuously move. So people think about techniques in order to get their speeds to be reduced, like different kinds of magnetic material which can slow things down and then get it to plunge to the earth, or get it enough down that the atmospheric friction will just burn it up. So there are things to deal with space debris, but again, I'm not at all.
Sir, what exactly are space debris? I mean, what all things are there as debris?
So there's a lot of junk around from man-made things. So there are satellites where some of these parts get loose and then they fly out. Sometimes astronauts are working and if some tools flies away, it just flies away, right? I mean, flying away means even if it has a little small different velocity or a slightly different distance, its period changes. And so it starts to drift away from you. And then it is very difficult to catch. Because then again, you have to move, then what if you... So it is complicated because of this.
Sir, I would like to add one point here.
Yeah.
Based on the space junk, I had organized a competition, research paper competition for students. And the team of the students, they come up with the topic, like in our city, Nasik, we have a municipal corporation waste management.
Yes, yes.
So there it is called Ghantagadi, which goes area to area to collect the waste.
Yes.
So they created a beautiful model of satellite and they named it as Space Ghantagadi.
Okay.
And that will catch all that useless,
Yes.
chunk of the whatever satellites and all that which are orbiting without fuel also, and that will absorb, eat it, and then after some period it will come down again. It will be collapsed in the ocean.
Yeah.
And they were interviewed by the former scientists of ISRO.
Yeah.
So that was the big.
Of course. The only challenges there that are there is that the amount of space that you have to cover. So imagine you have a sphere, right? And that sphere is of radius r, where r is 6,400 kilometers plus some distance, right? Above the earth that you have to go, right? Now you do pi r square, which is, or 4 pi r square, which is the surface of the sphere. Now your Ghantagadi has some size. So now you can ask, in order to reach each and every portion of the space, how much time it will take, right? Even if it spends some amount of time, then how much time it will take. So these are the kind of calculations that people who actually try to do this in practice have to do. And then the other problem is that, okay, if you get a bullet, then what do you do about it? How do you slow it down, right? So there are many such issues that people are trying to solve in order to make sure that this kind of a thing can be done. Okay. So next we'll go to seasons. Asmita Reddy, she is a postdoctoral scholar at Yoga Center for Science Education. So she will tell us about seasons. In fact, now we will try to do a flipped classroom kind of an activity where you will do things, okay, together.
The helper, sir.
Oh, sorry.
No, I do it. But it's so tight. Wait, cut it. Okay.
That's it.
Need to
Oh,
connect
yes.
this.
Send you the link.
Yes.
No. Did I send you the link? So I have sent a link to you on WhatsApp. If you click on the link, then you can go to some form.
Yeah. Yes, it's a pre-test. It's a quick test that you'll have to give. I'll tell you the reason.
It will take time to read this, right?
Yes, I hope we are done. Hi. Good afternoon, everyone. Everyone is there? Yes. Okay, so shall we start?
Should we read this part?
What about this?
Yeah, give me a minute and then you can read and go to sleep. That's So, good afternoon, everyone. You're almost nearing the end of the workshop, and I've been watching you for last 2 days. So since that first minute, you have been really very enthusiastic, and everyone was so participating that when we design our talks, we are a little worried of, I mean, you're teachers, so I don't have to give this briefing, that how will it go and how much time we expect and all, how much participatory it could be. But in last few days, we saw that we learned about astronomy, different concepts in astronomy that we have experienced. And we have been looking at how we can first understand it ourselves and then to teach students. So for that, we were also in the process understanding ways of taking it to the students, where students can fall short of understanding, where there could be misconceptions. Sometimes we witnessed our own misconceptions. There was a lot of learning, even for me for that matter. There were so many things I didn't know. So it's always a process. Even 10 years later, perhaps, we will have some things more to learn. But there is also another aspect to it as to how to learn or how do students of different age groups learn, and there are some intricacies of the subject itself and how we can deliver it to students. So as you are reading here, the approach that like I'll be talking about today is interdisciplinary approach. It came out quite nicely in most of the discussions we had or the comments you gave from your own experiences, that astronomy is not a subject of science alone. It certainly is taught, most of the part is taught in geography because it forms the foundation of most interesting and perhaps even the burning question of today's time. If you open any newslet and put climate change as a topic, there'll be like within a half hour, there's at least one news related to it across like the globe. So it's like coming to our doorsteps. And this and many other things related to geography, the topics that we checked in these last few days and will be looking now, forms the very foundation of delving into these advanced topics. Okay. So, but while understanding this topic, it's not enough to know science alone or geography alone. We see that there's so much of maths in it. There's so much of visualization, geometry in it. Then for visualization, you might be using it already. Some properties can be used, which will better help better students better understand the topic, and then logically come to the things that we want to convey than just getting into rote learning. So one of the teaching approach, which has been extensively talked about, it's nothing new, is interdisciplinary teaching method. In this, we'll be talking about how a subject will be seeing it, taking a case of seasons, which is the topic that was given, as how a topic of like season, which is inherently quite interdisciplinary in nature, can be taught rightfully or in a better way in the classroom, where teachers from different subjects can collaborate and work. Now we have all been collaborating for last few days. I checked the list. Some of you are from science background, some of you are from maths background, and some of you are from geography background also. Chemistry background also.
Biology also.
Biology, yes. So we have more, and it all connects, you'll see. So, but before we start, I wanted you to take a pre-test. And this pre-test is nothing. This is a study that we are carrying out to understand what are how many of you first know about interdisciplinary teaching methods, what your understanding of it is, and if you have used it in the classroom, and what are the challenges. This is part of a study that we are carrying out. I'll talk about it later in the talk. And so if you can scan the QR code, most of you have already done.
I have sent the link anyway.
Okay. So you can go through it. There's a consent form at the beginning, which just tells you that we are taking the names and some demographic details of yours, but we will not be using or revealing the personal information anywhere. A lot of the analysis is done in a generalized way with the names anonymized, and wherever we present it in presentations or publications, name are not revealed, but the generalized findings from the studies are being presented. So it will greatly help our studies. And if you have any questions, you can ask me.
You're having trouble opening this.
No charging in my phone. So it's
Oh,
everything
phone.
has to be on paper copy.
Paper copies, yes. Anyone else getting a paper copy?
Do you need a paper copy?
Yes, I want.
You scan it?
I sent on WhatsApp. I sent a link on WhatsApp. It is there people. The question.
Grades, how to fill up grades, back हो रहा है. नहीं, एक ही था.
अभी एक
one
ही
class. Only one.
One
highest class.
Yeah, so that.
Don't do that.
नहीं, the link will change.
Link won't change.
But the data will.
might create some. Give an average number like preschooler, 7th year, high school ho to 9th ka lo. Then we know that you teach 9th. Well, you don't have to collaborate at this stage. Huh? It's later. You should.
How many sections are there? How many sections are there? What a question is? No, we are there on section 2 starting. Okay. Hmm.
One section I missed completely. Can I go again?
Suggest to
Section 2 and
submit this and resend. But I think whether to overwrite or submit this so that.
I submitted and then just I wanted to check because I got it ended early, so I wanted to see what happened. And one section.
It only voted section. Section.
I don't know. I got directly submit thing. I got submit option. So I did it.
Nothing else. It was made compulsory. So that's why it just went in.
And section 3 I can't see anything. Only section 2 I see.
You are learning editing of this one.
Huh?
You are learning editing of this one. Then it is.
Only section 2 I can see.
That's okay.
No, I did.
After submission, it bounced back.
This is why you got this. Not possible to copy, unfortunately.
It bounces back and again it is very difficult to submit.
And this thing like this.
Oh, is this the proper way to send it?
I don't know.
Okay.
Overwriting and all. Why do people should be good?
But also to track you properly.
They will be able to see me.
Okay. Sounds good. Sounds good.
Then it's still.
See, again I got what I'm supposed to do. Click submit to finish, even just after pressing. Then I go to the next section. And get this. So back.
Section 1. To next.
And see. I think directly.
Is there anyone who could submit it?
I could submit directly without 2 and 3. I don't know. I am directly getting.
So there is some problem with the form, I think. Okay, I will try to fix it in between. You can continue, maybe. I will try to fix the form. Just give me a information.
I'll go through the questions back.
Sorry about that.
That's not structure
Does not show section 2.
Have you even selected the consent?
Yes.
I
consent.
I
The
consent.
second section is not mentioned. Actually.
Okay, the last question that I have written is, that answer is no. Is it because of that?
I think that's right. Yeah. So if
Because I have
you don't consent, then of course.
No. I have given a consent. But this section was last question.
Maybe that might be the reason. See, if you
Right.
then that's it. Oh, then it's fine. That's the reason why it is. Then it's okay. Yeah. Okay. Of course. If you are not right, then you should not. Okay. That's
I'm thinking how this is fine.
Who was this? That's right. Okay. Okay. If some of you have not tried out interdisciplinary sections teaching, then of course you should write no, and then the survey will finish earlier.
Oh, right. You don't want to write.
How many are finished already? Submitted? Many of you.
Actually, we have submitted, it shows that view scores. And we clicked on that and we can able to see the second section, which is not filled.
The same thing. We have not tried interdisciplinary.
Second
Must be that.
So that's why everything is done.
It must be that.
It's like you filled second section.
First
at the
section.
End of first section, and at the end of first section, is it or? At the end of first section, if you say that you have not tried interdisciplinary teaching, then you wouldn't go to third, second, you will directly go to submit.
Which is okay. I mean,
That's
fine.
numbering I was
We
also-
want exactly what you have done. If you have not done, not a problem.
Now I get it. All the questions are about that.
How much time you need now? Is there anyone still trying to finish the form?
Yes, ma'am.
I tell you, is that whole thing, you also type it. I don't have answer. Last question. I was not able to.
Last question of second section.
We were not able to because it was
Okay. Leave it.
and once it is clicked, it is not getting okay. We can't choose another option.
So we are just given it.
The 24th question, right?
Yes, the last one.
Okay.
There were 6 options.
Yeah.
Few of few answers are like jumbling up. So I gave any answer.
But this is also part of learning for us. Like maybe we need to design some things a little
I
bit
mean,
better.
somewhere it is not fitting grammatically, and somewhere I'm not able to get the right answer.
So you can ask like, you could have asked me.
Yeah, but give this feedback because it will be useful then to like rephrase something.
So, shall we go ahead?
Yes, ma'am.
Try to be quick because we already are short on time.
We'll finish later. Break time.
Actually, that's a pre-test, so I'll appreciate if it's in the beginning. But you're done, right?
Yeah, but some of the questions get confused.
Okay, fine. We'll take it in the intermediate part, but try to finish it in the break time. So yeah, in this workshop we have been learning about
Just a little bit of.
Not that this one.
Can you speak?
Hi. So
Not coming.
So not coming, ma'am. It's the same.
No, it's not.
Let me see.
So this noise tells you it's on. Yeah. So, yeah, we have been having this workshop on astronomy. And in school, astronomy is being introduced in subjects like science and geography. These are typically the topics covered in astronomy textbooks across subjects, I would say. Mostly dealing with positional astronomy. Some of it we discussed yesterday. And then we have space and astrophysics, which includes space science, evolution of stars. And as I said, they are covered in, major of it is covered in geography, early age. So positional astronomy related things are covered in 5th, 6th, 7th standards classrooms. And depending on which board you are teaching, it varies a bit. And if you take Maharashtra State Board, how many of you are teaching in Maharashtra State Board? There are a few. And how many of you are teaching in CBSE board? Okay. And then there's
Tamil Nadu State Board.
Tamil Nadu State Board. And there are ICSE and what all the other ones? Others? Okay. So yeah, depending on boards, it varies. Sometimes there are some additional books that schools follow, private, so things vary. But broadly, these are the topics covered at school level. And we discussed most of it in last 2 days. So we had workshops and we had activities, interactive problem solving sessions also, where we saw it was not just giving problems and doing some mathematics, but seeing how these things could be visualized and logically coming to the conclusions. Then we saw demonstrations both where we used external aids as well as where we ourselves were properties and we were moving around to see how these planetary motions occur. And did you have a better experience with that? I mean, which form did you like in this case? And because I remember in the first discussion, one of you said, perhaps someone from here, that visualization is a task. When it comes to astronomy, it's not a subject that you can just always visualize with the day-to-day things. It needs a little higher level of visualizations, and there it becomes a task. So did these activities help you in coming up with some better ideas?
Definitely. Yes.
So if I give you a challenge that I give you a new topic, will you be able to come up with activities? Up until now, it was like the activities were pre-planned, right? And you were participating in it, so you were very much part of it. The task for this session, the other thing we learned was how astronomers work, which Professor Zuru More told us. They break the problem into small parts. They address one bit at a time and then try to understand the whole. So we also learned techniques eventually. We were learning. We were learning astronomy as well as techniques to address these things. So, so what is the motivation to have astronomy in curriculum? Are we there to just, is the purpose just to deliver content? कि भाई phases of moon आ गया, या I know tides का concept, eclipse now I know. Is it only that or is it beyond? What are we preparing the students for? So the idea of astronomy, introducing astronomy, is at school level. Certainly the level of astronomy they learn is really basic. But what we want to inculcate in them, in the students, is for them to understand the nature of science and the process of scientific inquiry. A lot of the times, so yesterday we talked about textbook analysis, but the same goes for classroom analysis also, that how a topic could be delivered in the classroom. So most of the times, like see, in last 2 days, the first 2 talks we had, or even the morning talks, the first things we did were we noted down our observations, right? As in, when we talked of tides, everyone started talking about tides. But it might not always happen for a child that they would know that new phenomenon to the details that we already know. So certainly, any curriculum, any classroom starts with some information, building the background for that content. But then, often, the work that we have been doing showed us that there's always a jump to give reasons. ये हो रहा है, ये क्यों हो रहा है? You agree with this? Some nodding. Yes. So this is the lacuna that we are trying to fill, because in the process, we miss this part. So can we help them observe things? First is recall from what is already been observed. Then make them go and do some observations. And then it could be direct observations or analogies, because what happens inside the star, what happens inside the stars, we cannot go and see. But can we build some analogies in that case, some models in that case? And then making students think. It takes a while to make students think as to what could be the reason based on what they have already learned. And then come to the reason, delivering the reasons. As I said, the analysis show that depending on boards also it varies, but most of the time, with the constraint of timing, with the constraint of knowing that their age groups, often things are, or maybe some other constraints, I don't know, but often things get jumped up, and in the process, the real conceptual understanding is blank. So, so coming to one approach in teaching that I'll be talking about is like one thing you saw when we talked about tides. Well, someone talked about blood pressure, someone talked about fishery, and then it also went to economics. It also included maths. So, in fact, every topic in real life is interdisciplinary, multidisciplinary. But is the school curriculum interdisciplinary in nature?
Yes.
Yes?
Now it is.
Now it is
happening.
happening. Okay, so that's good. I would like to read your responses in that case. Say, how are you trying to implement it? And is it smooth or is it challenging?
Challenging.
What are the challenges you're facing?
Time.
Availability of the teachers at the same time becomes very difficult.
But this thing is being incentivized by the schools, or you do it on your own, at your own space?
Sometimes by the school, sometimes by us. Partially.
Yes, huh? Principal wants you to do that way? Because I had met a principal who said that it's coming from top on them. So,
Ma'am, in our school, we have an initiative that students of class 9, they have to do an internship. And in that internship, they can select the topic or the place of their own choice. Even school also provides it some few companies and all, they go during summers, 10 days they attend that particular company. Then they have to make a presentation, and all subject teachers we sit together and we just assess on the basis of that. So it is interdisciplinary.
in a way, it's interdisciplinary. The reflection part of it is interdisciplinary.
As well as CBSE has a mandatory art integration project.
Art integration project as compulsory.
That is also
Arts and compulsory.
It is not only art integration.
Subject integration. All subjects.
Lesson plan, it is interdisciplinary. We have to. So my Hindi teacher is when teaching about Chand, Tare and all. And letting my EVS teacher to be there together, and they're planning their lessons.
So many a times Einstein and Shakespeare. They both come in the class.
Together, yes.
And what's the conversation? I'm interested to know. So,
Story with maths concept.
that's amazing. So I guess we have rightly designed our this workshop where you are going to be here playing this interdisciplinary role, and we will watch you, we will learn from you, and we will together see what things are missing and what more could be done. Yeah. So certainly, like, it depends on which school you are coming. Trends are changing now. The compartmentalized traditional discipline-based approach of teaching is slowly, the walls are breaking, and the schools, as you said, are making space for interdisciplinary teaching. Up until now, subjects were in their own silos: maths, geography, arts, computation, and science did not communicate with each other. But while I mean, I would correct this. I'm really happy to correct it that interdisciplinary approach is now being visible in the curriculum. So, shall we go ahead? We'll take a case of seasons, a topic which overlaps with most of these subjects, and we will see how we can know about small intricacies of what season is and what are the different phenomena that we see under season, why they happen, the way they happen. So, are you there in the game? Yes. Okay. So then we are little bit of moving around. You'll have to reshuffle yourself, break the comfort zones and meet new people in the space. Perhaps you might be talking to each other during tea time. And now let's work together. So, to begin with, how is the weather today? AC room में बैठ के बाहर के weather का नहीं बता सकते. I remember there was a time when I was sitting in an AC office. Institutions usually are like that. And then I told a friend of mine, गर्मी मुंबई में तो बिल्कुल गर्मी नहीं है. She was impressed. It was May. And after that weekend, it happened that I had to go for shopping. And that day I realized that what the temperature was. Because other times, like during the peak hours, I used to be inside the institutional building. So yeah, but weather is something we talk about. आज मतलब आते आते ही एंट्री मारते ही आज थोड़ा गर्म है या फैन चालू कर दो है ना. So this conversation is our daily conversation. Why? So weather report, we news channel के पीछे अभी I don't know how many of us look at those typical weather forecast, but weather is a daily change in the season around us. It could be change in various parameters like temperature, humidity, and other things. Like there could be precipitation or no. And these daily changes we term as weather. But if I have to make a plan, the vacation May, where do I want to go in May for May vacation? Which place will you choose for May? Huh? Hill station. Or somewhere north of India than south of India. Kerala you will keep for, or Tamil Nadu you will keep for winters. Okay. So this is what an annual variation of temperature we can say. The main parameter that's changing is temperature. That we see seasons. And then again an anecdote. I came with a huge bag because I was going to stay for a few days, and I carried my woolens across with me, thinking Pune jana hai. So this time of the year it will be cold. But I was betrayed by Pune. It wasn't cold enough. So these consistent patterns that we expect, knowing the geography, are sometimes changing. So this pattern change over a long time is called climate. You all agree with me? Yes. So before weather has local fluctuations in it, the local regional fluctuations in it. Climate is a long-term thing. It's a burning problem, but it's not the topic of our conversation now. But to understand both of these, we first have to understand why this first parameter, the temperature variations, come about. And so we'll discuss what is season. So maybe now it can start coming from you. What are seasons? Everyone agrees it's 4? 3 for us. I wrote 4.
Because I wanted to show this fancy picture that I have. But do we see this? So what is it that we see?
Winter, summer, monsoon.
Winter, summer, and there's a monsoon.
Advancing and retreating.
Huh?
Advancing and retreating.
Monsoon is retreating, you get some precipitation.
It's missing.
Monsoon is missing.
Ah, yeah. That's good. This is from different latitudes. So. और क्या देखते हैं मतलब? Tell me about seasons. What comes to your mind when you talk about seasons?
Atmospheric condition.
Atmospheric condition. Or
Longer duration.
Either
huh?
Season.
Longer duration of season.
Changes in the landscape.
Should I write it
Day
down?
and night timing, sunset,
first of all temperature change, then the precipitation.
Wait. Someone said longer duration of
day and night changes.
Changes in the landscape.
longer duration of
Days.
Seasons only, like 4 months, and day and night also.
and
Landscape.
landscape.
Changes in the
Change the nature around us.
Landscape.
The nature around us.
Nature around, right? Yes.
So landscape I thought of.
Yes,
change in landscape. Change in nature.
Changing greenery region.
Yeah. Anything?
Temperature
Change in
temperature varies.
so change is sort of common.
Change in temperature that leads to the evaporation.
Leads to evaporation. और क्या?
Amount of sun rays that you see
That is there na day and night.
Longer duration of day.
Or night.
Photo period. Photo period, duration of sunlight.
It's the same thing na day and night.
Duration of day. I meant change in
Inclination
this
of the
vector.
earth. Inclination of the earth and revolution of the earth.
That will be
Good. I was going to ask. There's this thing common. So why is this change happening?
Coming under that.
So it is because of
Revolution around the tilt of the earth.
revolution around the
revolution
Of the earth around the sun.
of Earth. Okay. Yeah, because there were
One more.
other
Uneven surface of the earth.
also we were talking about.
Uneven surface of the earth.
Uneven surface of
That's for other climate. Shape of the earth.
uneven.
Yes, ma'am.
और क्या?
Shape of the earth.
Shape of Earth. Someone said. Shape and tilt of Earth. And club these together. And
effect of sun rays.
Huh?
It is the effect of sun rays falling on the earth.
yes. So the change in temperature is consequences of
Vertical and slanting.
sun rays. Someone said slanting. You said it?
Vertical rays and slanting rays.
Vertical rays is slanting.
throughout the day.
Ocean water also affects the climate.
The challenges related to seasons.
Some floods and droughts.
And right disaster.
Disaster.
Seasonal disaster.
Floods and
El Nino effect.
और क्या है? So
Ocean water, El Nino effect.
ocean.
Seasons are getting shifted now because of climate change.
Shift in season. Season. Climate change.
It is the effect
And
of
global
and global warming.
The migration of animals and birds.
Animal behavior.
Migration of animals and birds.
Animal behavior, we can say. Animal behavior.
Change in animal behavior.
Biology.
Yeah, that's what I want. Change in animal behavior.
Animal births also now.
Okay.
Yes. Correct.
So that seasons also determine.
See, human behavior also changes.
Yes,
I will also.
I will not go outside in summer. I don't want to go outside in summer.
Festivals.
Economical growth based on seasonal festivals.
It is keeping us together also as per the season.
What is
Season is binding us also
interdisciplinary?
together. Season is actually binding us also together.
कौन से सीजन की बात कर रहे हो? सेल्स के सीजन की?
Rainy season when it happens, we receive rainfall. Rivers are coming from your catchment area, so they are bringing rainfall. First of all, civilization happens, then agriculture also they plan it accordingly. Then our festivals also, clothing also, food also. So somewhere it is keeping us together also.
Yeah. So when I was reading about it, it also and interdisciplinarity, it also took into account the colloquial use of season. कि अभी इसका season चल रहा है, तो sales का season चल रहा है. Was one of the events. So yeah, you're very right. She's gone really back in time, saying that how this thing has also helped in timekeeping. You agree? Timekeeping, predictions of some of these, or planning, predictions and plannings, we can say. I think this is good. Okay. I'll take 7 minutes.
Now what is there?
Huh?
What is there?
पूरा 1.5 घंटा और बोल रहा है. We'll be taking a break now. Is it okay?
Will do.
I think it's that tea break.
Yeah. तो ठीक है. I was expecting teachers है, तो first thing that will flash before your eyes, seasons बोले तो ये आया, right? How many of you have taught seasons topic in classroom? Because it is covered in geography. Science में भी है.
Geography.
Okay. So before we disperse, let us do one thing that will help you also engage during this tea time in a very efficient way, effective way for our workshop. So before we'll come back to this and we'll discuss. ये image देख के क्या सोचते हो? We'll go back to the basic first. There are other aspects connected to season, but what causes season? Some of it we have already discussed, but we will try to understand it a little deeper as to do we understand how those two things, parameters connect. First would be we understand it ourselves, and then we have to design a lesson plan for students together, where we will try at the end of 1.5 hours, they should understand what season is and every small, as much as possible, small nitty-gritties of it. But before we go for break,
I would like to share with you the activity that we plan to do. So we will form 7 groups. Do any of you have preferences of arts and computers? इसका drawing अच्छा है, activity करना है. Okay. और कोई है? Arts. Okay. Because that's not something that's easy, so I'm asking for arts. But otherwise, I'm going to randomly distribute people in 7 groups. So other than you two, we'll keep art as.
They will be needed by all groups.
Yeah, you can. How many people are there right now? 40, 50.
No, less than. Little bit less, but you continue. I will count.
So we will start calling out a number 1 to 7. Next one has to call out. Start from 1. 2.
3, 4, 5,
6. Okay. 6. 7.
40.
2. 2.
3, 4, 5, 1. Remember your numbers.
5, 6, 7, 1, 3.
कोई भी बोलो चलेगा. Just make sure you call out a number. 5, 6, 7, 1, 2, 3, 4, 5, 7, 5. Someone said 6, no? Last one was 6. Okay, so how many of you have called out 1?
Remember your numbers. That's it.
1.
How many of you have called out 1? Number 1.
So 1 will be group 1. Those who called out 2 will be group 2. How many have called out 1? 1, 2, 3, 4, 5.
3 इधर होगा ना.
इसमें हाँ. You should remember your number, not others. So 7 तो होने चाहिए. 40. हाँ. So do I have 1? Raise your hand. 1, 2, 3, 4, 5, and 6. 6. 6.
7.
40.
One number will be in 7 times.
Okay. And then 2. 1, 2, 3, 4, 5, 6, 7. 3.
1 वाला कौन है?
कुछ तो कम ज्यादा हो रहा है. Around 5.
नहीं, people are not admitting. Definitely.
I forgot the number.
7
That's why I said remember.
I understand. I get you right. But the quickest is to cooperate at this point because I'm not going to read you before that. So now 2 minutes, everyone attentive.
Again.
Who call? Yeah. Raise your hands if you said 1 in last 10 minutes. I hope you didn't call out for anyone else. 1. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay.
7
6.
2.
6.
40. 40.
No, number 2.
6. I.
6.
3. 4. 5.
ब्रेक नहीं बोला तो सबको याद आ गया.
6.
सबको याद आ गया.
6 will be less, but we will help you.
7 will be less.
7 में क्यों?
7. हाँ. अभी अपना ग्रुप याद रखो. 1 and 2 is for science. 3 and 4 is for maths. 5 is for geography. And 6 is for arts. and 7 will be computers. So the idea is these are your subject domains. बाकी तुम्हें पता है,
And we need to integrate.
So now you have to think in your groups as to what aspect of seasons can be better covered by our
domain. Okay, our
okay,
main domain.
our discipline.
Okay.
Okay. Which concept of a subject domain, which other concepts of a subject domain are needed to explain this topic? You can use mind map technique. Are you aware of it?
Yes, ma'am.
Yes. Discuss in your group to see if you, as an, you understand the topic well. Now we have to reason it. As to यहाँ पे बस revolution बोल दिया, पर वो कैसे, how is it playing a role? This is what we have to.
Sir, 1 and 2 science, 3 and 4 science.
3 and 4 is for maths. 5th is geography.
3 and 4 maths.
6th is arts.
Arey sir, make him.
Let him write. Incorrect at the end. Okay.
Geography.
सबको भी चाय चाहिए.
सबका नाम है. So discuss in your group to see you understand it first, and then we will also be part of the groups, and then we will explain these things to teachers, students first.
You also need
Obsessed with teachers workshop. So there are some conditions of the game. Each group should know what other subject group is doing. जाके बैठना नहीं है. You have to focus on your group things, but you should be aware क्या चल रहा है. And each interact with each other and collaborate when necessary. By this I mean, if there's something that I want to teach in physics which needs understanding of shape, can I request the arts teacher to help in this so that they can cover it in their classrooms. So we are breaking for tea now. 41. So we have 20 minutes of tea break. You can take 5 minutes more.
So do we have to
over
mingle again?
So now you have to be in your groups for next 15 minutes. ये छोड़ के चाय का time also you can utilize. You can come sit in the groups. There are some other properties also that we have brought which arts people can use to demonstrate the ideas. And then at the end of 15 minutes, each group will decide a representative of your group. तुम नीचे से मदद कर सकते हो, पर stage पे एक जन आएगा. And that together we will build a lesson plan where we have to fill a schedule. Say if we want to teach if we have half an hour for lectures, classrooms for each subject, how will we fill this timetable so that the topic of season is understood by students at the end of that 4 days or week? So, does this sound interesting?
Yes.
So we try it and we'll start working. You can first get introduced to yourself within your groups and start working.
मैं तो वापस करा कि
You understand? Mostly it was like pleasure to catch up with
all the supplies is here.
Let's start with the system. System where you have what is the source of temperature? I should do this.
I would.
So whatever part they will. So they see they also have to students will understand better. But how it is to demonstrate it to the students. So some distance the physics value, the temperature, exposure to increase the temperature, how to demonstrate. So this they cannot demonstrate.
And then, so 20 minutes, say, discussion, then 20 minutes, no,
So when they
time.
activities will be
No, like
but
what?
now they're thinking about it. So even if they so it will be elaborate discussions that what are the things we missed, what are the
So let's say last 1 hour kind of discussion.
Yeah.
What they came up with and then what they meant.
Like last 10 minutes, we want to keep
You should not eat
You would, do you want to distribute the books?
We will right after the conference.
Okay.
Yeah, but you want.
Okay, you guys then do this.
So this no other. They must teach us something. There is. So people. Show you the keyboard, yeah.
ठीक है अभी क्या कर सकते हैं what can be done
A cab and stuff can put.
Don't even have anything late for like this.
Yeah, actually, we just talking people here, and we were just saying, people who will go on the stage. That's what's happened here. We never did that. யாரோ ஒருத்தர் போய் டிஸ்ப்ளே பண்ணிருக்காங்க சார்.
ஸ்கூல் நல்ல கவர்மெண்ட் ஸ்கூல் நல்லா இருந்தா எவ்வளவோ பேருக்கு நல்லது நடக்கும் டீச்சர்.
நீங்க யோசிச்சு பாருங்க, நிறைய பேரு பழைய ஸ்டூடெண்ட்ஸ்னா நான் அந்த காலத்துல கவர்மெண்ட் ஸ்கூல்ல தான் படிச்சேன். கவர்மெண்ட் அப்ப அந்த ஸ்கூல் மட்டும்தான் இருந்துச்சு. அப்ப அதுல ஓரளவு ஃபெசிலிட்டிஸும் இருந்துச்சு. 2 ஸ்கூல் 3 ஸ்கூல் இருந்தது.
Can I say like I did not find my door? That can be an excuse.
Yeah, but I'll say that that's an excuse. Yeah, I need to do it.
Or some
You can use computers to, or like the media that's available on official websites. That's basically an entire use of computers, videos and stuff.
yeah.
Sir, tell me a number.
I sent a message to you.
You sent it.
Both of them.
Thank you, sir.
Thank you. என்ன ஃபங்க்ஷன் பாட்டியோட தான் இருக்கேன்.
Where are they sitting? ये ग्लोब पास में इधर ही खड़े हैं क्या?
पहले ही रो में जाएंगे
Can we have somebody to write in a lesson plan like that? एकदम lesson plan में बना देते हैं lesson 1, lesson 2, lesson 3, lesson 4. और उसमें LOs भी लिख देते हैं पहले lesson plan में क्या LO है, what is our learning objective?
Seven.
You also said
Okay, so is it okay if I give all these 11 to you and then distribute? Yeah?
Oh, this is in Tamil.
Yes, we have translated into.
My God.
But I mean, many Tamil people helped us to get this translated. I gave them. I will ask them to sign up.
There is no other word. Tamil only.
No, we have a bilanguage system.
In Tamil
There are these 11 more copies that you also have to distribute. So please do that. And this is a big ideas in astronomy book. We hope some of you can help translate it.
Nadi Shastra hai. Nadi Shastra like ancient period मध्ये
If you are
जे
interested,
होते
then please.
त्यांनी घेऊन ठेवलेले like
I will get
तुम्ही
your
त्यांच्यासमोर गेले तर
signatures.
तुमचं अगदी आई वडिलांचं नाव सुद्धा ते सांगते की कारण एक बिझनेस करणार
Sorry, Asmita.
data is there with them all. The person is in Delhi. They are implementing.
Five.
They have that
Group number 5.
all
6. 6 is sitting outside and 5.
outside.
Over that Newton's space. This is 2.
Okay, so Asmita is working with the maths group. One by one, she will come around.
I'll take your number just for me.
6 group is standing outside.
7.
All the 11.
No.
Yes, I think. Kumar sir.
Where should we sit?
Yeah. Oh, you have to join.
Oh, yeah.
If you have anything extra left, just
Yeah,
We will all give you the books in English or Hindi or things like this. So just wait. Where did they disappear?
I think still people are outside.
அப்படியே செட்டில் ஆயிடலாம்னு நினைக்காதீங்க நாங்க மிங்கிள் ஆக முடியாது
In my hometown, hardly 30.
Sir, do you know Hindi? Script.
I'm just scribbling. What I'm writing, log in back.
इथे पूर्वी ना नारळकर सरांनी पुण्यात 100 कुंडल्यांचा सायंटिफिक स्टडी केला होता. त्यावरून त्यांनी बरेचसे त्यावेळेचे 20-25 वर्षांपूर्वी जे काही सगळे शास्त्रज्ञ होते पुण्यातले मुंबईतले यांनी जॉईंटली ते एक प्रकाशित केलं होतं. त्याला काहीच बेस नाहीये.
हा म्हणून नारायणकरांच्या विरोधात बरेच लोक गेले होते.
आणि त्यांचं जे पुस्तक आहे आकाशाशी जडले नाते त्याच्यामध्ये तो पूर्ण चॅप्टर क्लिअर कसं केलेलं म्हणजे त्याच्यामध्ये त्याला बेसच नाहीये सायंटिफिक आणि तो कुठल्याही याच्यावर तो प्रूव्ह झालाच नाही. मग परत एक चॅलेंज होतं त्यांचं की आम्ही तुम्हाला 100 पत्रिका देतो ज्या अगदी पुण्यातल्या चांगल्या लोकांनी केल्यात. तुम्ही ते त्या किमान तो स्त्री आहे की पुरुष एवढं सांगा. ते चॅलेंज घेतलं नाही ते पुण्यातच नाही म्हणजे जे काही
मग नारायणकरांचं हे पडलं का मग खाली म्हणजे लाईक
नाही
केलं का नाही ना.
उलट ते प्रूव्ह झालं ना ते म्हणे की मग आता ऍक्सेप्ट करा की ज्योतिषशास्त्र हे सायंटिफिक बेस नाहीये आणि हे चाललंय कला म्हणून
धंदा म्हणून
त्याच्यावरून. कारण मग आता मोठमोठे जे इव्हेंट होतात त्याचं प्रेडिक्शन कुणीच का नाही करत. नोटाबंदीचं कुणीच नाही केलं. असं बरेच जे अचानक झालं म्हणजे माणसांकडूनच झालं. अजिबातही त्याचं म्हणजे त्याच्याविषयीची शक्यता सुद्धा कोणी वर्तवली.
पुढे जाऊन असं नोटचे
सुनामीचं असं बरेच इव्हेंट आहेत नॅचरल मॅनमेड वगैरे अशा.
मग ते डिझास्टरचं सॅटेलाइटच
आता उलट डिझास्टर सांगता. म्हणजे त्यांना तेच विचारलं की मग तुम्ही तरी सांगा की तुम्ही कुंडली मांडता देशाची मांडता राज्याची माणसांची तर मग 100% सांगा. असं म्हणजे एखादा प्रवास करणार आहे रेल्वेने प्रवास करणार आहे त्याला अशा अडचणी येतील तशा येतील हे कुणी एक प्रेडिक्शन आहे पण तुम्ही 100% क्लिअर सांगा. मग ते म्हणतात तुम्ही सायन्स करा. सायन्स असं प्रेडिक्ट करतच नाही. टेक्निकली समजा काही झालं तर काही होऊ शकतं प्रोटेक्शन मध्ये किती चाललं तर पण मग तुम्ही नका असं करू. भौतिक घडामोडींच्या पलीकडे काही घडत नाही असं त्यांचं मत आहे.
2-3 वेळेस ते वाचायला घेतलं आकाशाची कम्प्लीट होत नाही इतकं मोठं पुस्तक ठेवलंय त्यांनी. आहे ना पुण्यातच येते आता त्यांची मिसेस वारल्या ना त्यामुळे.
आम्ही सुरुवातीला एनसीआर मध्ये ते एकत्र आयुका ज्यावेळी बिल्डिंग तयार होत होती ना तेव्हापासून आम्ही बरोबर बेंगलोरवरून आल्यानंतर इथे मेन बिल्डिंगच्या समोर एक गोळे बंगला म्हणून त्या मध्ये परफॉर्मिंग आर्ट सेंटर आहे तिथे नाही का आता रामलीलाच्या त्या कलाकारांना लावलं तो बंगला तिथे निम्मा बंगला त्यावेळी IUCAA आणि NCRA ला वापरायला दिला होता हे सगळं होईपर्यंत. मी 2-1 वर्ष तिथेच बसत होतो. मग नारळकर सगळे NCRA च्या एका रूममध्ये बसत होते. मग IUCAA झाले. मग ते इकडे त्यावेळी आमचं इथे IUCAA आणि NCRA काही फार वेगळं नव्हतं. त्यावेळी ते गाजलेलं होतं ते मांडत होते. त्यांनी ते दाभोळकर सर असे बरीच लोक होते, मानव सर होते. त्यांनी ते सायंटिफिकली सांगितलं की याला बेस नाहीये, आलंय जे चालत ते तुम्ही वेगवेगळ्या प्रकारे टेबल्स बनवले, हे केलं ते केलं, पण यातून असं काही ठाम नाही सर. ते कला त्याचं काय म्हणतात त्याला व्यवसाय अशा
बिझनेसच चालू केला.
that is computer group. This is what group? One. अरे एक नंबर बघा.
But in which group? Math. Computers. What is the arts? So what all this so we have to supply the design on the and for yesterday.
अडचण कर
Photo is nice. Yes, yes, yes.
And come with the idea.
Or it can be used. But of course,
We don't have feel like my class, so that's how they do class. But like, so it's messy. It's a separate
You are in maths. That's what I was asking. Yeah, I
Which is great. This is our
sorry to interrupt. What subject you have?
Science.
Okay, so I mean, what ideas you're working on right now?
we are working on temperature.
Effect of temperature on the season
Summer. How the temperature is increased. Why?
because of the season.
That's good.
How seasons affect the temperature change, right? I'm sorry to interrupt. What concept I want to cover? I'm from geography.
What are you? What are you covering?
So, okay, fine. So, ma'am told us that this season, although it is interdisciplinary, but basically where the teaching is in geography, basically. So, the main frame of season starts from geography. So, what we were thinking, okay, so what we were thinking is we did the same stuff. And then wherever we need the inputs, like suppose math is an algebra, so we call it math is systematic. And then if you are explain science, then that basically is how I think starting like or maybe how the axis is split and from there.
Don't go in that. Science part.
So that is what I
But
want to
then we
know.
can have your basic knowledge.
Yes, we can have that how the reason.
Then how the life
Opening can be something like that. Just be, maybe
Sir has a very
First to, my opinion is first to take look to your classroom.
Tell students where we are on
Right now.
our location first. Then explain them rotation about moon, etc. And then you first from geography itself. I'm saying. Then we can go further.
Yes.
We can start with the globe activity.
Yes.
So we can ask our teacher to make a globe, or maybe globe is most of the time ready.
Ready.
Yeah. So in science, what else we can do? What else we can do? Can you explain the rotation of all this? I don't know.
Day night
चांगले आयडिया आहे तर सांग.
Instead of telling or using the word simply, can you ask them what they are doing? What are the different? So, and they are so this season that is
Because of revolution, the way the rays are reaching the. So accordingly, the rays also will change, na, the angle.
main thing is temperature.
And one more thing, also we have to explain the height of atmosphere. Usually students, even we are not aware, taking some reference. This is the height of Himalaya. This height is for clouds. This height is for thermosphere. So whatever they feel, that is very, very down to surface. Season, yes.
बेसिक त्यांना प्रश्न विचारला
नाही आपल्याला कुठे ग्रेड 6 ला शिकवायचं त्या हिशोबाने प्रश्न
हो जस्ट 6 स्टँडर्ड
त्याला उंची जसं डिस्टन्स आहे ना तसं हाईट म्हणजे मग
in one period
काय सांगते टरबूज एवढी खूप असेल तर वातावरण किती झाड आहे तर याच्यावर संत्रीची साल आहे एवढंच आहे मग त्यात प्रश्न रोजच्या उंचावर जातो हिमालय किंवा कळसुबाई 6-11 किलोमीटर ते 11 किलोमीटर अगदी इथे
जे रोजच्या डेली लाईफ ते लवकर रिलेट करू शकतो
migration
adaptation according to the season.
Sir is telling that height is also that much important. Yes. But that is why they are giving
Nowadays, scale models are also there, or images are there. You can refer Himalaya heights and explain them. But it is again related to science. You can explain them in which layer cloud activity happens. For season cloud raining is important.
But I guess that would come when we go for more and more deeper study of physics.
We only see in the southwest regions.
Okay, that way only
That is
you
the
have to
third
consider.
season which is a specific part.
The question should come from them also. No? Questions should come from students also. Now, if we are just yes, yes, correct.
For direct rays and slanting rays and direct rays.
We need TLM, no? Teaching learning materials.
We can also one day only one topic in the maybe temperature.
And the distance also.
So this experiment, this works. No, we can't see the
Yes, curvature of the earth. Distance and surface.
So globe only will take more directly. So whole space जो है वो पार
Yeah,
it
very
says come along brother there are two people somewhere why don't you come along?
Actually, no, we are thinking of too many things to be covered in one period.
Right? No, no, right. Right. Very nice.
These jokes are very on the side, so if they are like
Not get that much.
the temperature very
Like a small of the topic can be done like this also. Yes, you can have that. It can be done.
what we do is
Summer
To explain.
I will just write outlook and then make one for temperature. So for further also we can make it, we don't have that much space. Make for one. So if you want to teach feelings, I mean temperature through feelings, we can show feelings of the earth and so SEL versus
Yeah, that's what I was telling. Yeah, we will show you this. Yes. Tell her that. And after summer season, this was opening instead of saying some random things. Yes, yeah, very good.
this I had drawn we have 5 more results not to tell temperature but we can say that I am that burning force won't affect us. But
We have 5 more minutes, and after that we'll start the presentation.
and
Excuse me? Be careful with the wires.
It's not on. Na?
That is not on.
तेवढं आपल्याला वेळ आणि त्यामुळे नाही त्यांच्यापेक्षा स्वतः आणि काफी पुरा 1 वीक लागतो.
The little overlaps will be there. So when it comes to, see, sometimes it's a bit tricky at this point because we have really less time. But the way you can see it as you can go a little more in details of how each answer happens. Then there are chapters of concept. So it might not be the initial concept. No, not conventional, but temperature, how is it happening, and the things that we talk about, depending on distance, how it happens, if the source is radiating in isothermal, what object, and that's how is it calculated. They don't get into calculation while so that they can certainly it's little smaller, getting dimmer, less light. But perhaps as a science like grade students, you can also consider using some sensors. Five box, use it, and they can actually measure the intensity and see how it is. These activities simultaneously could be done. In that time, we will talk about that is absorb different amount of everyone exactly right. Topics of their own subjects. At this moment, you see the syllabus is that's why we talk about differential science is not very easy or understand until you don't manage with your experience. These curiosity for how temperature, how structured. That's why we talk about this paper. It will be quite active. But the idea is every other book is narrow basic syllabus at the same time. They shouldn't be like helping the geography teacher to say something. That's not the objective. Because some part of her own subject is also important. That so when science teacher does it or maths physical geometry, they will do it at a different
level also with you. And who go in whatever they learn, that helps them understand the daughters. And if it is done through, let's connect it better. Because angles
They are coming quite often.
That's this and why. Some of these things also come from present structure. If we are getting instructions, we have to read it. And find how to concentrate some other subjects. वैसे भी चैलेंज है इन शॉर्ट but we lined up
Yes. Okay, class.
This is always a challenge in classroom, right? इनके बाद बिठाना
I should say. Say it loudly. If you can hear me, clap. Say it loudly.
But can you hear me?
Yeah.
That means everyone can hear me.
That will grab the attention of others.
Okay, let me get that right. So I was reading a book recently. Okay, listen. I was reading a book recently about a teacher who tried these different experimental ways of grabbing students' attention. And the teacher used to use a trick of singing. So instead of shouting in the classroom to get students' attention, but of course she had a beautiful voice that ensured that students be quiet. My thing might not work. So I request everyone to take place, take their places. You can be seated in groups as you are. And we can start because we have really less time. And you will see how much time it takes later on. Because at the moment, she's calling us there. Yeah. So there are 4 groups, no? 5. No. Like science, maths, 5 groups. Sorry. So 2 minutes to settle down. I'm just trying to mimic. How does it feel? Okay. I feel so good.
We are disciplined children.
Yeah, thanks. See, at the moment, I am aware that we all, including me, are in a state of chaos. Because for me also, this is an experiment. It is not structured as much because it cannot be structured. But the fact is, if I have to implement it in classroom, it needs lot of prior work. Is also the challenge that comes up in this. At the moment, we have done 5 groups, 5 subjects group. Okay, but in the classroom, you already said we have tried starting with 2 teachers, 3 teachers, 3 subjects. I mean, okay, and some have gone to Shakespeare and combining Shakespeare and Einstein, which is also amazing. But right now we restricted to STEM subjects. And
we will quickly look at how we can go about teaching students of 6th and 7th grade a topic called जोर से बोलो how is the Josh?
I think this is
I think it is closed. It's not. So, so everyone has small pieces of what we want to build, and we don't know how much what others have done. So there is a little bit of uncertainty, but we will start progressing. And if not, I have my slides ready. So at the end, we will cover seasons for sure. No, that I was warned about it. So
The 6th graders
also
again.
I wanted to keep, we'll bring it to some conclusion and we'll see that we learn about seasons as well. But we'll also try to come up with things that you had discussions. It's been like an hour now. We have been discussing. We were, it was almost an hour, yeah. Maybe a little less, 15 minutes. So, how, in the process, he also, the first question to me was, what is the age group? Which means, what are the things the students have already learned? Then we also role played, right? Okay, at this age, ये नहीं समझेगा. So, we discussed it, but we knew that it's not something that will go in the classroom as it is. We will simplify it. Okay, so without taking much of your time, let us start. Geography group, I thought instead of me being the Sutradhar, let one of them come and be the Sutradhar of that event. Oh, you don't have to use this, but you can come and explain. You can use the board, or you want to put the slides. Or you can use the methods that we use. See, for talking about seasons, okay, I will start giving the pins, like, what do you say, for some navigation milestones. So, what is it, the two bodies that come into play when we talk about seasons? Is it moon, earth, sun, stars?
Sun and earth.
Sun and earth. You want to take over geography as to how is. So we're coming to
all of them.
Yes.
There are 2 mics here. Whoever wants to speak, they say this.
It will fall down.
They join the.
Oh, they can join the Zoom.
Do you have Zoom?
Yeah, Zoom is.
Can you?
So can you put in the WhatsApp?
Yeah, that's what I mean.
I can share it. Yes, yes. So anybody on the mail and they can show it.
Okay, yeah.
I can make a collaborator.
Yes.
You can show in front of this camera.
It's on slide, so anybody
Slides.
can
This
just
camera, it will be visible over there.
Yes, so which email ID?
Biology. I become a regular.
Yes, yes, yes.
Okay, everyone.
Okay, so basically the topic seasons was given to us. Although I visited different groups as we were bifurcated in, and then tried to understand that what all subject teachers or what each subject is trying to put in to teach this seasons topic. So basically, as I've discussed with you, what we have tried to do is, even though it's interdisciplinary basic subject it belongs to, or where we do usually see in geography, right? So I thought that it would be better to start with geography, and then wherever different references of the different subjects come, then the subject teachers can come here. Like suppose for science, we need any inputs, then whoever is representative that you have decided for science, maybe one or two, and they will come and then explain, give their inputs. So subject wise, we'll go ahead like this. So I request Reju sir to give foundation or basic idea as a geography teacher will start with in a class for the topic of topic of seasons, and then we'll proceed with different subjects.
Can we define a time limit, please, so that all of them will play their role? Because we need to cover it.
We have 20 minutes for this whole activity, and because at the end we also want to discuss.
So 5 minutes for each subject.
So it wouldn't be 5 minutes. What we thought was, in practical, you will see every teacher would be doing their things in their own classrooms. But right now, as geography geography teacher will take us through. So when they want to talk about revolution, they might ask maths group to come and talk about variation of angle as the planet is revolving around the sun. Then when they talk about sphere, they'll call them for latitude and longitude. At the same time, if art teacher group thinks that they want something to be added at this point, they can do it. The places where they want some explanation from science, they'll call you, like variations with distance, how are you, and all. Is that clear?
Yeah, we have done according.
Okay.
All right. Good evening, class. It's actually.
Okay, so we are going to start with the curiosity building in the students with a think, pair, share activity, which usually we do as a hook or a do now in our lesson planning structure, where we will tell them these two questions to think, pair, share, and once the child thinks personally, he pair share with the partner, and then 2-3 whole class sharing, they'll get a glance about it, about the tilted face of the earth. Yes, then we are going to list them the objective which we want for this unit to be, that we are going to learn about causes of seasons. There will be a video to be shown in which all the details about the latitude, longitude, and tilted face, all information about the seasonal changes will be given. And some, okay, I'm changing over here. Sorry. So here is the objective, then the video showcase, then the visual representation, whatever they have seen in the video, they can take this in the notes or in a format with them in the notebook so that they have a reference to look at it. Then the maths team, please come. The maths team will explain
the latitude and longitude. So I will just. So before we go to latitude and longitude, I'll add one more thing here, that she said that the two will pair together to understand. First, there is a gravitational bound of two bodies, the sun and earth. So the revolution is happening, and when the revolution is happening, how is that happening? I'll expect that to be done by. So we have done it quite way too often, like how moon revolve around the sun, or to understand how earth revolve around the sun. So we have seen that thing.
So that role play can be done by geography teachers. Rather than just showing videos, I would say that that can be done where.
We have a hands-on activity also.
Okay, okay. So we'll start with that. That there's a sun and there is an earth revolving around it. So when you talk about revolution, what happens is maths team. Can you explain angles and how do you think you'll be teaching angles in one dimension?
We have to come in the stage and talk. Just give the information or we have.
If you have presentation, I mean,
Actually,
give
what
it.
happened that about the longitude and latitude, we have our own presentation. As we discussed and we have taken that point. So whatever they are asking, should we explain our whole lesson plan or we just have to give the answer?
I would suggest come and explain your whole lesson plan. The first thing, start with revolution of Earth. So then you explain change in. Okay. Okay, come. Yes.
So every grade section must have made a proper 60 minutes or a 40 minutes lesson plan, how they are executing. So in this, we have put up all the section in between that this is completed by that time, maths is completed, art is, first I would say first step is art is completed.
Yeah. So everyone, please stay attentive to what the main person, one person who is saying, so that you know at what time you have to pitch it. Okay. So fine, we'll come back to that. I'll invite the maths group right now who will do the foundation, maths foundation that's needed. Of course, we don't have 45 minutes now, so you have to be quick with your things, but ensure that you have to point out what students don't understand and what you are going to highlight.
Reach to the lesson. Reach to the lesson.
And you have to catch them wherever things are missing or give suggestions as to.
Initial part is not catching. We were very silent students.
They
were not naughty for them. How can we naughty for her now?
Hiya.
Hello.
Yeah, I need you loud in class. Hiya. Hi.
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 Hello.
Hello, that's fine. How many months are there in a year? 12. How many weeks are there in a year?
52.
Is it exactly 52?
Little bit more.
If it is a ordinary year, 52 weeks and 1 day. If it is a leap year, it will be 52 weeks, 2 days. Is it 2024 a leap year or a leap year? Yeah, fine. How many days are there in a week? 7. How it is related to season, you are all thinking. I'm thinking so. Okay. How many seasons do you know? What are the seasons you all know?
Three seasons.
Only 3 seasons?
Winter,
My thought.
but we don't know. Summer, rainy, and winter. 3 seasons. Our children will say 3 seasons.
Tell me the seasons you all know. So, summer. Next one. Spring. See, you are students at the time when she is teaching. So you have to respond promptly. Otherwise, she has the whole answer. Then only I can give my concept. Otherwise, I can't give it. Monsoon.
What is spring?
Winter season.
Winter, good. Next. Autumn.
What is autumn? We don't have it. We don't know.
Ma'am, I didn't ask in India. What are all the seasons you know? Okay, you know, what are the seasons you tell? Okay.
Three. Only 3.
Only you know 3. What?
No autumn.
No autumn, okay.
No spring.
No spring, no, okay.
Only 3.
We know only summer.
Summer, monsoon, rainy.
Rainy. Yeah, good.
Nothing but a monsoon oblique rain.
Oh, okay, monsoon is a rainy. So, what?
But traditionally we know 6 seasons also.
Ah, we know 6 seasons.
What will be the spring and autumn?
Why we are contradicting from what are the basic things we know means it is there is autumn, there is spring, there is summer, there is rainy, that is also called monsoon. But we are doing summer, spring, monsoon, winter, autumn, and rainy. In India, we don't have autumn. In India, we don't have spring. Why this happens?
You have to be quick also. You cannot go at length because everyone has to get chance.
Okay.
So at some point try to.
Okay.
So how do you want to use this information to come to what you want?
How many months are there in a season?
Nowadays,
Nowadays it changed, but in classic, how many months are in that season? Oh, okay. What makes the what is the reason for change in season? Revolution? Tilt of the earth. Okay, now we are getting a right answer for me. What is the tilt of the earth? 23.5 degree. So 23.5 degree. In today maths class, we are going to see about what is the common name of 23.5 degree? Angle. What is that? Angle. So in class, we are going to see about that angle. Okay, let's take a graph sheet. How we are predicted this? Let's take a graph sheet. I will give you some coordinates. Okay, that coordinate are Tamil Nadu and Pune. Okay, the coordinate of Tamil Nadu is Chennai. It's especially Chennai. There will be 80, 30. Chennai. 80 and 30. It is a x coordinate and this is y coordinate, but it is longitude and this is latitude. Okay, and Pune 74 and 19. It's also the approximate value. This is not the exact values. If you plot them in a graph, means you are getting a straight line, right? If you see it to the globe, is it a straight line?
No.
No. Why? It's spherical in shape. Then we are getting an angle there. We are moving using that horizontal line. We are moving that horizontal line in some angles. So we are not getting in the straight line. That's where stop. Then
I think this is a Chennai. Okay, we are moving from Chennai. Yeah, then we are getting Pune. So that place value covered by arc and that these two lines is called the angle. Okay, that's the definitions. We will simply complete it. Okay, like that we are introducing seasons to the topic of angles. How we are going to get the topics and how we are incorporating the seasons and climates, longitude, latitudes is it? We are giving the word problems. Okay, let's take two places. Guwahati and Ajmer means Guwahati and Ajmer. Guwahati and Ajmer. What is the longitude of Guwahati? Do you know the longitude of Guwahati?
Guwahati is
90 degree east. 90 degree east is Guwahati and Ajmer is 75 degree east. Okay. We all know in social, in geography, we had learned in India, Guwahati is the earliest place we can see the sunrise.
Yes.
One more time, right? In Ajmer, we will see the sunrise at the delayed time.
Yes.
How long? What is the difference between the sunrise?
So I'll interrupt at this point.
Yeah, this is a question that we are going to give to the students.
Make the problem. We are making that in a word problem, and they will calculate how they calculate what's the difference in the time. So how the longitude affects the sunlight.
Get to that yet. I would say I'll interrupt at this point. Just think about it a little differently. So we talked about two bodies, right? So the first thing would be how they revolve around each other. I appreciated you asked number of seasons, right? So we have sun in the center. I'm not good at drawing. So we have sun at center, and we have moving around by 365 degrees. Do you know why we have 360 degrees?
It is a spherical, object, 360 degrees.
Huh? So this is a contribution of astronomy we can boast about to maths, which many of the students might be cursing us for, is where the hell this 360 comes from? Any guesses? How many days Earth take to revolve around the sun? And how is this motion? Let's not worry about what angle. It's a circle, right?
Yes.
Huh? So 360, approximately 360 days, 1 degree per day. So how many degrees it would be? 360 degrees. Now, typically we are talking about 4 seasons. So Earth, let's say, is revolving around the sun along this path. So 4 equal division would be 1 season of how many degrees? Days.
3 months. 9 months.
4 months, 90 days. Okay?
3 months.
3 months, 90 days. Then 6 months, 180 days. So
9 months.
that matches with angle.
Yes.
So why did this is 2D space, right? But what maths teachers can show in this is we can just use one number to denote where the Earth position is on the axis if we use spherical coordinate system. Right? So it's a one-dimensional. And how we know every time it moves by 90 degrees, the season is changing. So what exactly is happening when the sun Earth moves in by these 90 degrees of installments?
And spherical coordinates taught in grade 6.
It's not taught, but that is the thing that in geography they need it. We have talked to maths teachers also that they have not taught it. But if it's done in maths classroom, it's done in a better way than if it would be done in a geography classroom.
Yes, they know about the 360 degree of the circular angle.
Angles they know. They know if I have one arrow here, if I go on changing the arrow which is directing to Earth, this angle is going to change. So it's a simple extension of what's already taught in the classroom. And that helps us tell, because if they when they open the geography classroom, they see these numbers 90, 180, 270 and 6. So the next stage is, so this can be done by a role play model where 2 students are actually doing it, which can be done in classroom. But if maths teachers have talked about this variation of angle and how it can help us describe a circular motion, students will appreciate what these numbers are in much better way, that when I stand facing this side and when I turn by whole circle, it's 360 degrees. This is called rotation. And when I move around somewhere, again the same thing happens, and it is also something that can be represented by an angle. Now the second stage is, how is this rotating body and what is happening as it moves from these different positions. Okay, so you can sit for a while. I'll call you for latitudes and longitude later on.
Thank you. Thank you.
You got the thing? I mean, they are doing a lot of things in the class. But what we needed immediately for what they were saying is what the part I'm using right now. And here, this is not easy for students to understand. See, even when we talk to any artist, it becomes a little difficult. We have to draw and give them. It's not very easy at students level to understand what these angles are. But everything comes in that one seasons chapter, and then the chapter is over in 2 pages. It's a burden. And then the whole of geography is banked on it. So students end up by hearting it, the real visualization that it needs is missing. And that's why the logical thinking related to it is also missing. So let's go to this stage.
Ma'am, just one thing, just very casual only. But when we talk about this 4 season, just now when we played the naughty children part, definitely students here are not getting that 4th season thing. How we are going to just tell them that you have to consider the 4 seasons? How to do
So
that?
right now, we don't talk about we have 4 seasons in our place. When we talk about seasons, it has to do with revolution of Earth, whichever part of the Earth, whichever part latitude we are on. The reason for it is revolution of Earth.
Yeah, she's asking about the season. So if you look at the
because
diagrams, can you go to the first diagram that you showed about the
I'll move to my
so there is
slide.
spring and autumn. Equinoxes are shown, right? So she's asking that problem that how
Now also in this picture, when taking help of maths and angle, when you try to depict about, you get major emphasis was on 90, 90, 90. That is that 4 months period,
No,
right?
wait.
3 months
I
period.
understood your question.
Yeah.
So, see, at this moment, with the constraint of time, we will go through.
the thing is they are thinking about India. Then I say, imagine right now you are in like America or some other.
That thing makes no
I don't have
sense.
to. Just give me.
Sure, ma'am. Sorry. That 4 was a picture.
See. So, So, yeah. So we don't jump to, we are starting and creating base for explaining seasons. So this doesn't mean or need not mean ever that there should be 4 seasons. We are just coordinating. The first slide that I showed, a fancy picture, depending on which place I am on, it could be right or wrong. See, I could be a teacher in any part of the world, right? So it could be right and wrong. That's not the concern. The concern is like what causes season, and the basis of it is revolution of Earth around the sun, and then we will get into the details of in what is the path of rotation, what is Earth, what is the shape of Earth, how is it rotating around the Earth, sun, rotating around itself and revolving around the sun.
Can I make a comment?
Yes.
I would just say that to the students that we are talking about hemisphere, northern hemisphere. What is the average number of seasons in northern hemisphere, not particularly India? You can mention that monsoon is a local phenomena because of our
See, we'll come to those things because
no, I mean when we also give this talk, the students first ask like where is monsoon and why 4 and all.
Yeah.
But you can think about like the hemisphere average.
One more thing, as you said rightly, 4 Earths we need to show in the diagram and all. You can also tell them that at poles, when we have 6 months there and 6 months night, how are you going to talk about 4 seasons? Right? That also comes in.
certainly. So this is point taken, but we'll go one bite at a time. Okay. So these things will come as to how will be what will be the global feature when the Earth revolves around the sun, and what will be the local features also. So once they understand the global picture, it is easier for them to understand local picture. So certainly these questions will come because they are from their observations. But what is happening in this case? So shall we start with, we'll change the form a little bit. that whenever you say that think that your group can add to this, just raise your hand and say we would add this part in it. So rotation we can show, and we have thought of these 5 options is what you can tell us. Okay. This was just an example, but it holds for every other person. So yeah. So what we saw, this is a picture from geography textbook. Now this picture is very loaded. We'll be segregating these things one at a time, but it's really different, and the chapter gets over in few pages. Some things are flashed without the reason for it, but you know, as a teacher, you will be getting questions from students as to why. So when this is moving, we talk about, you see that it's a circular motion. We talked about eccentricity of when one body is moving around the other body, it's not circular, it's elliptical, right? And what decides what is the main property of ellipse?
The distance is not symmetric. At one point it will be less, at the other
Huh?
point it will be more.
So typically this is the image that we see, right? Because it's also what do you say? Artistic picture which says that we are looking at it from different view apart from top. So this is not a top. So we have and that's why like often this ellipse, you have this oval shape as well as you say that it's an elliptical orbit. It creates a misconception that is it as elliptical as this? And if it is as elliptical, the focus wouldn't be here, it will be away from the center. But if you see, so certainly it's not at, the sun is not at the center. So it's not equal distance. But there is the farthest distance that the earth goes to. And you see it's 15.2 crore, 10 raised to 7 kilometers. And perihelion, the closest distance that the sun reaches to is at 14.7 into 10 raised to 7. So the difference isn't as much.
So with the help of a video, the link has been shared. So this can be shown to the students in a simulated manner. So the link has been shared on
It is there on my PDF.
Okay. So you mean to say
Computer is going to do that stimulation work with them.
okay. So at this point, we will just take it that these things can be nicely shown using some form of simulation, as well as there are apps like GeoGebra, where the students can choose the eccentricity of that ellipse and they see what the path would be. So if we have a top view of Earth moving around the sun, it is almost close to circular shape.
So in that, the rays of the sun, the slanting rays, the vertical rays can be seen according to the date where Uttarayan and Dakshinayan is happening.
So you can set the date of solstice, summer solstice, winter solstice, equinoxes, and then you can accordingly see that the sun's northern journey and how it again comes back, start the southern journey through the rays and everything.
So what software are you using for this?
It is there in my team.
Oh, see, the thing is, are you okay with sitting for like up to 6 o'clock? Then I'm okay, but that's my concern. Huh? You all want to see? Huh? Is it okay?
Yes.
Does the elliptical orbit of the Earth affect the seasons a lot? Yes. A lot?
Not a lot.
It does. Elliptical.
Yes, because of that only sometimes we can see towards north and sometimes we can
Axis के वजह से.
Both thing together.
You should share your screen.
Yeah, it's frozen. Cursor isn't moving. So it's added to your own.
See the computer section. Yeah, click. Yes,
The simulation.
open.
She needs to share the screen.
So
They have shared the
So yeah, do you have a group for these people? Where you share things?
They have
So I would
shared.
appreciate if you share it on the group also.
They have shared already.
Yeah, that's great. So
Just move.
oh, okay.
Now the red cursor. Yes. The rays and sun.
Okay.
This is moon. No.
So yeah, so let's go one at a time. So yeah, perfect. So at this point, computer group has given us a link to a visual. So it's a simulation where you can just move. You have seen while I was changing it, right? And we'll come back to it. It's really good. But when we go to that stage, we will come back to it. And what we saw was, as we move along this axis orbit, it is giving us some more details of how the rays are falling on the surface of the earth, whether they are direct or slant. But before that, everyone please. So before that, first we saw that season. The reason for season is temperature, right? And what is the main source of temperature? I mean, why is temperature बढ़ रहा है तो कहीं पे तो sorry, if the temperature is rising, there has to be heat somewhere, right? So what is the source of heat for someone sitting at home? See, you are talking to students. So what is the source? What are the sources of energy? Everyone agrees, sun? Yes. Is there anything else? Are you sure? Primary so major source, huh? But is there anything else for us? Fire. No. As in which leads to heating up of
Fuel.
Certainly, let's stick to what we want, where we want to get to. See, at this point, we all are trying to develop a lesson plan. So don't give random answers. Carbon dioxide is going to increase heating, but is it what I'll bring it at this point? So at this point, it's sun. Moon is also there because it's reflecting some part of light which would have otherwise gone somewhere else, right? See, these questions can come. We see light coming from moon also, but that is a secondary source, and the amount of light you see is different. Yeah, so that is certainly not going to increase the temperature as much is needed for the change in season, right? But we see some difference, like in light on Purnima day, we see some more light, but it's not it doesn't give enough heating effect. Numbers can also be calculated or shown somewhere from references. But so the primary source is sun. And then when this is moving around at a around a circle which has different, where the earth will be at different distance, do you think that will lead to season?
Not season, but severity of season
Might change? Or what do you think? How would you think about it? So the first thing is, if I'm close to the burner heater, I'll feel hotter. And if I'm farther from, so don't rush. I mean, as I said, we're talking about distance first. So what do you think? Will distance affect?
Matters much, I feel, because 0.7 and 0.2, 0.5 is the difference.
Ma'am, it is
But is that the way you think about it?
0.5 crores.
So how would you reason it? Do you want to physics group? Do you want to tell how would you?
Closer to the source, you will feel it more.
You are not louder.
You can do the activity with the torch and the cardboard.
Torch and cardboard, but what will you do now?
It
You're
will be
going to
like
change the distance.
Distance
Not
will-
slant and all.
No,
You just want to change the distance and see what happens.
Right.
So what do you think you can explain using that?
We can show, simulate the intensity of light as heat.
So everyone is with us. They are trying to there's one parameter now. What is this? Distance. There's a candle, say. There's a source of light and we are at some distance from it and the distance is changing. These are big numbers. We don't know how much effect it's going to have. So what are the things we can use to say that whether this parameter is relevant or no? What will be the temperature change? How would I estimate it from first principles as to how do we think about it?
Okay. So the sun is the major source of heat for Earth. So heat and light, both of them. So as we can see from the orbit of the Earth, that it is not exactly circular. It is slightly elliptical. That's why distance of Earth from sun slightly varies during its whole revolution. Now this little change, though you see the numbers to be changing very little, but they are in crores of kilometers. But so yes, the distance makes the difference. As you can see on the board, here now we are on the demonstration board. So as you can see here, the light intensity as your source is closer to the board is quite dense. You can read, if something is written on there, you can read very brightly and very nicely. As the light source moves away, the light intensity goes on dimming and dimming and dimming. Okay, so this same thing happens with the heat received from sun to the earth. So when the source, that is the sun, is little away from earth, we will receive the heat lesser, in less amount. Okay, whereas we are closer to the sun, we will receive the heat little densely, we will feel more hotter.
Yes. So
The
that
candle
is
example is better when we take the hand close to it. We can feel
Feel
more
it.
heat.
Certainly. See, beautiful.
That's
So
what I would
one
say.
thing what was brought up to us, this they had shown me earlier, so I'll just to fasten things. So as we increase the distance, we see if I draw a small square here, the amount of light that is reaching that small square is dimming, is what we can sense.
So here we have to tell them we are simulating light with heat. What the lamp and the candle example will tell is directly the feel of heat.
Yeah.
So that would be closer
So-
to the perception of 6th graders.
Yeah.
What it is.
Yeah. So the sensors are different. If this was a strong light, and if I hold it for a longer time, this will also heat up. So
Yes.
light is only causing the heating effect. There also in the candle case also there's light which is taking the radiations which are taking the heat, but we have our sensors intact. With cardboard we cannot. We'll need external sensors. Here we know yes, so
Heat.
it's getting hotter. But I'll give you a
I just wanted to add one point. While we are considering all the things, we are not talking about the tilt of the earth, which
I'm not
I
saying.
think is the most important reason behind causing of the seasons.
Season.
Because
But as
we
you're
talk
doing
about
point
the
wise now. That she has
But
suggested.
tilt is the first thing which I feel we should discuss first, because when we are talking about these two positions of the Earth as,
The tilt is making it
with
more
the sun, it is just that this is the shortest day and this is the longest day. It is not causing the seasons.
Precisely, but that is an afterthought when we know things. See, as a child, think about it. What I would know, think of first. As a child, think about it. So they would not think of tilt. They will first think of distance. And see, at the end, we are just thinking of one parameter at a time. We've learned, right? Break things and look at one thing at a time.
Now this is again a misconception. If the child is thinking that this is the cause of the season, and we have to correct them. No.
So that's what we are training, and that's what we are trying to do.
And believe me, when we have done the surveys, many a time students actually say it is this. This is the reason.
Then
why
further
it
explaining
is
this would be
important to address
further aggravating that misconception.
So I'll come to the point. See, that is the whole reason for spending so much of time. So there are two ways in which we can explain this. And let's look at the two things. So the first is, tell them to find out the day on which ephelion and perihelion happens. This is approximately the same time with a difference of 1 or 2 days across the year. So perihelion, I hope I have this right. So perihelion happens in January. 24th. I thought it was early January, but it's in January. And then ephelion happens in beginning of July. Now in northern hemisphere, just stay attentive to what I'm saying. Then reason it. Okay. Then discuss it. So in northern hemisphere, see, if we are talking about distance, tilt should not make any difference. Okay. But we are keeping that parameter off at the moment. So, but in northern hemisphere, what do we see? When is the temperature more?
July or January?
Month.
July.
Among these two, right?
Among
these two positions.
In July, the temperature is more.
The temperature is more in
Southern
July. But if the distance, farthest distance is in July, then will it be true? No, because when we are not taking into account tilt, we say that it will be same. If it's function of distance, the temperature should reduce in both the hemisphere equally. Okay, and what we see is not happening. So distance is not the reason for change in season. Get to the point?
Then we'll introduce about it.
Yes, certainly we are not going to leave that. And the second way to explain that is the thing that we demonstrated here. As the distance increases, even if it's a small number, when we talk about flux per unit area, it's a function of r square. So the variation, because it's luminosity, which is constant, as a function of divided by the surface area. So it's function of r square. So the temperature difference should be it's not linear as a function of r. The flux difference. So we can calculate these things, maths, and find out that the temperature at ephelion and perihelion, if we calculate the flux at the 2 point, the difference between the two is 7%. So certainly the temperature change will be less than 7%. But is this what we observe during seasons? Sometimes it's more, right? The difference between winter and the lowest temperature and highest temperature is more than 7%.
And 7% of the
Average. like the variation.
I mean, certain places have extreme cold, extreme high.
7. But precisely. So this distance cannot be the reason for cause of, it cannot be the cause of seasons, right? Is everyone agreeing to this? Huh?
Explaining this to sixth graders seems little off to me. Just
I think the flux part you might not have to go into as much details, but the first part that we talked about, the months and what will happen, at least if someone comes up with the question, teachers should know it. So if it is function of distance, both north and south will have same change. It will be low at the same time. We don't see, it's a different, as in northern hemisphere and southern hemisphere don't have same season. One have winter when the other has summer. So that itself refutes that distance can be the reason for seasons. But students do carry this misconception. So the second comes.
So what? Shouldn't we mention distance? Effect of distance? Why to explain that thing then?
No, as in we should also know what doesn't, what is not the cause, right? Because that's the misconceptions.
It is important to.
Even when this is not mentioned in the textbooks or anything.
And it's mentioned in the textbook, but sometimes you can just quickly miss that not all word is missed.
And they do carry this misconception that it is only happening because of this.
Only
this
but
may be true even in the pre-survey that we have done.
No, I'll tell you the image that I showed. It's on season CBSE board, and there's a mention that it is not a function of seasons. Distance. Season is not a function of distance, not caused because of change in distance. But again, the second slide that we saw, we are just telling them it's not a function of distance. Why? What if someone comes with the question, why? And the answer is not that difficult. It's like some of it could be, a part of it could be understood. So
may I suggest this just later? Because that picture, now I'm just suggesting, as that picture was there in the book, the students might have carried that blind concept that, okay, this must be having something to do with the season. So that's why that concept might have got taken to their mind.
Precisely. So see, misconceptions can come for many reasons. Sometimes it can come from faulty, I mean not faulty, but we might think we have said something factually right, but student might visualize it in a very different way.
So imprecise presentation.
Imprecise presentations, and as in there is no elaboration. If you see textbooks, 50% of the teachers would follow textbooks as it is, and if they follow, they would not convey the reason for that thing. So at the end, it just becomes a fact that is delivered. And then we don't learn a lot of science that we could learn otherwise. See, this is a simple thing that they play with. The intensity increases, decreases, that can cause a heating effect, and the area increases. So light, the same amount of light is spreading over different areas. See, this is like, they might not know the words. It's okay if they don't understand the word luminosity, but they qualitatively know what's happening. And they can understand the logical reasons. Eventually, at subsequent years, they will also pick up the terms of it.
I would also add that I would just say that studies have shown that it is very important to address the misconceptions directly. Even if you just tell them the right reason, they will maybe write in the exam, but 1 year later they will revert back to whatever they believe, because nobody told them that that is wrong and why that is wrong. So it's like a book thing, and one is like an intuition thing. Right? So studies have shown that you have to, if you know of any misconceptions for any of the subjects, it's very important that you say that in the class and you explain why that is not the actual reason. For not just for seasons, for all of this. Like moon phases, a lot of people will believe that it is caused by shadows of something, right? And then today you know it's not, but you have to still say these things to the kids.
So see, the whole business of science education is about understanding, not just at school level. Misconceptions are what do you say, picked up. Or it's misconception is also a wrong word. People object on that now because there's a negative connotation to it. But alternate conceptions that always the students might not have the right visualizations of what we are saying. So as a teacher, I have to be attentive to what imagery that students are going to form and then using appropriate props for it. And that is what we are trying to understand in the process. So so as I said, we'll be discussing everything. The first thing we thought of was distance, and we saw that distance is not the reason that causes season, but then what next? So in the meantime, in what can happen in art classroom is they can understand spheres. And for inclination, what is rotation? What happens to, see, it is one thing to know about rotation of Earth in phases of moon, and it is another thing to know about it when we want to understand seasons, we have to know a little bit more in detail. So when the rotation happens, if I draw one point here, how would it move when the rotation happens? Is going to help student visualize how the variation of temperature would be as a function of latitude also. So in the art classroom at the same time, what they can do is show them what a spinning ball looks like, what we have. If you put points at different along one longitude, I'll use the term, and if you put points at different latitudes, they will what do you say? We'll get concentric circles, and you'll see the size of the circles are also different. That means the distance, the circumference that that point is being following, the path that the point is following is different, but it is finishing it in the same time. So the speed will be angular velocities. Again, terms can come eventually, but the change in angle is same, 360. But the change in angle is same, but the time is and the time is also same. That is 24 hours for Earth. So the angular velocity is same. But if I calculate the speed of with which the point is moving, is it going to be same or different for different latitude? Are you sure?
Yes, it is.
How many of you think it would be same?
Change of linear speed. Linear speed will be different.
It will be different. And can you tell me how different it will be?
Different perimeter.
Distance
Different
covered
distance to be covered in 24 hours.
The velocity value.
So where
Each
will
circle
it
have a
be?
different radius. The circumference of each circle is different.
Yeah, that's right.
So t by t is equal to v. Each circle have a different t value.
So just tell me where the speed will be more and where the
Equator it will be
In
more.
the equator, in poles it is 0.
Yeah. So similarly, we can also help them appreciate. See, these are small kids. So we can help them appreciate what a sphere is when we slice it, how the circumferences are different, also by slicing things. And that can help them understand latitude. And when we show it, like how one particular point drawn on the circle inscribes this circle, they also appreciate why we have the axis like this. See, we have x-axis and y-axis in Euclidean. But whereas to describe a point on a spherical surface, we use latitude and longitude. So,
Polar coordinate.
Polar coordinate, yeah. That's right. And then, why do we use that? So, we use latitude as slices which are perpendicular to axis of rotation. And then we have the lines connecting north and south pole as which can be shown by orange pins, like where the angles are subscribed. So if I have longitudes, and when I say 10 degrees, where is the angle subscribed? So these can be shown by pizza. So if I make a slice at the center of this sphere and I connect the dots, the edges of the longitude, I will get a shape like this. And this angle, I missed putting the plot here, but these angles are essentially the longitudinal angles. So these are the things that can be described, taught to students by maths teachers at the same time. And then help them understand that, see, you understand plots, graphs in 2 dimensions. And we use x-axis and y-axis to represent any point on 2D space, right? But the moment that space gets curved, we use different method. And there we use theta, like if I have to show some point on the surface of the sphere that is described by the tip of my hand, what I would say is I move up. Instead of directly representing this point, I would say if this is 0, I move by 90 degrees and then by 45 degrees, and you will come to the point. Anyone would understand where I'm directing to just by these 2 parameters. So that is what we have as latitude and longitude. And then it helps at later stage to understand. So these things can happen parallelly in math class. So now coming to inclination. So I guess many of them are naturally happy when I said inclination. So yes, certainly this is the reason for seasons. But first is, what is inclination? And it's often taken for granted that students understand inclination. If you look at 6th standard, I mean, I understand that teachers fill in these gaps, but I am also pointing out, because we are doing textbook analysis, how these things are left in textbooks, where sometimes students might not appreciate what that numbers mean. So there is a table of planets and their inclination with respect to Earth's orbit. So this is like the Earth's orbital plane, which is perpendicular to the line that I've drawn. And so if I say the inclination was 0, we typically refer to inclination as the angle with respect to the perpendicular to the plane of Earth's orbit. Okay. So what will you, if I say inclination is 0, what would it mean? Huh? She says it will be straight. If this is the plane of Earth's orbit, it will be straight and the Earth would be rotating like this.
It is, inclination is 0. If it is 90 degree with
Sphere. By the, there's no sphere here.
Not
plane of the orbit. Rotating like this is the plane of the rotating orbit. It's 90 degrees. But when we say incline, what would it mean?
It will change to acute angle.
Say, need not be acute. Every planet can do have different inclination angles. So some also have 90 degrees. So if I say the inclination is 90 degrees, what would it mean? That the planet is rolling. And then there are some which have more also, 180 degree, close to 180 degree. So what would it mean? The planet is moving in
clockwise direction.
Yeah, so if we have west to east, that planet is moving from
There
east
is
to
no
west.
such planet.
And that is what we refer to by inclination. So these small concepts also get developed when we are doing it simultaneously, is what I'm trying to also appreciate. If I have to run through seasons quickly, this might barely take 10 minutes in this classroom. With students, it will take more. But as students are seeing these, visualizing these pictures simultaneously, they also see the small things that change when we change these parameters. So now when I say the inclination is moved by
planet which are rotating 90 degrees.
I'm not that good at it.
Uranus.
Huh?
Uranus. Almost 90 something. 90. Almost it's like.
So there is no day and night for it.
So he
Yeah, so we will come to that. So this is one activity. And what will happen if I change the inclination? Where will the sun rise if the inclination is 180 degrees?
180, it won't, there is no planet of such.
If there is a planet, I think there is one. I don't know, I'm really not.
So for it, it will.
So if there is a planet, where will the sun rise? Which direction
West,
the sun rise?
Sun will rise in west and set in
Exactly. So these small things, when students appreciate, they know what these things mean in a larger picture of geography. Otherwise, they just become numbers, which they by heart and present it in the classroom. So it's yeah. Sorry. Okay. So now we have tilted the earth, and I'm not going back to the same picture of tilt of earth. We all know that, right? We are in that same circular orbit around the sun, but this time the earth is not 0 degree with no inclination, but it is inclined. But is it inclined like this? We talked about moon, right?
No.
Tidal locking and all. No, what is it?
It is like.
It is
like
parallel. At every point, it is going to be parallel. And that is what causes seasons. The tilt. But how? I mean, why should I believe you? Can you explain?
Now the distance thing will come.
Will distance come into picture? Or is it something else? Boiler.
The inclination of the rays.
So now the shape of the earth comes into picture, not the distance. And the shape of earth, it's a big point, right? So that's why we also have this ball. So we can also use balls of this size where you would appreciate when you try with a torch. You want to show? You can show.
Torch is there only, ma'am. Torch is here. Torch is here.
So there was another torch.
So yeah, so when we saw it on a plain board, but what happens when the curvature is? Now, see, it's not just tilt, it's also the shape. What if it was a square? It would have been different. So certainly these things matter.
Switch off the lights, front lights. Be back so that it will illuminate the whole ball.
You want to see the difference? So, do you want to explain?
Okay. So anyone wants to explain, what do you see? Here, if I have a small doll standing here, we talked about it, na? How will I, a human being, be standing at any point on the sphere? Radially outward, right? And then, what do I see when there is a light ray coming from here? What do I say? It's from top. And see, look at the area over which it is spreading right now. Okay?
Smaller.
Okay, so
Now it stays the same, but look who even I had not seen this. So see, when you look, change the size of the ball, and you see that it's not just a tilt, but also the.
You can turn also to that side. So
Okay.
So imagine this is the Earth's
pole.
axis. This is the pole. Imagine this is north hemisphere, then this is south hemisphere. So sun rays is falling. So I'll keep the sun rays parallel. So this is parallel. See the difference.
Not able to see from here. We will not.
We will do it from the other side.
Lights not. But people in this You see that this is a small area and this is larger area. That's the difference.
So same amount of light falling, but is being covered in a smaller versus a larger area.
So there's one more thing I want to point out. So now,
Exactly, that's it.
That's the question.
so now she used something called parallel wavefront, which I have also shown here. We'll come to that later. But when the source is at a distance, larger distance, like we see the Earth flat, we can approximate it to be a plane wavefront. Now this is not obvious for students. If you go back to the same image, we'll discuss that it's not very it's not very intuitive to understand like why they have all of a sudden used parallel rays in that small elliptical circle. But one more thing, now the tilt is say 23 degrees. But what if it's a parallel ray, right? At this point, it is, I can say it's overhead. But what if I go up?
It's not overhead.
It's not overhead, slightly spreading. See? So, this is what leads to difference in
latitude.
With latitude beyond 23 degrees north and below 23 degrees north, you're never going to have direct rays from sun. So the maximum intensity is always going to be less than what you would have at tropical. Also, the minimum will be lower because of that. And which is why the difference in temperature that we see at temperate zone, and that actually decides the temperate zones. We'll come to that later, but now that we were discussing it, I have just
Tropical Cancer.
6 already.
So, okay, so I guess 10 more minutes. But then you have to quickly answer. Okay, so did you see what happened? Was it just inclination? If Earth was like this, concave, or any other shape, it could have been different. So it's both inclination and the shape. And we saw when we took the approximation of parallel waves, parallel wavefront. So it's sun is at a very far distance. Like Earth is huge. So when I'm standing at any ground, I think it's a plane, right? Similarly, on that, though in the flux case, we showed that spherical things, Earth is really small. It was not to the images were not to the scale. And there, parallel wavefront approximation works, and we can consider that if rays are coming parallel on Earth, then the same intensity rays, like the same angular distance would cover smaller area on Earth, where at 23 degrees, when the North Pole is inclined towards the sun, but at lower, at southern hemisphere, the same light rays, the same angular solid angle, the same solid angle coming from sun will spread over wider area on Earth's surface in southern hemisphere, which means the temperature rise over here would be lesser than the temperature rise in northern hemisphere, which is the reason why we see difference in temperature. And what happens in northern hemisphere we call as summer. What happens in southern hemisphere we call as winter. Most of the books apparently were written by people in northern hemisphere. So we call 21st January when this thing happens as summer solstice. But it's like who writes the book decides who the winner is. So otherwise they could have quite conveniently called it as winter solstice also. But you understand what's happening over here. Now, here I am just describing why that parallel wavefront work, but I hope everyone has understood. Right? So now what happens on the other solstice, that is winter solstice in northern hemisphere, which happens on 21st December. So quickly tell me what will happen. So anyone who felt earlier they were not confident and have understood now, try it now so that we check.
It's the same thing.
It's the same. So there'll be summer in northern hemisphere.
Summer in southern hemisphere.
It's the same but flipped.
Winter.
So now we have direct rays because sun is, see, you know the 4 picture position wala picture. I'm not repeating it again and again. So sun is somewhere here and now we are seeing the zoomed image of the other side of that orbit. And that's when the southern hemisphere is facing the sun. These two are not to the scale. These are 2 different pictures. And the earth is rotating, direct rays will fall on Tropic of Capricorn, whereas slant rays will fall on Tropic of Cancer. And this was beautifully shown by the presentation that you shared, the simulation. So after you explain this, if you show the simulation, students would appreciate that from ground, how do they see? So the rays are actually tilting and they can actually do observations also.
And that must be mentioned, it's a midday position of rays. I mean, noon position of rays.
So again, another thing that we had talked about is duration, right? So can you guess why the durations are different? Just from this picture, don't what do you see? We discussed at this point, right? If I draw a point here, every point concentrate, which is on the circle which is parallel to the equator, they will pass through this
light
circle, right?
Lit
So
part will be more.
maybe not so fancy, but I've tried to show that circle, this front side and back side.
Part is more.
So that is what is happening when spinning. So do you see the day this person over here is going to traverse this path in one day as the earth is spinning? What is more, day or night? Day is more. What happens here? These are not to the scale. I just made a very quick things. But if you go by actual Tropic of Cancer, dot the tropics and the Arctic circles, you would see that as we go further higher, there are regions where there would be no
night
at the southern, at the northern hemisphere in June, and at the same time there will be no daylight. Literally, people there close their windows with black things, what do you say, blinds, so that otherwise they cannot sleep day throughout. So that is what we can also show, and that also decides what the temperature would be. You see daylight for longer time, so the average temperature of the day is also sort of increased because of this. And then someone asked, what if the inclinations are different? What fancy things will be happen? Now, if you leave children with these questions, they will come up with really interesting answers to you, because now they know what's happening. Those were not facts. They've seen how it happens. And I would say give it a try. Okay? So we can wait and discuss it later, but I'll go to other slides which I want to discuss with you. So yeah, coming back to the same picture, this picture is quite loaded. And this is the responsibility of the teacher then to split it, break it into small pieces, help students appreciate those small pieces, and then bring them back to this again. Then they will appreciate. Today we understand it, right? But as a child, it's not easy. So see, textbooks have their constraints. But then we have more freedom in classroom. So, and then again, we can further go to do they experience same seasons in different latitude. So let me check it. So yeah, someone said no one mentioned of 6 breadcrumbs. So certainly different cultures have different way of nomenclature, but if you go to temperate zones, that is above Tropic of Cancer and below Tropic of Capricorn, what you saw there, right? That they never see sun overhead. So the temperature, the max temperature is not going to be the same as that at the equator or any thing in the band of between the two tropics, right? So their variations is more. So variations in landscape is also more, and that's can be deemed beautiful. But when you have to experience it, let me tell you, animals go in hibernation. So it's not a very pleasant time. Also, always sometimes it's also called blue, for the reason that it's not a dull time. See, now we have heaters and all, so it's still much better to live with those things. But otherwise, these are the things that the people in temperate regions have to bear with. Then in torrid zone, that is between the two Tropic of Cancer and Capricorn, we have seasons. It's like, see, different literatures also refer to it differently. Because some, if you're referring to some cultural thing, they might call it a 6 months. And in Indian calendar would say it's 6 seasons, 2 months each season. But typically we have in this belt dry and wet, and that's why we have summer and winter, and we have rainy precipitation in summer. So there are different, as I said, there are different ways of narrating this, but what we see is we certainly don't see this 4 season in southern part of India. As we go to higher up in north, we start going, see, Bhopal has Tropic of Cancer. So then when we go beyond subtropical, we start seeing these 4 season effects in India also, thanks to the wider span of latitudes we have. And at equator, there's not much variation in seasons. So it's like every day is the same. Perhaps. Yeah, this is something I got in one of the schools. So I've like stolen from there, but they had this display for students. So yeah, these are different representations, I would say. Some have divided these Earth calendric year into 4 parts. Some have done it in 6 parts. So if you look closely at nature, you do see variation even in tropical. It might not be the 4 season form, and that's why we do have the 6 season pattern: Hemant, Shishir, Vasant, Grishma, and Varsha and Sharad. So this is also observed in India. It depends on how keenly we observe that we see these variations. Then there are regional scales, we see that there are differences. I didn't get a good picture, but I wanted to show that even between Mumbai and Pune, there's a big difference in temperature, how the temperature variation is across season. As I said, I was very hopeful of coming to Pune that it would be winter here, but it was disappointing. And the reason is the mountains in between. So it's proximity to the sea, big lakes, mountains, landlocked regions, and cause variations in temperatures. But there's an interesting fact also that if you see, northern hemisphere is mostly land and southern hemisphere is mostly water. And what do we know about heating of land and
convection and convection?
Conduction and convention, but how quickly cools and
land heats quickly and releases heat quickly. Exactly opposite water. Water takes time to get heated and releases heat very soon.
Yeah. So can I say if it is landlocked, the variation in temperature would be more than when it is and when it is close to the sea, the variation is in temperature would be, or it's water more, the variation in temperature would be less. And that's why coastal India has equable climate and not extreme climate. But even the global thing, if you look at the numbers, we see this feature. So this is the maximum in winter minimums at northern and southern hemisphere, average of all the regions, and this is the maximum, and the year. The annual difference between the two. And we see in northern hemisphere, which has more land, the variation is more, and in southern hemisphere, the variation. See, this number is the difference between the max and minimum. So that is less because it has more water. It's more of a water. And this I'll leave right now. You can look deeper into it. So yeah, coming back to interdisciplinary. So first, did you enjoy it? Yes. It was tiring.
Yes.
It was exhausting.
Yes.
I'm pretty sure some things are still left. Is it? Do you have questions? Do you think there are some connections we are missing?
In fact, I mean, whatever presentations you prepared, we would like to see them also. So you should send it out.
Share it on the group, yeah.
Share it on the group so that every one of us can actually take a look. Okay? So that would be really useful. In the end, we would like you to design things together. Like as a group now, you have come together, you know each other, so try to design with each other, and that hopefully will help. Okay, everyone.
See, and if you're trying something, I'll come to that now as to why these things were taken. It's an experimental research-based thing. So we talked about interdisciplinary, we connected only the STEM topics, but you remember the list we had in the beginning had more things. So certainly, if the foundation of it is stronger, it becomes easier to understand the topics which are covered in geography as well as different subjects at latter year, and also preparing the students for the next burning concerns that we have. So this study was part of, I'll take this 3 minutes more. Okay. So this study, interdisciplinary approach for teaching. So real world issues, whichever phenomena we take, is not compartmentalized into disciplines. But we have also compartmentalized ourselves. I meet someone, I say I'm a physics person. Someone said I'm a chemistry person. See, this is so natural for us that we think, and our way of thinking is also framed by those disciplines. How I approach a problem is also getting framed by it. And somehow we are those in the classroom, we are opening space and breaking the walls. As trainers, we are still in that compartmentalized zone, and somewhere we are trying to break it.
That's the strength of us.
Strength as so see, that's what we are trying to do. I agree. But even at higher college levels now, we see these walls are breaking. They are opening, they call it multidisciplinary, so depending on how it is being implemented, or interdisciplinary. But ISAs and big institutes are now saying that we cannot work in silos. We have to work even for research, even for higher education. If we want better students for research, higher education should get interdisciplinary, and it should further go down and see. We should see how students could be trained at school level also, and there is so much of scope, as you all are aware of. So interdisciplinary approach helps understand small intricacies. And one of the things that I've been discussing with you people, some of you, is like, see, interdisciplinary approach doesn't come standalone, it comes interlinked with some things. So what is it? That we use so many things, right? There was embedded learning, we were using problem-based also, activity-based also. So everything was used, but imagine it to be done in one single classroom, and it being distributed across different classrooms, subject classrooms, where you rightly said that subject expertise brings strength in that subject, right? So we can get that those teachers can take the students into deeper understanding of those subjects. So the idea is teachers from different subjects collaborate to teach a single and ensure that some of the concepts are taken care of. But what are the challenges in it? I request you, because some of you have already been trying interdisciplinary teaching at whatever level, do write to us about, we'll also share a post-test of this, which will be mailed to them. Is it okay? Will you fill up the form and tell what your critiques, feedbacks, and appreciation for it were, for the method? And because I might have my limitations of delivering it, but I'm talking about the methodology as to if these things are to be implemented, what are the things that need to be supportive for those changes is what I would like to know from you. And so standardized assessment, many things like, see, we can do all fancy things in classroom, but at the end it's like test. If they are not changing, you know, we cannot have more freedom, degrees of freedom. And then there are time constraints, which it does take a lot of planning work. Support from school administration. So quickly, this is last slide. So this work is part of NIUS project. I have to acknowledge my colleague who has been working with me. She is a NIUS student. NIUS is a program for undergrad students in HBCSE, where undergrad students can come and carry out projects in science, maths, biology, and even science education. One of the students, Lauren Halal Hill, has done this work. She went through the textbooks, identified the places where we can use interdisciplinary approach, and it is not restricted to season. Even the topics like stars could be discussed in a similar fashion. And we are also trying to, some of the things I could not discuss in this classroom, as to how we can use other tools for lesson planning, which can help us ease out this interdisciplinary implementation of this interdisciplinary approach. And we are like trying to think of how we can generalize it to extend to different topics also. So whatever feedbacks you are giving is going to help us, the ones which you give by filling up the form, as well as later on also. If you try it in your classrooms and you want to share your experience with us, do let us know. Yeah, this is time. So
yes.
Question.
Yeah.
Mike. Oh.
Have you eaten?
Wait.
Actually, I have some doubts or some questions. This question, I thought this might be chewing gum for all the teachers while we are going out from this classroom. So my question is, we know some planets are tilted, some they didn't tilt. Why all the planets are not tilted? If we see 3 planets, even Jupiter, Mercury, Venus, they didn't tilt. But other planets are tilted. Suppose who tilted the planets? Which caused the tilt? Suppose if we say the gravity makes the tilt, means then why it could not do for all the planets? Only few planets are tilted. Suppose if you want to tilt any body, means then we need to give some external force over on it to tilt the body. But the planets are tilted. So which fellow tilted the planet? And suppose another question. If the moon, ma'am, there are one more question. One more question. As we all know that moon came from Earth. So if moon came from Earth, means Earth is tilted about 23.5 degrees. Why moon didn't tilt? Both are coming from the same. Then Earth is tilted. Why moon didn't tilt? Both are coming from the same, means then they should have should be a tilting. No. The moon should tilt, but moon didn't tilt. That's the reason.
Question. Maybe because it was already covered in our class.
Yes, so if you remember the history that we showed, so it basically depends on the history of the planet's lifetime. So basically, generally they would not be tilted. But if there is a violent event that happens, like something if a tree is standing, and if some storm or tornado has come, it might tilt the tree. You have seen this everywhere, right? Or if an elephant like pushed it a little bit, the tree would become tilted. So you are completely right. You need an external force to tilt the planet, and this only happens in certain situations, like it happens for Earth, like we showed in that simulation video, that another big body hit the Earth. And at that point, Moon was created. So Moon itself did not get hit after it got created. That's why Moon is not tilted. But Earth did get hit, so Earth becomes tilted. So it's a very complex process of if you see any planet, why it is or it is not tilted, you have to do very detailed simulations of what might have happened for the past 5 billion years from when the solar system first formed. So it's a very complicated dynamical problem that scientists still are trying to solve for different planets.
Different planets are tilted in different angles.
Yes, because Earth got hit, but like Jupiter did not get hit. Yeah, so like
space.
It's a huge, yeah, the space is very huge. So I mean that histories are different for different planets. So we will be giving you some books. There is a Big Ideas book, which is about the essential concepts of astronomy. You can use this as a guidebook. And then this is a book by Astronomy Society of India. This is about the history of Jantar Mantar. It's for kids. It's like a cartoon book. And we have some copies in English and some copies in Hindi. So you could choose either.
Please take one.
Please take one. Yeah, and this is our post-workshop survey. We really want you to take it to measure the impact of our workshop. It's the same questionnaire, but if you can scan it, and in that time we will come and give you the books. Okay? Just to manage time. Oh, and when you leave, if you want to give us some feedback, if you liked it, if you didn't like it, you don't have to write your name. Any comments you can write on the post-it notes and just put it. And we would like to see what you thought of it. We don't want to keep this online because too much online things are happening. So this will be here.
Oh, yes. Thanks for
Actually, we are very grateful to the IUCAA team. We had requested through Dania ma'am. They accepted us from other state to attend the workshop. So first we are grateful to them. Next, they have given us some materials in Tamil. We are only 10 people, but they prepared material for us. So we have to show our grateful to them. Thank you so much. Thank you to the team. Thanks for providing this workshop. We enjoyed, we learned, we had many people to meet here. Thanks to all. Thank you. Anyone wants to say or have any questions? So I would give vote of thanks to all the people who have participated in organizing this event for the welcoming gesture, and most important thing, being grounded. Like we never felt that we are in front of such people and everything, and we had that forum where we could ask questions. That atmosphere creating that culture have made us at that space where we could ask questions and clarify our doubt. Really lovely gesture. Really appreciate. Love the food also. Thank you so much for everything and for giving this as a package.
It's always a pleasure to invite teachers and have students around us and talk with them and interact with them. We often do not get that much to interact with school teachers at least such a level. And there are things which we may have done well, things which we may need work on, and of course, as you keep learning, we also keep learning. And hopefully in the future, we can make these kind of teacher training programs better. And so that you can get more and more out of it. Okay? So what we are going to do is all these, all these slides that we had prepared and we had shown, we are going to put them up on the website so that you can take a look. I have done a recording on YouTube or the streaming on YouTube. So that will also make available. Of course, it will have some gaps and so on because mics are not present, and so it may look a little bit odd, but hopefully it will be useful. Okay. And then finally, of course, I want to thank all the speakers here who came. I mean, Nokia put in a lot of work. Pritesh as well. Then Asmita, and then you had heard from Pritesh yesterday and Sai. One of my PhD students, actually, he also came over here and helped out, even though it was, I just had mentioned that there is this kind of a thing that is going on. So many thanks to Snehil. Yeah, thank you.
We can get the PDF on our WhatsApp group.
Yeah.
If we can get the PDF over there, just the PDF.
PDF of what? Presentation. Oh yeah. So I'm going to, it is there on a website that I will put. I will send a link to the website so that you can download everything. Because these PPTs, etc., they are huge. So, PDF that will be. Oh, to who? Yeah, we will do that. That's not.
If you want to give your travel allowance form, please give it to us. The homework also. If you want to give the homework, also give it to us. We will
Good evening, everyone. May I have your attention, please? Just 1 minute. Yeah, formal vote of thanks. Okay. Very much thank you to this incredible team of OAE and the wonderful insightful platform what they have provided us for this 2 days teachers training program. It was such a great workshop and we enjoyed a lot, right? So they have taken us to this wonderful cosmic journey full of geography, maths, astronomy, physics, astrophysics, and everything. So we expect the same workshop not once in a year, but twice and thrice in a year on different topics at different levels. And one more thing that like if we really collaborate with all you people for such great developments. This 2 days workshop was really a great development for us, for like professional academic growth for all of us as teachers. So if in future we collaborate and collaboratively if we do something kind of a research on student level, so under your mentorship and guidance, so that will be a great platform to our students also. So I would like to give this a small gratitude, appreciation, and thank you later from my management desk to the OAE team. Thank you very much. Thank you, Surut sir, Mopia ma'am, Asmita ma'am, Kshitij sir, and yesterday's who was it? Pritesh, Sai, and Shivani. Wonderful it is. Thank you very much.
Yes, I would like right now.
அதை வச்சுட்டாங்க அந்த பேக்ல வச்சிருக்காங்க.
So, if any of you wants to visit IUCAA students or anyone, psycho.gmail.com, they do many events.
Yeah.
And all events are free.
Oh yeah. Oh, you have signed it.
Please give us sort of.
Yep.
We have not got it.
Yeah, we'll come to everyone.
Okay. They're coming.
Excuse me.
If somebody's phone is here, please, it's for charging. Take your phone.
Yes, yes.
Have you got it?
No, today. Yeah, sure.
Yes.
पिंक होकर आई है
It was going to fall.
She has not.
Hello. Bye. Keep in touch.
I'm here.
Nice talking to you.
Happy and safe journey.
Just keep it safe while
Take care. Express and Poland lang. Express Poland lang.
Yes, ma'am. Marathi good.
I mean, when you
I will try as much as possible. Sorry?
बरोबर बरोबर ठीक आहे माझं झालंय मी थांबते
No, so I asked multiple questions, and unfortunately, it's not so. I don't know what.
I found it. I will have that a lot. So please promise. It's saying how many days it will take.
If it's
So many things and
Who else is there? You got it? You guys got the everyone done?
Yeah, so cypop@gmail.com.
You've got the book?
Yeah, sure. Done. Great.
Sure. You've got the book?
You got the book?
Yeah.
Once you write to them,
because they will
then
give you.
I mean, it all depends upon the time availability and so on. But once you write to that address, then they can at least ask multiple, not just one. Right? Because if I get from all 40, then it will be difficult. So you write to them, they call coordinators, and then they can say that okay, maybe this person can go. We got this request. Then it gets divided. I mean, it all. This is about teacher training program. Teacher training programs happen, but not maybe at this kind of a level. So there are teacher training programs that are cyber people also. But
We aim for one teacher.
I will send. I promise.
You might also attend, but unfortunately, they come here.